Our first speaker this morning is the MOVES Director, Dr. Imre Balogh. He will speak on the state of MOVES.
Thanks, Barry. All right, good morning, everybody. I'm glad to see we have such a good turnout. This is the first post-COVID in-person open house we've had, and I'm really glad to see that there's such a good turnout. We have a lot of people here representing the M&S community, a lot of students, both current and former, so they understand what we do. We also have representatives from stakeholders in the DoD and industry representatives. And so one of the things that's really important is for us to build better connections to industry out there, because after all, industry is essential in using M&S successfully in the DoD. So I want to thank and welcome all of the industry reps to our open house. Hopefully the next few days will be beneficial to everybody. And I look forward to learning a lot about what people are working on and hopefully educating everybody on what we've been working on. So today I thought I'd start by refreshing and talking a little bit about the NPS mission, because ultimately the NPS mission is what defines what we do. And so there's a couple of key elements to note in the NPS mission statement. The first is that we are an educational institution. So ultimately what our mission is to educate. And particularly, it's education of defense-related issues, teaching people on defense-focused graduate education. So that's what our mission is. And in order to be able to be an effective graduate institution, we also need to do research. So people need to understand that research is an essential part of what we do, and it's part of our education mission. It's needed to support the education. You can't have a viable graduate degree program without a robust and diverse research portfolio. So research and education go hand in hand, but we do more than just research to support education. We also do research to support the fleet and support our other stakeholders. So it's important to understand that all of these things work together, and the way NPS functions efficiently is to be able to make all these connections. So given the NPS mission, how does MOVES fit into all of this? Well, again, can't have a presentation without talking about our mission statement. And if you look at the mission statement, it pretty much echoes what the NPS mission is, with the modification that it's more restricted, that we focus on modeling and simulation related topics and subjects. So that's what we're doing. And it's really critical in our work to make sure that the education program we have is relevant and current. And the way we do that is through our research programs. And so what we've been focusing on is getting into more wargaming. Of course, we're doing all the different modeling and simulation technologies. And the research then supports the curriculum. And I'll talk a little bit more about that later. So the other thing I need to mention is the fact that over the past couple of years, we've been starting to work more closely with industry partners, because industry is essential, as I said at the beginning. And for a long time, we were relatively isolated from building good connections to industry. So this has been one of our mandates at NPS, is to strengthen this. And I think at MOVES, we've been doing a pretty good job of this. So I'm going to talk a little bit about what we've been doing and what's going to happen, what's going on with MOVES, and what I see as the future for MOVES. So I want to highlight some of the programs, some of the things that we've done over the past year or two, and to give a feeling of where we're going, where we've been, and our successes, and what I think the future is going to hold. So I'm going to open up talking about our LVC lab. I think that this has been one of our big successes. We essentially started building the LVC lab back in 2019, and we've been growing and expanding it. The Marine Corps helped us get it set up initially, and since then we've been expanding and growing it. And the function of this is to make sure that the students we have get a good experience with LVC. LVC is currently one of the biggest topics in the DoD. The Marine Corps and the Navy talk a lot about it. The CNO has mentioned LVC in different guidance documents. And so it's essential that our students be well-versed in how LVC works, and the lab is critical in making that happen. So we use it both for research and education. So the education part is we have a lot of simulations and a lot of other technology in the lab that allows the students to get hands-on experience with how LVC works. We also use it to support research to better understand how interoperability works, what are the issues, how that can be improved. And one of the things that the main thing that we're working on is expanding the reach of the lab. So we're working on building proprietary connections between other labs and our lab so we can address more complicated problems. We've built a network that goes to the Defense Analysis has a lab here on campus. We have a network connection to them to allow the special ops students over there to work with different simulations that we have in a collaborative fashion. We're also working on building a connection down to Redstone Arsenal. That's where the future vertical lift is headquartered, and building out the ability to run LVC type exercises across country. That helps our research, and that also helps our ability to do education with our students, to look at real world problems, the things that you run into once you start getting larger and longer network connections. I just wanted to mention one of the places where we've been very successful. We've been supporting the NATO's Coalition Warfare Integration Exercise, CWIX, since 2018, in part using the infrastructure we have and the knowledge we've gained in building our LVC lab. That's one of the big exercises that NATO runs to understand and improve their interoperability capabilities. And so we're working on that. Actually, right now, we're preparing to support this year's iteration of that. And the goal with the LVC lab is to move towards what a term that we've used is called a living lab. The idea is to look at the lab not as a laboratory specifically, but more as an environment that can be used for doing different types of experimentation and research in environments where you need to have network enabled technology and systems. So the goal of the living lab is to become a resource across campus, and then ideally, in the broader space, where people can come together and do research and investigate problems tied to any kind of topic that requires network interconnected technologies. So that's one of our big successes. Next topic, AR, VR. This is another component, a significant component of our research. After all, virtual is in our name, so AR, VR is a critical part. We've been quite successful in having some student engagement in this. We've had multiple theses on AR topics, both in the both in the MOVES program and also the CS MOVES track. And what we've been doing with AR is expanding the range of problems we want to look at. It used to be that the focus of AR or VR research was on the technology itself. How do you do AR? How do you make an AR system work better? How do you employ? What kind of software you use? But we've come to realize that that's only a piece of the problem. And I can have really excellent AR or VR software and good applications. But if I don't have data, if I don't have the infrastructure to drive that, then I'm really hobbled in being able to adopt and make use of that technology. So what we've been working on is the full spectrum of problems that we want to address to make AR and VR possible. So some of the examples of the things that we started looking at is the question of content creation. How do we effectively create content to be used in an AR or VR environment? So
I just want to share your screen so people on LinkedIn can see it, or not LinkedIn, but Zoom.
Okay.
So excuse me.
All right.
Sorry.
All right. So anyway, so the work we've been doing is looking at this full range of problems. So how can I effectively create 3D contents? How can I build 3D models effectively? Traditionally, if I want to do an AR or VR representation of the real world, I need to use some sophisticated technology using some sort of LiDAR scanner or something to get data, or need to have CAD descriptions and drawings of the system. Well, the goal of our work is to look at the whole spectrum. What can we do? So how can we efficiently use current technology to rapidly create this 3D content? And by 3D content, it's not just simply the 3D models, it's also the entire process by which I use these AR systems, or AR and VR systems. So we're doing a lot of work in that space. And we're pushing the boundaries on how that works. So that's the goal of us, is to create ultimately an environment and do work that addresses the entire end-to-end problem. And we've been quite successful in doing this because we're actually pushing the limits on what can be done. And this work has resulted in patents. So in the past year, we've been granted 2 patents related to AR technology. And currently we actually have 6 other patents in process. So we've been working with other organizations like NAVAIR, NAVWAR, and NAVC. So this is a broad reach program, not just something within NPS. And I think we are really pushing the limits, which is very encouraging for us. And hopefully we'll be able to build on this success as we go into the future. AR, VR, I'm sorry, AL, ML, enforcement learning. Another area that's been growing and it looks very promising for us is getting into how we can use machine learning techniques to train agents inside simulations to behave in a more useful way. We're focusing on how to develop systems that can learn tactical behaviors. We've had a lot of student involvement in this. So there's multiple theses that have worked on this. We actually even managed to brief some of this work to the commandant a couple of years ago, as you can see in the picture there. So it's very promising work. And the goal here is to have better agents that run in our sims. One of the difficulties in closed form or any kind of simulation where there are entities that are controlled by the computer is to try and make the behaviors realistic. And a lot of work goes into that. The goal with this kind of work is to take the burden of that kind of development off of humans and have the computer learn how to do these different types of tasks. We can imagine using this, make our constructive simulations better, could be helpful in wargaming because we can then use different kinds of, we can use the AI to help the wargaming adjudication and development. We can also, one of the things that looks promising, and there's been some examples where these techniques have actually developed novel new ideas of how to solve problems, creating new tactics. So as we come in with all these new kinds of systems, the idea is that AI could in fact discover better ways of employing it. So either better ways to employ systems that we already have, novel ways we haven't thought of before, or as we start bringing more technology in, maybe AI can actually help us discover better ways to use these new systems, things that we haven't thought of. So again, a really promising track for us. There's some way, let's see. The next sort of big event for us, one of the things that we've been working on is doing cooperative agreements with other organizations. And one of the big successes we've had here at NPS is the collaboration with Microsoft. So a few years ago, about 3 years ago, we started talking to Microsoft of how could we work with them in partnership to understand and leverage all of the technological expertise that Microsoft has and bring that in to NPS to help us address and solve fleet problems. So we've been working on this for a few years and culminated last fall when President Rondeau and a group of us from NPS went up to the Executive Briefing Center in Redmond and talked to them about all the different places where there's overlap in the interest of Microsoft and NPS. And that meeting ended up resulting in a CRADA that was signed back in February for us to develop, to have a close working relationship with with Microsoft and NPS to address different types of problems that the fleet needs to address. Now, as we were going and starting to set up this agreement, we recognized that there's a large space where we can work together. But to get something going, we wanted to focus on something more tangible, more identifiable. And the big problem that came up, or the space where it looked like there was a good opportunity, was to work on problems that we have been told we should look at, or we've been asked by compact fleets to look at. So we've been, we meaning NPS, has been in dialogue with PAC Fleet for a while on how can NPS be more effective in supporting actually the operational fleet. And from those discussions came a bunch of problems that we thought that this CRADA could possibly potentially address. So the Microsoft CRADA has 4 initial projects. Like I said, the idea of this agreement is it's a long-term, it's envisioned to be a long-term relationship. But to get things started, we wanted to pick some topics where we could get going fairly quickly. And so these 4 projects were identified as the initial ones that we're going to work on. So the first one is something that's being done with the Space Systems Academic Group. And the idea there is to look at how we can leverage cloud-enabled network technology to build better ways of connecting and better ways of leveraging different types of communication problems and data problems using the cloud-enabled networking. So that's one project. The second one is the Campus of the Future, which is kind of a completely different track. The vision there was that how do we use technology to do better education? How can we teach people more effectively by using technology? And so the Campus of the Future is oriented towards looking at the technology. Microsoft has been working a lot in the space of distance learning, distance collaborative environments. How can we leverage that technology to improve potential future of education? Another thing that kind of prompted that is what happened with COVID. We learned and we kind of got force-fed a lot of issues on education. How can you do education in a distributed environment? So that's what kind of drove the Campus of the Future. And that's what the focus of that is, to build a vision for what the future campus could look like that leverages technology, that leverages the advantage of doing things in residence, and also the advantages of distributed. How can we bring technical knowledge and education to a broader range of people? Not everybody can come to NPS to get an education. How can we share our educational capabilities with a broader environment? That's the goal of Campus of the Future. I'm going to skip the fourth one because that's the main one that we're working on. The last one is the most tentative of these. The idea there is to look at how technology from Microsoft and advanced technology can support field exercises. So we have every quarter we have a big field exercise down at Camp Robbers called GIFIX, where a lot of technology and a lot of experimentation is done. Problem is that that's somewhat isolated. Data from that is hard to connect to the rest of the world, hard to leverage. The question is, can different types of technology, say available through the work with Microsoft, enable that to be better integrated into the fleet? So that's the fourth one. The 21st century gaming and experimentation modeling and simulation track is the one that we in MOVES are most closely involved with. We're the lead on that. And the idea there is to look at literally all of the stuff that's been developed in the gaming world, all the things that comes with the gaming world, and how can we leverage that to better support the fleet in a broad range of areas. Microsoft has committed a lot of resources to getting into this space. They've set up a game studio that's specifically focusing on this class of problems. So what we were looking for here is, what is a problem that we can address together as a team that is relevant to our sponsor, in this case, the sponsor is Pack Fleet, to make use of what Microsoft has to offer. And so what we're focusing on is wargaming. And so the question with wargaming is, how can we essentially modernize wargaming? This all came out of a request from Admiral Paparo, basically saying, what does 21st century wargaming look like? If you look at wargaming, the way it's run today, the way it's done, say at the War College, the Navy War College, sorry. It's very similar to the way games were run back in the 30s. So is there something we can do with technology to improve that? So that's what we're exploring. This recognizes that the type of classical war games will always have a very important role. They have a lot of really good characteristics, but there's a lot of types of questions that people use war games for today that might be better answered if it was technology enabled. So we're working with Microsoft to explore this space, to develop tools to make it more efficient to create games, to make it more efficient to run them, and also make it more efficient to get the results. The guidance we had was, currently, it takes months and months to set up a game. It takes a long time and a lot of people to run the game, and then it takes months and months to get results back. How can we speed that up? And so that's what we're looking at with Microsoft. And we're working on an architecture, a framework, essentially, that we're going to demonstrate in I think it's in late July or early August to Pack Fleet, to show some of the ideas of how we're going to work on this. And it's critical to understand that technology needs to be helpful in this. One of the things that we're looking on also on campus, how to help with the adjudication problem. Adjudication in wargaming is one of the big problems, because right now, normally the way it's done is some subject matter expert makes a decision on the outcome of some type of interaction. Problem is, and this is what triggered all this discussion, apparently a few years ago, there was an exercise or a war game run, and whoever did the adjudication totally underestimated the capabilities of some new technology, leading to a very unpleasant outcome in the game. And so how do we make it better? How do we make this process better? What can we do? So that's kind of the vision of what we're doing with GEMS. Another, again, trying to talk about the things where MOVES has an impact on NPS and on the work we do, interdisciplinary effort. We're an interdisciplinary organization from the start, but we've been really working hard to expand our footprint and to play a bigger role in interdisciplinary projects. So over the past few years, we've been doing more projects. We have multiple projects. Some of them will be briefed here, where multiple departments work together. So we've been quite successful in working on that. And I wanted to sort of mention one particular effort, interdisciplinary effort that we had, which is the Center for Additive Manufacturing. MOVES faculty played a critical role in setting up the Center for Additive Manufacturing. And that has snowballed into a lot of success. Initially, this group of faculty that came together worked with Xerox and created a CRADA, where we got one of Xerox's first metal printing systems. So we got a very sophisticated metal printing system so that we and our researchers on campus can look at the full range of issues of how to use these kind of systems in the fleet. And actually right now they're working on how to deploy one of these printers actually on a ship, putting it on, I think it's on a large deck amphib, and to see, will this work? How well will it work? It's a really, really significant development. What followed from that was ultimately working with Xerox, we ended up securing a $50 million appropriation from Congress to create a consortium for additive manufacturing that's going to be focused on adoption, right? The question is, okay, we have all this ideas of additive manufacturing. How are we going to take additive manufacturing and make use of it in the fleet? What's the right use? Well, someone needs to bring all those different efforts together, and NPS is going to be leading that. So that's one of the big successes on campus. And the reason I mention it is because MOVES has played such a critical role in making all that happen. So we like to think that our goal is to bring people together, and this was a really good example of that being quite successful. So I'm almost at the end here. So what's the future? But before I can talk about the future, what's going on? What's in our context? How is the world changing for MOVES? And the big thing for us is the changes at NPS. NPS next up there, the logo, is our big effort. This is NPS's effort, essentially to reimagine what NPS is. How does NPS become more responsive to what the fleet needs are and make sure that what we do really impacts and supports what's going on? And so ultimately, the goal is for us to refocus on what the fleet's needs are. So this is at times in a little bit conflict with the typical academic kind of view of the world. The typical academic view is we do research, hopefully it's useful. Now we want to look at problems that we can map them more directly onto issues that the fleet need. This is not to say that we're not going to continue doing a lot of the research we've done and a lot of the basic research we've done, but the idea is to be more cognizant of what is the impact of the work we do. How do we make sure that our research and our education really is relevant and really addresses the needs? This week, we're having the MOVES curriculum review. The idea behind that is to ensure that what we're teaching to our students is relevant. Our job as academics is to make sure that it's academically valid so that the students have the right background. But the fleet's responsibility is to make sure that the way we do this and the information we convey helps them and helps the fleet in becoming more efficient. So a lot of the refocusing that's going on at NPS, MOVES has already been moving in that direction, but there's all sorts of organizational changes within NPS that's going to impact us. And the thing I need to mention here is the Naval Warfare Studies Institute. The NWSI was an organization set up a couple of years ago with the mission of trying to coordinate all of this. So the NWSI can be seen as kind of the one-stop shop of if you want to interact with NPS, whether on an educational realm or on a research realm, their job is to be the people who understand all the different disparate research efforts and education that's going on campus, and be able to hook people from outside NPS with the right people. In the past, it was hit or miss. If you knew somebody at NPS and you had a project, you could find something. But if you didn't, it was hard to connect. The goal of NWSI is to facilitate those kind of interactions. So the way NPS is changing is going to impact moves and how we go forward. The other thing that I wanted to mention that's been a fairly significant change that's going to impact our future is changes in the management structure of M&S in the Navy. A couple of years ago, the enterprise lead role went from the previous organization to the chief engineer of the Navy. And so an organization that's in some ways more engineering focused, more research focused. And so that has led to a change in leadership, which is going to change how we work with the Navy. We've been working closely with this new leadership, built fairly close ties. So I'm really looking forward to that relationship growing, because it's going to be essential for us to really make a significant impact on the Navy. And again, it's interesting to note that Mr. Mann and Mr. Lloyd, who are the leadership, who are the new leaders in this new organization, are coming out and visiting us this week. It shows the degree to which the Navy is committed to what we're doing out here at NPS. And so to wrap up today, I'm going to talk a little bit about the future directions of moves. Of course, we're going to continue doing what we've done and the things that work for us. We're going to continue expanding our ties to the fleet and industry. We have connections both large and small. Like I said, we connect with companies like Microsoft, but we also have a lot of small companies that we're working with. We want to continue expanding that. The position of moves in this reorganization of NPS is going to change a little bit. We're going to be playing a bigger role in M&S. Part of this revisioning of the entire structure of moves is to focus on 7 key areas, and one of those is modeling and simulation. So we're going to play a bigger role in how modeling and simulation is used throughout campus. And one of those changes is going to be reflected by that the Moves Institute director is now going to report, or will in the future report, to the provost's office directly. So currently, I report to the chair of the CS department, but in the future, that position will be reporting to the provost's office. So it's a higher visibility position. And I think that the biggest thing, and I'm just going to close with this, the biggest thing that we're looking at, and I think is going to be an important part of Moves' future, is how do we expand our educational offerings? I mean, one of the keys of the entire NPS Next vision is how do we make sure that the broader DoD and broader Navy can take advantage of our educational capabilities. So clearly what we need to do is create modalities of education that go beyond the resident. We can improve, make better resident education programs. What are the things we can do to support the broader fleet, both the officers and the civilian workforce, and to educate them in modeling and simulation. So I will be stepping down as director come probably September. We'll have to see how that, whether my replacement is found by that. So this is my last address as director. But I think that the future of Moves is really promising. There's a lot of support we have, both from the broader fleet, from the Cheng's office, and we have a lot of support here on campus. So I really do think that the future is bright for NPS and for Moves inside NPS. With that, do we have time for questions, or shall we? Are there any questions? Anybody? Any questions or comments before we introduce Mr. Hoffman, our keynote speaker? Yeah.
I was wondering, so in your GEMS initiative with Microsoft, how do you see that interfacing with the Marine Corps and their development of their gaming center there on Quantico? Does this sort of activities that can support each other?
Yes. Actually, Microsoft is involved with the Marine Corps Gaming Center. So yeah, we view this, the entire idea with Microsoft is to try to start something where we can have some wins fairly quickly on to build a solid foundation and then expand out. You know, one of the areas we're probably going to get into is more AR with the HoloLens and things like that. So we're looking at that. But yeah, that's definitely one of the things we're working on. All right, well, thank you, everyone. Thank you. And I hope everyone has a good and productive 3 days.
Thank you very much, Imre. Today, we're honored to have an outstanding speaker as our today's keynote speaker. Mr. Douglas Hoffman is in the Senior Executive Service, and he currently serves as the Director, the Operations Analysis Director at the Headquarters Marine Corps, Combat Development and Integration. And that mouthful is generally more referred to as OAD, CD&I. There he leads the largest group of operations research analysts, both military civilian, in the Marine Corps. He is also a member of the Senior Advisory Group of the Analytic Federation. Mr. Hoffman oversees the operations research analysis portfolio of OAD that includes the formal Marine Corps study systems, many command-driven shorter-term requests for support, oversight of the 8825 and 8850 occupational fields, the 1550 community of interest, and support for forward deployed analysts. The 8825s and 8850s are very important for us because our graduates become 8825s, the MOVES graduates, and our OA graduates become 8850s. Prior to this assignment, Mr. Hoffman led the current operations analysis support team within OAD, where his daily mission supported forward deployed analysts and their respective deployed forces. During Mr. Hoffman's tenure, they deployed more than 40 analysts to many different countries, including Afghanistan, Iraq, Djibouti, Bahrain, and Okinawa. Mr. Hoffman himself also served as a forward deployed analyst in Operation Iraqi Freedom in 2003. Prior to working for the Marine Corps at Quantico, Mr. Hoffman performed military logistics related analysis at the Joint Warfare Analysis Center and Systems Analyst Division of the U.S. Army Industrial Operations Command. Mr. Hoffman graduated with a master's degree in National Resource Strategy from the Eisenhower School, formerly the Industrial College of the Armed Forces, in June 2007. He earned a master's degree in operations research from the Florida Institute of Technology, and his undergraduate degrees in applied mathematics with minors in computer science and Spanish at Clarion University of Pennsylvania in 1995. Please join me in welcoming Mr. Douglas Hoffman.
Good morning, everybody. Good to see you all. So, General Heckel, so Deputy Commandant for Combat Development and Integration, was originally invited to come out here and provide the keynote. It is congressional testimony season back in the DC area. So that's occupying his eventful days when I come in the morning, and his truck is there, but his van is gone, and it doesn't return until later in the afternoon with a man walking in, just kind of shaking his head and muttering under his breath. But he sends his best out here. For those of you who will be attending Morse, he'll be the keynote speaker at Morse. So get an opportunity to hear about his perspective, especially fleet perspective, and then how it relates to how he deals with analysts. So I'm one of those guys. So underneath there are typically 4 different groups underneath General Heckel. So Capability Development Directorate, my counterpart is General Eric Austin right now. So a 1-star for CDD, developing the capabilities. My other counterpart is the Marine Corps Warfighting Laboratory. Currently, Major General Ben Watson, I'm going to be turning over this summer. So he does a lot of the future looking things. So you see a little bit of force design and a little bit of force development. Marine Corps Systems Command doesn't fall under General Heckel, but like last week or 2 weeks ago when Modern Day Marine was underway in the DC area, I was invited to participate in the panel. So it's kind of interesting starting at the panel. It was General Heckel at one end and then going through the 2-stars, the 1-stars and then down to me. And when they talked about their mission set, I was able to basically say, and I do the brunt of the analytics that supports all those guys. So that's what OAD, and I appreciate the very kind introduction. What we do in OAD is operations analysis for the entire Marine Corps. So I take very seriously CD&I, combat development and integration, and I lean heavily into that integration. So constantly as a team, whether it's across different analytically joined organizations through like an analytic federation, or simply across the other organizations and deputy commandants in the Marine Corps, we're constantly looking left and right. And we do a deliberate studies system where we reach out to those folks and understand what they need. Brett's actually been able to work some of the LVC TE stuff for training and education command. But then as you heard from my introduction, we look from a fleet down to, or from a headquarters down to a fleet perspective. So fortunately, I kind of got the itch with, I'm straight out of college. I never wore the uniform, but I got the itch for current operations pretty early on in my career at OAD as a deployed analyst. And then that turned into a 10-year love affair where we were able to push out 40 plus deployed analysts. I think our numbers are in the 60s now. And we've only had 2 gaps, and that was due to COVID and turning people over. The majority of the work, the good things that get done with for General Heckle and for the Marine Corps with M&S are because of Brett Telford, John Watson, and Captain Courtney Thomerson over there. They are the folks that make everything happen. I just hopefully am somebody that will impart upon you some knowledge that's useful today. So I'm going to talk about, I'll probably pull my bottom line up front. I'll just give it to you. So if you want to zone out, then you can do that. So I'll just pull those distillations forward. It's important that you're here. And I know, especially in a period, so I've had, for better or for worse, I've been at OAD for almost 20 years in October. So what I saw was the period of time where Marines were able to put their hands in the air and volunteer for the different special education programs. And then I saw the transition when folks were voluntold. And I understand a lot of the angst that comes with when a Marine is doing well. I don't understand it. I hear a lot of the angst when a Marine is doing well in their MOS, and because they were outstanding in perhaps their undergraduate education, they get picked and they get sent out to Naval Postgraduate School. There's a lot of frustration. I would offer that I'm sorry, but it's important that you're here. What I'm going to try to show using the backdrop of force design today is where we as the M&S community, we as the operations research analysis community, we as the subject matter experts, we all have a role here. And Dr. Balogh just couldn't have laid it up any more perfectly for me. The things that are happening, the educational things here at NPS, I'm going to try to give you an idea why those are important to changes in the Marine Corps, in particular, the Commandant's planning guidance and a little bit of force design. So the key thing is there's a reason you're here. It's important, and you are going to make a difference when you get to the fleet, or when you get back to a B billet and to the fleet. The promise is it's going to be frustrating, right? In Doug's opinion, the Marine Corps is a very intuitive service. There are a lot of people, and I hear this in the 2 and 3 star levels I work well. I just know it's that way. I just know it is. It's based on my experience. And so the Marine Corps right now, courtesy of General Berger, is going through a rapid transformation where he's basically ripped things apart, and now we're reassembling them. What opportunity, never before have we seen such a plan and an opportunity to change things in the Marine Corps that we see now. And that's the modeling and simulation community. So what the things that you showed, how things are becoming more and more important to the fleet that are analytically driven. General Berger laid out a plan for the Marine Corps. I'll hit a little bit of it. I'm not going to brief you on the Commandant's force design, but this brief is here with the team. It's got some details in the back that we analysts like to see. It'll show a little bit of like the force element changes that we're seeing in the Marine Corps. But what I want to do is weave the themes of the Commandant's planning guidance, and in particular force design, where I think those opportunities are, and they're rich for the entire M&S community, analytical community, knowledge management community. We already heard that. Now what's really driving the changes is my DoD career is about 27 years deep now. Never have I seen a premium on knowledge management finally that I'm seeing right now, and it's about damn time. You know, there were so many times that as a young analyst growing up that I would have to plan somewhere between 3 and 6 months just to find and extract and clean the data. There are efforts. And for the M&S folks that are coming out of school, it's a little bit frustrating, but I need you to hang in there, right? I need you to take the talents that you have as Marine officers, as naval officers, that grit and determination. And when you come out of the school, when you get into your payback billet, keep pushing forward, because we can make a change. I'm seeing it in the Marine Corps, where General Berger has laid out a plan, but then he's challenged us to find ways to prove to him that the numbers weren't right, the squadron counts weren't right, these ideas weren't right. The opportunity is now to take what we have and to permanently change the Marine Corps going forward. He just wants to see some of that analytical backbone. Now, the reality of it is, I'm not going to tell you that every analyst, you're not swinging 100. We're not getting into the analyst hall of fame batting 1,000 here, okay? Because at the end of the day, they still have their intuition, they still have their rank, and they have a lot of other knowledge that forces them to go in different directions. My daily life, that influence is money, right? And we're even seeing that in OAD. OAD is about 56 or 57 analysts right now. We serve the entire Marine Corps. We're not the only group of OR analysts, but we're the biggest group. And the way that I try to do my job, looking left and right, is I have Brett and Courtney and John kind of reaching out and building that network, trying to be a central hub of resource for the M&S community. Much of the rest of the OAD is trying to do that with the 8850, the OR analysts, the 8852s, the defense systems analyst. And then I'm lucky enough to have 4 different types of Marines. I have a software engineer type in OAD. So what we're going to have to do is continue to work together, put our shoulders in it. Some days it's going to be 2 yards forward and 3 yards back, but at the end of the day, we will push forward and we will be able to change the Marine Corps. You're going to be able to change a lot of different things, whether it's the supporting establishment, but more importantly, the fleet. And so any opportunity, what you develop here can be pushed to the fleet and can help the fleet make faster decisions, especially if we get knowledge management right, is critical. It's impactful. If you need to zone out, now's the time to do it. That's I kind of hit the key points. There'll be frustration, there'll be continual evolution. And we're finally growing a Marine Corps that's starting to be more comfortable with analysis. Now, I still have, when I sat down with General Smith, when Dr. Axe retired, so he retired in August of 2019. And then I applied for and became the director of OAD by December of 2019. So I've been on the job about 2.5 years. And what I've really done was nothing really revolutionary. I just said, let's be relevant. What I call it is simple terms, get seats at tables. And sir, you showed where you're getting seats at tables. And I think that's very important, getting that seat at the table. And sometimes that seat sucks, right? And we as analysts have to understand that it sucks, but we try to make the best of it. We try to help the folks who are around that table with that, whether it's simple analytical rigor, believe it or not, whether it's teaching them spreadsheets still, or whether it's taking them into some of the most powerful models and simulations that we've ever seen. That's our role. That's our introduction to be able to do that. So I think I covered the reason why you were here and the demand signal. What I'll do now is just give you a little bit. I'll put a backdrop against the Commandant's planning guidance, hit a couple of the key tenets. And since I'm your educational keynote, my whole point was to give you my assessment and my opinion. I feel like I've given you that, and I'll hit it again at the end. I'll talk a little bit about the Commandant's planning guidance and force design. For those of you who are well-versed, I'm sorry, it might be a little bit vanilla, but we're finding more and more often that a lot of folks don't understand what force design is and what it isn't. So I'll hit a couple of the slides here. And actually, if you want to interrupt me and ask questions, I'm good with this. It's an educational keynote. So that's not me just telling you stuff, that's you helping me out. And honestly, this is an evolving creature. I'm not an expert. There are different tentacles, there are different aspects that are evolving every single day. To include some of these new envisions are being played out by 3MEF like today, right now, and in MAR4 pack that we see. All right, so this is in general terms. That's not the one I wanted to hit first. I'll hit 3 first. So this is, we saw the picture of General Berger. And so when in the summer of 2019, when this dropped, these were the 5 main lines of the Commandant's planning guidance that we saw. Force design is underlined because it is the highest priority at that point in time. It occupies a great deal of my time. It occupies a great deal of OAD's time. About 50% of our workload goes towards the force design. But what I also want you to focus on are the different lines of effort. And as you look through these lines of effort, what I see is each one of them has a need for analysis. Each one of them has a need for modeling and simulation. It's a matter of being able to work together and to get some momentum, get some mass to change these things for the future. Right now, force design is still kind of the highest priority for CD&I and the organizations working there at Quantico, or that working within our building. But education and training and command and leadership core values, the talent management, are very important next in line there. So I know based on our M&S team, we have folks at McWill, we have folks at TCOM, we have folks around the fleet and supporting establishment. So there is a basically, at least all 5 aren't number 1 priorities. So there's a number 1 priority, and then you've got 2 kind of 1.5 priorities, and that would be your education, training, and some of the talent management work that you're doing. And part of this, I'm sorry if it seems a little, I'm trying to adapt, and I don't want to say the same things that Dr. Balogh said. I wanted to adapt and kind of complement the work because I really appreciated your presentation, sir. Going forward, I jump to. I don't want to show that one yet. That one's the complicated one. All right. So you saw the big arrows, right? And so this is a little bit more of the decomposition of Marine Corps modernization. And so truth in lending, a lot of what I end up doing on a daily basis is my partner organization is the Office of Secretary of Defense cost analysis and program evaluation. For those of who have been in the National Capital Region, CABAIL. So I end up spending, that probably occupies about 3 out of every 5 days that I'm in the office working with them. But I think what they need is help that you all can provide. What we're seeing right now, whether if it's working across the services or working with CABAIL, is a huge demand signal for modeling and simulation, for analysis, for data and knowledge management coming from experimentation and from wargaming. Ideally, what we're trying to create here is a cycle of research, right? Where all these things are coming together, and not one type of modeling approach or one type of problem solving approach is giving the answer, because really these are complex problems that require complex answers that require a variety of different problem solving techniques. I think, the M&S team that's in here, the students that are getting ready to go forward, I can see pieces and parts of these where Dr. Balogh has already mentioned, and things where you have a role in each one of these modernization efforts moving forward. The trade space that we're seeing, the reality when you get to the supporting establishment and to the fleet, is that money. And that's where CABAIL comes in. So they do some modeling and analysis. And one thing I'll explain is I apologize. My comments might be a bit more biased towards like campaign analytics or those types of modeling and simulation as opposed to the training. But based on what I'm seeing and you're doing here, there's a role. I think the reason this curriculum is so important is because you are actually cradle to grave. So I could see you, if we use you well, if you are implemented well, you're doing everything from future concept development into capability development through implementation, and then on out through training and education command and the work being done. You are truly cradle to grave when it comes to any type of concept or capability that we are moving from conceptual futures into actual implementation in the fleet. And the exciting thing when I get to the real eye chart here to give you an idea of what the campaign of learning or the cycle of research looks like here in the Marine Corps is we haven't thought broadly enough yet about bringing TCOM in, Training and Education Command in the Marine Corps, but we are going to have to. And perhaps the tool that facilitates that is what's already been mentioned, and that's that $140 million Marine Corps Wargaming and Analysis Center. So I'm going to jump over. Sorry, I hope I don't screw up I'm going to try to jump over to this, if that's okay. Hopefully I didn't screw up the projection. Perfect. All right. So this, what I'll do is start, I've mentioned the campaign of learning, the way we view, and this is great. This is one little thing, and I'll take a little credit for this because it shows how just a little bit of analytic rigor can change things. So when I first became director and we were briefing the commandant and the ACMAC about what OAD was doing, what CD&I was doing, McWill put up a set of slides that had its own calendar. CDD put up a set of slides that had its own calendar. OAD put up a set of slides that had its own calendar. Kind of bothered me from day one. So I just went downstairs, and I wish I were a calendar wizard with some fancy tool. But I just went down and made my swim lanes in an Excel spreadsheet. I put a calendar across there, and I started to add the different roles that we bring to the table, CDD, McWill, and that. And I brought it back up and I said, hey guys, what if we worked off the same calendar? So like the future concepts thing, the capability development, the war games and all that stuff, what if we organized it, what could be in series and what needs to be in parallel across time? And it kind of stuck. And you'll see the latest machination, which is a little bit overwhelming, but that's fundamentally what it talked about, starting to get that cycle of research. Now, this is Peter Perla, and I had the opportunity, 4 weeks ago, I think, to sit in a campaign analysis working group by Moore's, where he was in there and we got to talk. And I apologize, it's a little bit difficult to see, but there's your cycle of research, right? So it's the exercises, the analysis, the war games. So, and experimentation. It's how do we continue, I think as projects, as thoughts, as concepts, as capabilities mature, they will continue to mature. To think we are done with one, I think only happens when we bury it at the end of its entire useful life. Otherwise, we're constantly looking to try to refine the knowledge, the information, and the analysis around these different things and integrate it with other primary capabilities or concepts that need to be evolved. So this spoke to me a lot. And this came from an article, you can see Bever wrote it, and I think it's it's 2020, might have been a 2019 article where he really tried to talk about how the worlds of analysis, modeling, simulation, exercise, and experiments must come together. And then he breaks out, I really like the roles and relationships of OA, wargaming, and the experiments, whether it's strategic, operational, or tactical, the different level of knowledge. I think as wargaming evolves, and sir, you've already mentioned your involvement and the team's involvement in wargaming. Wargaming won't be a simple roll of the dice with the big map that we're kind of doing right now in maybe our service center. But ultimately, we better make damn good use of that $140 million that we're spending on that huge cross-domain solution that will bring more different types of classified information than one can imagine together in one building. And the opportunity there right now, like Brett always teaches me, is the 3 use cases are capability development, concept development, O-plan evaluation. And frankly, CD&I, we kind of own or kind of could be argued the lead for capability development and concept development. But it's really our plans, policy, operation, and the fleet that own the O-plan. And so we already have to have a partner in here, another opportunity for people, for that table to get larger, and for those problems or those solutions to get better by bringing together the different teammates, which includes the graduates of moves at that table to solve these problems. So this is what I envisioned, and what started with a simple calendar tool. And then what I've really tried to push, and it's still, I drew it. We went up to see, I had General Imes came on, Major General Imes at that point came on as the deputy director of CD&I. And he challenged me one day and said, I just don't think that wargaming could exist in an analytical organization. And I said, okay, challenge taken. And so I called Steve Stoddard up at Center for Army Analysis, and I said, hey, sir, you're an analysis organization supporting the 8. And you have 2 wargaming cells in your analysis organization. Can we come up for a field trip? And Dr. Stoddard said, heck yes, and a great man, great citizen, great partner. And he proceeded to go through, and the Marine Corps, right? We beg, borrow, and steal. But he went through that their wargaming, how they do it is really just a conference room they've commandeered, and they've got the modeling and simulation team there. They've got the ORs, they've got the data folks bringing in, and they're putting it together to run these war games. It's some tables and some computers, very non-sexy, very much like a Marine Corps would solve it. And after we left, General Imes said, I think an analysis center could run the wargaming center if necessary. And so what I did was I created what I thought would be the vision for CD&I, the cycle of research. And I invited a lot of different people to come in and comment on that diagram. So what we've ended up with is, my apologies, you have to, that's the data for the data geeks in here that like me, who love to grab that stuff. So these are the 3 areas that I probably meant to touch on as I build into the data. This is where I think, as Dr. Balogh mentioned, these are areas, I'll just call them, right? Our concepts, our force design is threat-informed, concept-based capability development. So you heard me talk about the mission sets of the 3 different partners underneath OAD. And then it's easy, I believe, for me, it's easy to see where modeling and simulation fits into each and every single one of these in a variety of different ways. It's just a matter of trying to get that economy of force, focus it in the right direction, or at that single point that needs to be pushed furthest forward, fastest, and getting that. But that's happening now. That's these teams coming together. And then ultimately what we have here is this eye chart, which people might think that this is a mess. I think it's a thing of beauty. And the reason I feel is it shows what we're living. And I guess I'll take this and I'll walk it forward. And what you see here, what can I leave? I'm going to leave the microphone, but I'll yell. So I'll use my Marine Corps voice. So what you see here are the mass nations that these were the swim lanes, right? This is time. These are the strategic guidance coming into the Marine Corps, coming into the services, bringing in our threat analysis, doing that, concepts, studies and analysis, wargaming, experimentation, integrated planning teams, and then the pumping, the campaign of palms across the bottom. What I like is I see this even prettier with the Navy N7. And so if you know Captain Thane Clare and the team at N7, Admiral, I'm trying to think, I think it was Admiral Munch that started it, but they got underway during the period of COVID and they brought together their own campaign of learning, which I thought was great. Now they're bringing together, they're trying to marshal the different capabilities and capacities and organizations around the Navy to try to put it in some cohesive campaign of learning. It's exciting to see. What's missing from this one that deserves its own swim lane is the training and education. Because in my mind, if this is a circle and I turn it out from the board and make it three-dimensional and then move it through time, that's where I see the TCOM and different folks in a variety of the different M&S communities continually can enhance this campaign of learning, this cycle of research, constantly making the data better, managing it well and taking it back to a central repository to now help field and reduce variation in the assumptions and make better solutions going forward. So a bit of an eye chart, but these are the swim lanes that we endeavor to bring together. And these are the things really, this is the chart. So what I'll talk about right now is this is important within the Marine Corps to do this. How am I doing on time? Okay, good. This is important to do it within the Marine Corps, but it's more important than the joint community. As I said, about 3, maybe even sometimes 4 days a week, I'm working with OSD Cape, but I'm working with my service counterparts. So I have CAA, Center for Army Analysis, to the left of me, Navy N81 to the right of me. Used to be Air Force A9. It's now SAF, Secretary of the Air Force Studies and Analysis. And they're supporting both the Air Force analysis and the space analysis. So we meet every single week in one form or fashion to talk about these things. And the focus becomes Indo-PACOM. What you saw here was General Berger driving home the fact that it's kind of funny that these guys are in here talking about forward thinking. And there may have been some kerfluffles in the National Capital Region along the Marine Corps lines. You may have heard about that. A little bit of drama going on right now. But what we end up using is the operational environment of Indo-PACOM. And what I really, as director, what had been born was the joint force operating scenario and had been underway. There used to be an old support to strategic analyses process where all the services and the tri-chairs, CAPE and policy and the joint staff were all at a table trying to figure out how one would answer the various challenges of the combatant commanders around the theater. It died. I think it died a slow, painful death, maybe 16, 17 timeframe. But what became important was that the services still needed to understand, have a force sizing construct where they could move forward with analytics. Therefore, the services got together as a band of brothers and sisters, left and right, kneecap to kneecap, brought their professional planners together, and then brought their professional modelers together and started to look at Indo-PACOM area, using defense planning scenarios as a baseline, really building out the CONOPS, the CONEMs that go with that, and then building out the models. Because what they realized was probably the most important thing, and what's important that I want to leave with all of you is many hands make light work. Whether you're a service the size of the Army, or whether you have the capabilities of the Air Force or the maneuverability of the Navy, the Indo-PACOM challenge area, whether it's in competition, crisis, or conflict, or any one of those, it requires all of us to come together. The new national defense strategy, of course, focuses on 2 things that we haven't really seen in a national defense strategy of 2018 was homeland defense and strategic deterrence. So one has to understand that those are the first 2 priorities, and then Indo-PACOM. What does that mean for cyber? What does that mean for space? What does that mean for the services as we're trying to do ISR, as we're trying to model and simulate various situations? What happens to those space sensors? What happens to the cyber work at that point in time? And that work is underway right now. You are highly sought and highly important to developing not only jackhammers, but not only what's going on within the services and the different supporting establishment offices you go to or the fleet, but working across the purple community. And that's what I find every day is the most rewarding, is the fact that I am meeting with my analytical peers left and right in the other services. We have tables that require professionals in modeling and simulation, subject matter experts and other folks bringing in a variety of different operations research techniques to try to come up with some of these solutions to this really challenging problem. So when I took over OAD, simple things. I didn't have to revolutionize OAD. We had a lot of good parts. We just had to have them working a little bit better. Seats at tables, relevance, collaboration and cooperation. So what I'll ask you is when you go, you in the modeling and simulation community, you as the analyst, you, sir, as the school, which you're already doing, is look for opportunities where you can make a difference. So Marines, continue to do what you do best, which is to get into a billet and do the absolute best that you can there, regardless of the pressures and the tensions left and right. There are things, there's a community that you can reach out to in Captain Thomerson, in Brett Telford, and John Lawson. It's a small community, but what I endeavor to create in OAD is an opportunity, a place that's really tries to integrate, to create an analytical federation, a modeling and simulation federation. It's not where I want it. It's not where it needs to be. But like Courtney and I were talking at breakfast this morning, there are a lot of things that need to get better. And the float is huge, and we just have to push pistons in certain areas, and we're kind of working on that. So I coordinate and collaborate with my analytical counterparts in the Marine Corps and across, but it needs to be better. Tying together our M&S teams into those analytical communities and having them creating opportunities where they can do better. I need to do a better job of that. We need to do a better job of that. But what it starts with is the one thing that, having gone through the transition and watching Marines who've come from Naval Postgraduate School who are volunteers into the voluntold, I expected to be a significant difference in the quality coming out the other end, and I'm not seeing it. In fact, what I see every year, just when I get a class that I'm ready to say goodbye to, and I think, man, they just can't get any better than this. They do. They keep getting better. And so the credit goes to Sir, you, to the school, to Naval Postgraduate School writ large. You are turning out the best and the brightest. And I feel lucky every year when I get the new crowd. It's kind of like Christmas in July. This year we have 7 new Marines coming, and I'm very excited because I love the Marines that are there. I'm going to miss them. And I know ones that are even as talented, if not more so, are coming. And so just help when you are that person, when you are going to your organization, feel free to reach out to us in OAD, but continue to use your initiative, your work ethic, your creativity. Don't give up on that. What I talk to the Marines when they come in, I do an in-brief with them, and I said, okay, you're going to come here and you're going to say, man, what are they doing? WTF on this? Why? I can't stand this place. I just have to do 3 years here and then I'll be done with it. And I've asked each one of them, don't do that. Don't do that. Because we're in a time right now where we can change the Marine Corps. General Berger has given us the opportunity to challenge the concepts, the capabilities, and all the things that are happening. Don't forget that opportunity. Take it. And we're trying to do it in OAD. I see modeling and simulation teammates trying to do it across the different organizations. Worst comes to worst, we just have to work together, but get in there and look for those opportunities. If you can't get the energy from the staff that's around you and you have a great idea, come over to OAD and get the energy. There's a whole team over there, especially if you're on Quantico, or have us come and visit you, but don't lose what you do best, which is work ethic, innovation, and adapting and making a positive impact in your billets. And in that way, I think you'll accomplish what the Commandant really wants to see is us pushing towards a new Marine Corps and developing new horizons. I think I'm going to stop there and open it for questions. I hope some of what I've tried to adapt a little bit on the fly to complement what Dr. Balogh said. Hopefully, as we leave the educational perspective we had and the great things that Naval Postgraduate or School are doing, the implementation and us being able to move that. Am I getting feedback? Oh, okay. So hopefully I've helped connect another piece in that whole life cycle. But anything I've said, inaccuracies, because I'm force design is so much of a change in the Marine Corps that I hopefully didn't say anything incorrectly. Questions, comments? Well, sir, please.
Yeah, Chris. People on Zoom have asked.
Okay.
Okay.
This is apologies first because you probably said it and I didn't get it, but I was enjoying the story about the connection between the wargaming cell as you saw it play out in the Army.
Yes.
But I gathered that now there will be some change in your organization. Will you have a wargaming cell? Will you have a major role steering the wargaming center? How do you see that evolve?
So one of those evolutions underway, sir. No, it's a good and fair question, and I have today's snapshot for you, and I don't know what future. I mean, Brett and I, we spend a lot of time talking about what the future looks like. Very much. I hope we don't get into what happened in Helmand province, where we built a brand new multi-million-dollar beautiful headquarters building, and about a month later we got on the 46s and got out of there. So, given the change in the financial profiles that I'm seeing for the services, at OSD, the priorities of the administration and that, even our organization right now, General Berger, in order to create more money for modernization, is cutting back supporting establishment. So my TO is about 71, 72 people, and unfortunately, over the next 5 years, I'm slated to cut 11. So what that translates to is we got 4 Marines and 7 civilians. So I'm not excited about it at all, and I'm looking for every opportunity to buy it back that I can. But I lose those extra important Marines, the different MOSs I have, because I have to regress back to a policy and program perspective with M&S, and then coming back to the analysis. So that's a long answer to say it's still evolving. The building will be built. I mean, when you come this summer, those of you who are going to be able to make it to Quantico, you will see the walls will be in place. The roof is on. The new center is there right on the edge of Quantico town. We're still working through the Marine Corps Warfighting Lab right now has kind of the executive control over that. We're just not sure how it's going to be staffed. And I think even if I tell you today it's going to continue to evolve. I spoke about the 3 primary use cases, the O plans, the concept development, and the capability development. But Brett, tell me when I'm wrong, but there was a training and education command.
Yeah, there were actually
6.
So back in 2017, we did a workshop to figure out, based on analysis that had been done by RAND, where modeling simulation could best benefit the Marine Corps. And we identified 6 areas, 3 you already mentioned, plus training and education, S&P, and senior leadership conversations or discussions. As we whittled it down, basically as we were directed by leadership, we came down to 3 specific use cases. Those are the ones you mentioned. And that is what our capability design document captured in terms of how best to figure out and how to bring a capability that was going to break the status quo or should break the status quo about how war games and analysis work in conjunction with another. Not necessarily the same thing, but they're very close cousins and they need to try to support fire each other. That's what the goal is. We'll see.
And that's when I talk about just pushing every day, shoulder in, and not giving up. I mean, General Smith, what a great guy to be hired by. I feel really, he's now the assistant commandant of the Marine Corps, a great man. He was the one that hired me. Probably didn't give a rat's behind about analysis before that, but because he had to go through the whole machinations of hiring a new senior leader over OAD, he figured it all out. And then the way he mentored and supported, and he got me at tables where before OAD might not have been invited to a table to make an impact, whether it's those IPTs where we do all that work, or if it's the IPTs, he got people seats at tables where they belonged, and we started to make an impact. We started to be having success, and then that got us more seats at tables. That got us more opportunities to succeed. And so much that, and this isn't an M&S thing, but it will be an M&S thing in the future. Is our deputy director, Colonel Kemp, week and a half ago, in one afternoon, he was briefing the Secretary of the Navy, got pulled into his private office and said, "Hey, we're talking about amphib requirements study. Tell me, CAPE is saying these things weren't analytically rigorous about the analysis. What's your perspective?" And Secretary of the Navy was leading one way for amphib numbers. And by the time Colonel Kemp was done with the conversation, using a team, using Captain Foster, different folks who had been here before, the SecNav slapped the table and was like, yep, 31. That's the right number. We're going forward. And then in a meeting 2 hours later, he was briefing the DepSecDef at the same level, talking about, yes, ma'am, CAPE has a perspective on what is right for the amphib requirements number, but this is the analytically driven requirement. And it came from M&S people, OR analysts, subject matter expertise, people who understand. And because General Berger had gone to Congress already with the number, the DepSecDef might not have been super excited about that because they didn't have an opportunity to weigh in. But it was analytically founded, analytically driven, and the commandant was able to give that number to Congress. And now we're kind of working out with how that whole disagreement might have happened afterwards. So I think I went way too circuitous, sir, but I think we are evolving, and the personnel, I think we're going to have to go with a contractor staff at McWack for facilities, security, and knowledge management. And then it wouldn't surprise me if we don't treat it as a large, because it's going to be a powerful tool. It's not necessarily an organization, but a tool with all the cross-domain solutions and up to many different use cases to include outside Marine Corps. I think would ideally use that center. So we may have a permanent presence there as an opportunity for OAD. McWill will have a presence there. So there is the opportunity for some high-speed modeling and simulation, high-speed analytics, and to Brett's point, getting more people around the table. So we're coming up with better informed solutions. Really long answer. I apologize to your question, but that's
That was great.
okay.
I'm following it, and I'm very hopeful it works out.
Yes, sir.
All right.
Well, we're going to keep leaning into it. So what other questions, concerns? I mean,
Morning, sir.
Sure.
Captain Martin, I'm a junior cohort here for the Moves Institute.
Can you wait just 1 second to get the mic? I mean, you can definitely hear it, but people on Zoom can't.
Good morning, sir. Thanks for coming out. Again, I'm Captain Martin, junior cohort here for Moves Institute. I'll go into 5th quarter next, was it June? So essentially, I want to preface this by saying, like, I'm not behind the curtain as much as you are and the senior staff, but it seems to be a conflict between DoD's desire to increase modeling and simulations in the DoD, and then the amount of staff that they're willing to support it with. So I'm just trying to see, like, how are we trying to grow? I mean, we're going to have this warfighting laboratory with walls, but nobody in it. Like, where are we going? What is the commandant talking about? How are we going to fix this problem of, I mean, we got 16 billets for modeling and sims for Marine Corps, but we're all basic master students fresh out of the schoolhouse. I mean, I know we have, you know, our abilities to overcome obstacles and seek unique solutions and all these things. But I mean, 16 modeling and sims officers, there's one Navy student here. Like, how are we going to overcome this problem of having all these great ideas, but no manpower to support it?
great question, and thank you. The way I see us overcoming it first is a clearance thing. So when we come back to the world of knowledge management, the biggest, one of the largest things that stovepipes us, regardless of our type of problem solving tool, M&S, analysis, whatever you want to apply, is access to information. We're seeing increasingly higher program held information all the time within OAD, within McWill, within CDD, pushing more billets, pushing the SAPCO, expanding the size of the SAPCO in the Marine Corps to have more people cleared higher. What OSD Cape is helping us with, the team I work up there, they're working with the joint staff. They're now trying to create SAPs that are cross-service SAPs. We're now, and the number's kind of funny, but it's the truth, 4 people per service can kind of get together and we can talk at some pretty high classified levels. So improving the collaboration and cooperation. I think, sir, to your point, I think what will bring us together will be proofs of concepts and projects where we're able to come together across these organizations because of the increased access the SAPs will allow. There's still the parochial hierarchical stovepipes and different things like that. But I think what we're going to see is more and more projects by organizations that can reach across different other organizations, like, for instance, OAD. You know, for whatever we are, I have the opportunity when a study comes into us or a request for a study comes in, one of the first things after we get the objective and kind of the assumptions and that nailed down is we ask the sponsor who should be assigned. And so we build a study advisory committee where we're building from across the Marine Corps. Those projects are excuses. We shouldn't need excuses, but those are the excuses and opportunities to work together. And I think as modeling and simulation works with higher and higher classified information, the problem sets like Indo-PACOM, especially when you get into ISR, I mean, the 2 big things right now at the highest levels are C2, C5 ISRT when it comes to PACOM, and contested logistics. So the contested logistics, we know, my gosh, we've waved our hand at that for forever, and we finally being called to the carpet on that. But the C2, so I think problems like that will help us get more people together across more organizations to solve problems. Brett, you look like
reality of it is the Marine Corps is a very small service, a very lean service. Our infrastructure is provided by people like the Navy, for example. So every Marine we send here to go to school is not only 2 years out of their MOS to go to school, but then they do a 3-year payback. And that's a big cost for the Marine Corps. MNRA has made it very difficult from a policy standpoint that if we want to create new billets, new set billets, they've created up to a 3-to-1 ratio that you have to turn in for compensation. That doesn't make it easy for any command seeking an 8825 to want and to be able to get an 8025 and afford it, or any 88XX. So it's a tough nut to crack. You ask, how's the MCWAC, the Marine Corps Wargaming Analysis Center, going to handle it? I will tell you the way they're going to handle it, it's going to be very expensive for the Marine Corps, because what we're going to end up doing is hiring a bunch of contractors to do some of the same functionality that perhaps 8825 could do. So when you look at the $190 million cost of facility, look at the long-term cost of the amount of manpower it's going to take for as long as we keep that facility up and open. I don't have a better answer for you. I mean, being a 14 more towards the end of his career than the beginning of his career, I had the luxury of being blunt, but I'm just going to lay it out for you. But I also think this gets to Mr. Hoffman's main point, which is why every one of you that go to the school and come out are so damn valuable. I mean, the reality of it is we only have 16 billets. We're not as, like some of the other services that have a few more M&S officers that also spend the rest of their career, if they choose, in M&S. We get one hack at you guys, most of you guys, one payback tour. It's very important for us, for you to learn the skill sets here, to learn the technical side of M&S, so you can be that translator of operational Marine Corps to technical M&S back and forth to make sure that the things we buy, the things we use are being done so appropriately. I don't know if that's a good answer you're looking for, but that's the best one I can give right now.
I'm just thinking survivally, the comment right now is doing a huge push towards force design. I know it's costly, but I mean,
Well, I'll give you an example. So when the decision was made to get rid of tanks, we jumped on board that and say, hey, what are you doing with all those billets? Could we have a couple of those to expand either our OR or M&S workforce? We were summarily told no, because they needed those billets to pick up on the cyber workforce that was now the new requirement. So everything's a give and take. There are no easy solutions, particularly when we're struggling with maybe a Marine Corps getting smaller as opposed to getting bigger. So it's not an easy, I'm not giving you the answer you want to hear, but I'm trying to give you kind of ground truth and the challenges we have to overcome.
Good morning, sir. Major Alex White, graduated from MOVES last year, currently with Expeditionary Warfare Training Group, Atlantic, working with the Navy. Modeling and simulation has broad applicability. Wargaming can focus on whatever it means to you. You've talked a lot about analysis. You mentioned a couple of times the importance of training and getting TCOM at the table in this. By my count, 12 of our 16 8825 billets are at training organizations or training support organizations. How do you make sure, as the proponent, we're getting TCOM included, we're focused on training, as we're making sure that the MOVES program is aligned to producing the 8825s for the things the Marine Corps is going to use them for?
My short answer will be, a great question. I appreciate it. Thanks. My short answer will be the ability and the knowledge that Brett would have over that community. There is an increased, so interesting thing happened a year and a half ago is Training and Education Command was underneath. It was MCCITIC and DCCD and I all in one, and then they were split, and a 3-star was put over that. It had useful purposes in doing that, but the more as we move forward, you see that the two are intimately tied. When I talk about the lines of effort of the Commandant's planning guidance and that, and especially the swim lanes that I showed you, Training and Education Command is more and more a part of that. I have the executive director of Training and Education Command is, of course, is a teammate of mine, a friend of mine, and so he uses the Marine Corps study system to try to help with some of the questions he has to have answered. But I don't think that fundamentally answers your question of how am I making sure those billets are being pointed in a direction that will advance force design. Brett, do you have?
So again, probably not the complete answer you're hoping for. So because by Marine Corps order, General Heckel is actually the lead for Marine Corps M&S. What does that mean? The same order also identifies 4 specific communities, each with a flag level officer, who leads and I would say owns and operates the modeling simulation that supports that community.
McMizzo acts as the action arm for General Heckle, which has been delegated to Mr. Hoffman on a daily basis. Our role in terms of what you're talking about would be what we're going to be doing tomorrow, which is the curriculum review. Going out and pulsing the communities, all the communities to include training and making sure we understand based on the billet requirements of how that community is saying they're going to use that 8825 and translate that into curriculum that then the people that are going to be filling those billets will educate and enable them to hopefully hit the ground running once they get to their billets. We work issues like assignments, or at least as best we can, given the constraints of what I answered the previous question. We're going to be working this summer to get a by name request for Jesse Atig to go back to TCOM, which would be his third 8825 tour, which is unprecedented. And hopefully, and I think we'll be able to do that. We've done by names before to get try to get the right people in the right positions. But I don't tell, once the 8825s gets to their owning command, I don't, Brett Telford, McMizzo, it's not our role to tell that 8825 what to do. It's their commander. So do you have a follow-up, or is there something else you want to ask in that regard?
Really just with all the talk of analysis today, making sure that if three quarters or 8825s are focused on training, we're not losing sight of that. It's really just want to make sure we're still thinking.
I don't think we are. We've also supported TCOM. We're always willing to support TCOM when it comes to LVCTE. We did some upfront analysis based on networks and stuff to help kind of feed the AOA that they ultimately did. We are supporting the Project Tripoli and leading the standards part, because I think that's kind of a core McMizzo function is M&S standards. We will always do what we can within the resources we have to support LVC, because I do think it is probably one of the two major things going on right now that is kind of Marine Corps M&S centric.
Thank you.
Good morning, Chris Getchell, full disclosure contractor. So I see some numbers up there and I've heard some of the discussions here, but several years ago, there was a big study put out for DoD about building up the civilian workforce, specifically to M&S. So while we talk about the force structure with force design, have we looked at like the manpower requirements for the civilian workforce besides just contractors and what that should look like going forward? Because this continues to decrease. I do know that some agencies continue to increase their civilian workforce, but it really doesn't benefit the fleet. So just, any insight onto analysis going forward with that, please?
Yes, sir. Yeah, I appreciate the question. And yeah, that's why I put this one up here. Didn't really talk to it, but for those of us who enjoy data in the audience, kind of looking at what force design and transformation looks like over time, we are reducing the numbers. What I see, especially with the strong analysis demand or strong demand signal for analysts, modeling and simulation teammates, different folks like that, we're ended up using contractor organizations to bolster that. There's going to have to be a push at some point in time to advance our tools, and that speaks to knowledge management and cloud and different things like that. Of course, with JEDI, we've had the start where we were moving towards the more integrated cloud environment, then we kind of stumbled. What I see some organizations doing within the Marine Corps, I'll say like our manpower and reserve affairs teams, they are making inroads with creating data lakes inside the organization, connecting previously unconnected databases that didn't work together. We're using Advana and Jupyter as kind of a PA&E and programs and resources kind of perspective, trying to weave those different data lakes together to create a more effective data mesh that ideally will help us to do more with less. What I see right now is there is a huge demand signal for M&S folks and analysts. Like I said, in the National Capital Region, CAPE is clamoring, Joint Staff is clamoring, every service. I was in my meetings even 2 weeks ago with Robin Bell from N81, and I was talking about the demographics of her workforce, and I was talking with the CAA team and my team and said, you know what, we're even thinking like CAA and I can reach down and grab and grow 7s and 9s because we have those ladder positions. What if I were bringing in people and greening them that I would push to then N81, whether it's for a tour or for a lifetime, but it still benefits the entire community, whether it's analyst or the modeling and simulation community. We're trying to get creative. We're trying to be non-stovepiped to try to get after this reduction, but it is troubling. And to even say, I think John Lawson, the other team, he looked at the Commandant's planning guidance. I think there are 11 separate excerpts in the 2019 guidance that talk about the need for more modeling and simulation, wargaming and analysis. In that talk, we would think that there would be a plus up in that, but because a lot of that is in the supporting establishment and General Berger, we have to reduce daily costs in order to modernize the force. You hear me even taking an 11-person cut, which doesn't make me comfortable because we can only create so many efficiencies. And Brett, if you have an add-in, if you want to jump.
Being around for so long, you kind of get a flavor for all this. There have been calls in the past to establish a separate job series for civilians for modeling simulation. The challenge with that, and it's a significant challenge, is job series aren't controlled by DoD, they're controlled by OPM. So it would have to be a whole of government push, not just a DoD push. However, there has been work done in the past, and I think the Army is the gold standard when it comes to this. They have a program which I wish we could figure out how to implement in the Marine Corps, where they have career professional 36, I believe, which is M&S. Now, what does that mean? It doesn't necessarily mean the individual changed their job series. They may be like I'm a 1515 OR. I would still be a 1515 OR, but my boss would dictate what kind of job skills or sets of skills I might need. And if those fell into the area of M&S, I would fall under CP 36, and they have a means of which they can help provide some of the education and training to facilitate my development as a civilian. In addition, we worked cooperatively with the Army to develop, this goes back to the old M&S steering committee days, the Marine Corps and the Army worked to develop what they called a series of knowledge, skills, and abilities based on what kind of job a civilian would have, whether it's a manager of an M&S, say somebody who's a coder, somebody who might be more of a senior leader kind of thing. And we identified those knowledge, skills, and abilities that people could take and put into position descriptions so that you could go out and hire the right kind of skills based on people's background. Now, nobody kept that up. We actually, in our Tiger teams that we had about a year ago with Colonel Gilman, we did the same work again, and we tried to re-energize OSD to say, hey, you need to reinvigorate this. This would be something useful for all the services across the board. That kind of fell on deaf ears. I won't get into some of the reasons why. One of the things that does concern me today, and maybe Ivar, you could comment on this, the HASS, the House Armed Services Committee, has now come down and asked OSD some very specific questions. One of those deals with the education and training of people involved in M&S. However, the focus is specifically on digital engineering. The focus needs to be broader than just how future systems engineers are going to be working. It needs to be how M&S practitioners across the board are going to be working. But I'm concerned that, being OSD, because I used to be an OSD guy, for better or worse, they're going to be very focused in answering the very specific question that Congress asked because they don't want to open themselves up to anything else. That's just the reality of how things work in the sausage making palace of the Pentagon. I used to be there. I understand it. I don't know if that's a little bit more fidelity to the question. I don't know if that fully answered it.
Lieutenant Colonel Michael Donaldson, Training and Education Command. Sir, as you mentioned, throughout the workforce, we're taking a lot of cuts in the supporting establishment whenever civilian personnel depart. One of the few areas where we have been allowed to conduct backfills and recently actually hire a couple additional personnel is within the area of simulation. So it is being recognized that this is a necessary skill set. I can't say it's applying to the enterprise quite yet, but based on some of the guidance that we've been given and specific direction from the commandant to execute these projects, people are aware that we need a skilled and professional workforce to do this.
That's great, sir. Thanks. That's good additional gouge. We're seeing the demand signals in general analysis on space and cyber at the DepSecDef level. So within OAD, a couple of us are part of a larger, not that much larger study team where we're trying to figure out where we are with cyber and space analysis and then what we need to do in the future. And DepSecDef sees as much of a priority where she said, how much money do you need and what kind of workforce? And we're trying to figure that out. So I think these are opportunities perhaps in the same vein, sir, to continue to advance some of these areas. It's 1 yard at a time. So.
Okay, well, I think that is about all the time we have. So please join me in thanking Mr. Hoffman for that great and interesting talk discussion. Our next speaker is Dr. Chris Darken. Chris is the MOVES Academic Associate. He's responsible for making sure that all the curriculum is going well, and he's been running our curriculum review. That's happening this week with Mr. Hoffman and Mr. Telford and Captain Thomerson. So, Chris, let's take it away.
Okay, thank you, Perry. Yeah, let's spend a few minutes talking about the curriculum. It's a big year for the curriculum. We haven't done a curriculum review since 2018, so we're a little overdue on that. Should nominally happen every couple of years, but for various reasons, global pandemic and little things, we have some good excuses, but but the curriculum review is really an ongoing process. So I'll be talking to you about some decisions that have been taken and then the immediate vector that hopefully will be signed off on from the brass at the school and on the sponsor side shortly. But that doesn't lock us in stone forever. We'll immediately start thinking about what new things, new initiatives we should be starting. So please give us your feedback in the talk. Grab us on the side by the lapels in between the talks whenever you care to, and give us your feedback, because that is extremely valuable. Okay, so let's see. What are the advanced? Okay, so yes, I want to give you my view about how the NPS wide environment has changed recently, because that impacts a number of things about the curriculum. Starting from the fact that, as in a lot of areas of the Navy, we have a reduced budget. Understand we need a few more ships in the Pacific. Well, that sounds pretty important. So no argument from me about that. But what that means here is less money for all kinds of things, and especially for our biggest expense, which is the manpower to do the teaching. Okay, and this happened to us. The exact change, I think, got dropped on our admin folks here kind of late. And so they kind of had to push a big red button earlier in the year, and we had to make some immediate course corrections that I will tell you about, because that's part of the change that's going to impact the curriculum, of course. And the second thing, and of course, what goes hand in hand with contention for budget, is trying to make sure you have support in your organization, right? There's no big surprise there. So you, when budget is contended for, you want your sister organizations around you to be saying what a great job you're doing and how they couldn't live without you. And no, by all means, don't cut money from them, because they really, really, really need it. And we also benefit, right? And so that's a part of this whole NPS Next endeavor, is to make sure that the feedback we'd like to hear is what gets heard by the Navy and broader government. Now, responding to that, also above my level, well above my level, there have been certain administrative decisions that have been taken that will also be impacting us. A little less clear what these mean. So those are going through I think a good inclusive process, from what I can tell, across the campus, to make sure that the implementation of the decisions is sensible and the best possible for the campus broadly. But what this is going to mean, and no shock with the reduced budget, is that efficiencies have to be found in the teaching process. And this means a big reorganization in terms of how we teach. So if you're not already aware, the four big schools that NPS had are already gone. If you visit our website, you will see there's no GSWAs anymore, GCs, the engineering school, operations and information management. Those notions of schools are gone. We only have departments now. And within degrees, there is a desire to reorganize how we conceptualize and execute those at NPS, again, focused on gaining efficiencies. So this means reducing curricula, cutting curricula, that especially ones that are undersubscribed, and consolidating the ones that we don't cut. So we're a small curriculum here, so that's interesting. But what that will really mean for us will be clear over time. And in particular, there will be a notion that there will be these academic program areas will kind of be the foundational construct that we use at the school, rather than the curriculum. We've been curriculum based up till now, In the future, it'll be the academic program areas that are most important. And then the curricula will kind of exist within these academic program areas, hopefully synergizing with one another so that, to take, the kind of example we're talking about, everyone isn't teaching their own math classes or programming classes or, on and on and on. Okay. What will these academic program areas be? Well, we don't know. So we're told that we'll have a final list in the end of July timeframe. But at the moment, there are only 9 of them, and modeling and simulation is 1. So that's some indication that we're well thought of at the current moment. But it's all subject to change. So let's wait and see. And even if modeling and simulation does kind of sit as its own area, that doesn't mean things won't change, because when there's a desire to synergize, one thing or the other will happen. I wouldn't have been shocked as a small curriculum if I were told, okay, you need to merge in with these other curricula, right? And of course, that would be uncomfortable for us and also for our sponsors, but it can work the other way too. We're going to stand up modeling and simulation as an area. What does that mean? Or maybe now you need to include these other curricula, make sure you're also servicing them. Okay, so there's going to be some interesting and substantive discussions, I think, around that. Once the fog clears and we understand what this really is going to mean in detail. So it's going to be a while yet. But that will all be part of our next curriculum review cycle for sure. So exciting times. All right. So what happened immediately earlier in the year is we were told that, okay, you've all planned your year, you've all figured out how you're going to pay yourselves for this year. You know what you're going to teach. You know how much you reimburse for that. Okay, well, that changes now because the budget is suddenly reduced. So we need all of you faculty and staff to go out and find more money to pay yourself. And we need to immediately go into the curricula and see what we can do to free up teaching sections. That saves 1 section per year. So a teaching section is, that's the way the teaching staff fill out much of their year. I teach a section of an AI course, for example. So that's 1 teaching section. I'm paid a certain amount for that. Okay. And so what happened was some sections were cut and all the rest of the sections had a reduced compensation associated with them, fairly substantial. What was it? Was it 10% or maybe a little more than that? Yeah, it was, substantial enough that made life a little uncomfortable for everyone, I'm sure. And so some of the detailed things that happened here are that we had our own programming course. There were reasons for that. I just made fun of everyone teaching their own programming, but I can tell you there's reasons why people do those things that go beyond, desire for, selfish desire for control of your own destiny. That's part of it always. But anyway, so we will be using the CS's Intro to Programming, which some of you students coming through that may very well be what you sat in anyway, depending on when you graduated. But we're going back to that world. That saves us 1 section. We were told we needed to use the, this was a discussion. So I was certainly involved in trying to make sure the cuts were, we had to cut a certain amount. We wanted to make the least painful cuts possible. So for this year, we are largely using the computer science networking course. That was more painful than the programming because, of course, in simulation, we have our own ideas about what topics need to be covered in that kind of a course. And it looks like this decision will be backed out in the next fiscal year. So we'll see about that, but that's already sort of happened this year. And then some other changes happened. We put another thesis block in, which will, I think, be welcomed by a bunch of students. It will replace a block that was related anyway. We had an advanced topics course that was really focused on allowing students to start writing their literature review. That's what most of them did there. But the real reason that was there is because certain students needed to learn some particular academic area or a skill using a software tool or something like this, which was a major sub-project as a part for their thesis and as it was needed for their thesis. And this gave them a chance, a slot where they could actually do that work without having to take it all out of Hyde, because students are very busy, without extra tasks like that. Well, now it'll be a thesis block, so that shouldn't be too much of a loss. Last but not least, the ongoing MOVE seminar, which is, we've always tried to trim it's nominally 2 hours a week, but we really don't use 2 hours a week for that, again, because we know the students are busy. Sometimes there's a little bit of maybe cognitive dissonance on their part. They already feel like they're doing so many different things, and the faculty feel like they should broaden their horizons yet more. So it's a good thing to come in and listen to an outside speaker or listen to someone else's on campus's description of their resource. So as faculty, we think that's important, and students already feel overloaded. But anyway, that isn't going away, but what is going away is compensation for organizing that, which moves faculty attached. Okay, so put that all together, it's a 2, 3, 4, 5 sections a year. It was enough to meet the emergency need. None of it's written in stone, but that would be the expectation is going forward, with the exception of the second one that we expect to be backed out. Those changes will stay in effect. Okay, now, let me talk a little bit now about the curriculum review. This is a normal curriculum review that would happen whether or not there's a budget shortage, right? So this is a process that is well established in practice, if not always codified in some kind of a written document. So let me just briefly describe that for you. It starts with the work that the sponsor does. So the main sponsor in recent years has been the Marine Corps, but we have our Army and Navy sponsors as well. So the Marine Corps has driven this process, and they've been responsible for understanding what the technical needs are that correlate with their billets, and going through and making sure that information is fresh, and potentially pushing that into a rather long, almost 100 some odd knowledge items, which are needed for each graduate. And together with each knowledge item is what's called a Bloom's level, which is a somewhat fuzzy, but a way of trying to get at how deeply do you need to get into that particular topic, right? Obviously, not every topic needs to be gotten into in the ultimate depth, but surprisingly many seem to need very rather detailed coverage. At this point, and I don't need to tell the alums this, but the students past and present, and MOOCE faculty as well, are also surveyed for each one of those knowledge items to indicate what kind of depth they feel is actually being provided by the curriculum, independent of what the sponsor is saying the student should have, what's actually being provided. Okay. Now, no surprise that those don't completely line up ever. Okay. So that kind of drives the rest of the process. Okay, now normally, and then the last time we did the review, the sponsor also looked through all the syllabi and did their own kind of heuristic analysis of what was being provided in terms of Bloom's level for those 90 some topics. For technical reasons, very unlikely technical disaster happened and data was lost, so at a bad time. So we didn't get that done this time around, but I assume we'll do that in the future as well. Okay, so that's all on the sponsor side, and then the sponsor comes back to us with the results of that survey. We do get raw results, but in particular, what I would like from the sponsor, what I ask for, is for them to filter that list a little bit using their own knowledge of, because they have their ear to the ground in terms of what's happening in their billets, whether the sponsors, the owners of those billets are happy or not happy, and why. I mean, I wouldn't have any idea about that, and they have plenty of idea about that. So I asked them to kind of filter those items down. Again, because the what's supposed to be provided, what's actually provided is never going to line up completely. Some mismatches are worse than others, and some of them have credibility with people who actually know what's happening in the billets, and maybe others don't have quite as much credibility. Okay, so in our case, there was a list that had 12 items on it, which was then pushed over to moves, from moves to consider. Okay. All right. Now, what do we do? So we have these items. We know what Bloom's level they should be offered at. I'll say a little bit more about the Bloom's levels on the next slides, just in case that's a new concept for some of you. And then on our side, we go and try and figure out what's actually offered, what's actually going on with those particular topics. So we need to figure out which courses are actually currently supporting that particular topic and talk to instructors and try to figure out and characterize what the nature of our offering is for those possibly deficient knowledge items. Okay. And then when we see that there are, areas that can be improved, and let's face it, instruction is always an area in which it's always fair to say it could be improved, right? And when did you hear a perfect instruction from a perfect instructor? That never happens. So there's always areas for improvement. And so then we propose how we would address the various issues to kind of shore up the what's provided by the curriculum in each one of those areas. And then just kind of the last bullet there is we don't, this is maybe not so visible to anybody, maybe it should be more visible, but part of also what we need to do on the NPS side is we're responsible for the academic integrity of the curriculum, right? So we need to provide degrees by Title X that are accredited degrees. And we have that has maybe more latitude to it than you might think, but at the same time, I mean, my feeling is this is a technical degree. The degree is being granted through a computer science department. The other large weight is on an operations research department. Those are very technical, mathematical, and programming oriented areas. So you would expect a graduate with a MOVES degree to be a technical person. Right? But we wouldn't want it to be the case that someone comes out and we've got the complete checklist of what's needed for the payback tour, and that all works fine, and the payback tour goes through, but someone retires and goes to get a job at a company who needs a simulationist, and we find out that their skills actually don't mesh at all with what a company would assume that a MOVES graduate should be able to do. Excuse me. That would be a bad thing, right? So it's on the faculty to make sure that doesn't happen. Okay, and then there is discussion back and forth about the improvements that are provided. I mean, how they can be paid for and other things, because some of the items are not small. And we agree on a plan leading up to a formal curriculum review meeting where the sponsors and the academic leads at the school come together and agree, and hopefully then sign off on the plan for the curriculum over the next couple of years leading up to the next curriculum review. That's the whole process, and that meeting will happen tomorrow. Actually, so some of us aren't here tomorrow afternoon. We'll apologize in advance, those of us that need to be in that meeting. It's not that we wouldn't rather be here hearing what our colleagues are doing, but that meeting is important. So that's how it works. Right. So this is just so it will not shock anyone to know that as specific and as precise as you would like to be specifying what needs to be taught in a particular area, you never really reach the level of full precision. Okay, and the best thing that's out there that we're aware of, and you can all tell us if you have a better construct that you're familiar with, is this notion of a Bloom's level. That's been around for a while. It's been adopted pretty widely by educational institutions. There are different versions of it, so I kind of put our version here, right? So kind of like the idea is, very, very coarsely, starting from a very cursory kind of a coverage to a deeper kind of coverage, right? Have you just heard the terms and you remember that, oh yeah, there's I remember that term from networking, right? Very cursory kind of knowledge. At least you know to look in a networking book if you don't remember, you don't understand what that thing means, right? Down through having some kind of understanding and able to actually apply it and actually do something with the knowledge, and to 4, 5, and 6 really being much deeper levels of ability to deal with an area of knowledge, to be able to analyze or evaluate, or of course 6, to actually be able to build a functioning system is kind of the ultimate in this particular hierarchy. Okay, but none of it is precise. So yeah, so no surprise, as on the previous slide. This is something that if we think that maybe the curriculum is falling down in some area, that some knowledge item is not being covered as deeply as it needs to be, you can't just leave the discussion there and say, well, you said Bloom's level 5, but the survey says Bloom's level 4. So therefore get it up to a 5 and expect that that is enough to go and take action on to remediate a problem. It's not. You need to discuss what that really means to move forward. Okay, and in our case, this is an eye chart, but it's just, I really just put that for reading later. This is actually the action plan for the 12 items that we had, maybe been slightly overtaken by events in a point or two, but most of it is there. So what you see is the actual text of the knowledge item that's there that the sponsor is requiring, the Bloom's level that they would like to see the students arrive at by the time they're done. And you see these are covering a wide variety of different areas. And as we, this is slide 1 of 2, okay? But as we dug into this a little bit, we see a lot there. I saw a lot there that was relating to modeling, environmental representations, terrain, vegetation, cultural weather, and you read the fine print there, that's got a whole lot in it. Physics-based models versus simplified models. So that kind of stood out to me as one kind of cluster. Again, together with my feeling, with my ear to the ground on this end, that I wasn't very happy with the way we were treating that. The modeling education here was a little bit desultory, not necessarily bringing students up to the level where they would be comfortable with the kind of models that they would necessarily find inside the code of DoD simulations, right? That's what I would really like to have. And then we saw some other items, issues relating to understanding software specifications, conceptual modeling, which has kind of been an ongoing issue. I wish I could kill that dead one of these years and have everyone say we're doing an awesome job at that, but it seems to always be a work in progress. Analyzing strengths and weaknesses of software applications, and on to, again, another software issue there, developmental testing. And then another cluster of issues relating to, in my mind, the broader interoperability area. How do you do staff training if C4I is involved, for example? Simulation support for larger wargaming efforts. Okay, that's more of a wargaming one. There's HLA Discentina there, and LVC called out there. And what's the last one? Being able to identify. So we know we always go through flavors of the month in DoD, right? There's a new term coming out, like AI is very hot right now, right? So something that everyone's talking about, can you discriminate between something that is going to be imminently disruptive versus something that, maybe it will be disruptive some year, but not this year? That's an important distinction that our graduates need to be able to make. What else do I want to say about this? Yeah, I was a little surprised when I got back this, our interoperability coverage to me was a strong point of the curriculum. So that was a learning point for me to go back to the students and try to figure out why they weren't rating our coverage as highly as I hoped they would. And it really wasn't that they were unhappy with what we were providing. It's that I think they were realistically scared at the gap between what we were providing and what they were afraid would be asked when they're actually going into a billet and maybe responsible for a big, federation of simulations to support a high profile exercise. And that's maybe always a thing to be scared about. But we went off to think about what could be done better in that area. And this is kind of my summary. This is the same changes. This is just a summary view of what I just showed you. Well, to let me talk about a few more details. Okay. So for that interoperability cluster, the changes we are proposing to make is to remove the CS cyber course. So we've been sending students over for the CS cyber course from kind of the moment at which cyber really started to become a hot topic. And I think that was the right call at that moment, because at that moment, it really wasn't very clear what a simulationist needed to know relating to cyber. So it was a conservative thing to do to kind of give them a good broad coverage to allow them flexibility to dig in deeper on their own in areas where they were actually going to need to dig in deeper. But now I think we've got a little more clarity on some of those topics. So we're going to pull that responsibility back into moves and set up a new course, yet a more advanced course. So this is our sequence in interoperability related sequence would start with our basic networking course. And we go through the interoperability practicum, which Chris Fitzpatrick teaches. And now we will have, Chris will stand up another course. That's the plan here. That's what MV4XXX is supposed to be, which will be more advanced LVC focused. I think, from the moment we stood up the interoperability practicum, I was hoping for, and I think to some degree we got, a hands-on exercise, which is really kind of always, it had some representation, the best we're going to ever do is just some representation of the L, the V, and the C, and show that you can make them all play together well. But I really think it was too big of an ask given how much time we were spending on interoperability. So hopefully with this, a whole nother course here, we'll be able to make it work. Now, this is a new course. And I just told you our budget is constrained. So there is no blanket permission to go and set up new courses now on this campus, the way it has been in the past. The sponsor says I need XYZ, just go create a course for XYZ. That was usually the right answer on this campus for most of the 20 some years I've been here. And now it's not. So, so this course is going to be so there isn't teaching budget for this course. So this is an experiment. This is an experiment with the blessing of the computer science chair, who's responsible for the teaching budget that MOVES uses. So I think maybe we'll be successful. The idea here is that this course will be research supported. Now, what does that mean? So what that means is that the instructor, for it to actually be offered, the instructor will have to have a research project. We do reimbursable work here, right? Where we work for usually other parts of the government that are paying us for some kind of a deliverable. And the idea here that it will have to be some kind of a deliverable that the students could get to. After all, this is after 2 courses in networking already. The students should be somewhat capable, and maybe that's a realistic ask from them to do something, kind of real for the Department of Defense in the networking and interoperability space. So that would be the idea, that the professor is really doing research, but together with the students are getting academic credit for participating in the research. And we think that will pass muster with the administration. And so we haven't been told to stop yet. So I think that might be right. The next large block here, that's a big change that we will be making, is again relating to this military modeling issue. I'm hoping that, and I believe we have a small project set up to do that. Imre will be leading that himself, and probably will be the first instructor for this. But basically, we will set up a new 4920. That's our advanced topics label. So we had an old 4920, which was completely different. That one's going away. And here comes, enter the new one. And this 4920 will be focused on modeling as it actually exists for the important simulations for our students. That's the idea. So some of us will probably be knocking on some of your doors to try to help us, give us contacts so that we can understand what models are actually have currency out there in the so-called real world beyond the ivory tower. and make sure that that gets incorporated into this this course to spin up our students. So those two are the really big changes, and those are expensive changes because they're going to take some manpower to make happen. And then we have some smaller changes as well, which are going on in here. So the issue with wargaming, so wargaming also has been something that was an issue all the way back to the last curriculum review 4 years ago. And the way we tried to solve wargaming for the MOVES curriculum is to send our students over to Jeff Applegett's wargaming course 084604 in the OR department. And that is an excellent course. And again, that was another thing I was kind of surprised to see was not getting full marks from students and other stakeholders in terms of our Bloom's level we're getting the students to. But it seems like the weakness was specifically relating to technology supported wargaming, which of course for our students is probably the only kind that they're going to end up being involved with. And Jeff Applegett's course is or traditionally has been pretty conservative and oriented toward, it's not doing a seminar style wargaming, you know, with a human referee in the middle, but kind of tabletop wargaming with a paper map and cardboard counters. Okay, not the technology isn't there. But talking to Jeff, he seemed very amenable to, and he does cover, Jeff just written a book on wargaming, which is very nice. You've seen that. Book, I would recommend looking at that if you're interested, kind of a practitioner's guide to wargaming, very practically oriented. And it includes material that I think is halfway decent on technology supported wargaming. So I asked him if he would consider making sure the students are covering that material, because he can't cover everything in the book in a quarter course. That doesn't happen. And he was willing to do that. And furthermore, I see another opportunity there. So I'm actually, so we're doing another research supported activity here. I'm doing this personally myself. So the wargaming course is happening right now. And we have our MOVE students are participating in that wargaming course. And as an experiment, we have 3 of them are kind of pulled out to do technology supported wargaming for the first time, as far as I'm aware, at least for our students. In the context of Jeff Applegett's course. And I know our students are working really hard on this, and it's a really hard, it's a big ask of them. That's not an easy thing to do, but they're there, I think, for good or for bad, in the exact role they will be in, which is a pretty uncomfortable role, I think, if you're doing technology support of an actual war game. That does not occur without a fair amount of preparation and actual effort to make it happen. But I was able to participate and support this. It's research supported. Why? Because I'm working with Port Hueneme on a project right now, which is AI in support of wargaming. So with their permission, I was able to spend some of my time to support the students who are supporting another team of the actual wargamers responsible to Marfor Pack, who is the customer who is dictating what the war game needs to produce in terms of products. So it's pretty interesting, and this and I'll mention that also at the end of the day here. But if you happen to be around or local in a couple weeks, I think it's the week of June 1st when the actual war games are going to happen. Jeff usually makes that open to the public. It's unclass, this particular war game, so anybody can come in and actually watch it execute and hear the in briefs and out briefs for that matter, I believe. So we could possibly do even more in that area to make sure the tech supported wargaming to really kill that dead for the future. But it involves if it's going to be research supported, that means it needs a little bit of luck. So when you have a customer out there, it needs to be identified, who needs to be willing to support this kind of engagement by one or more MOVES faculty member. Okay, beyond that, and I'll leave that's the fine print for the rest of it. We have 5 of 12 issues, which is a substantial number of issues, but we felt they were smaller issues that didn't require a particularly great amount of effort or money to make changes to the curriculum that ought to be able to answer the mail for those issues. Okay, so at the end of the day, I'm going to stop talking real soon, just in case we want to have some discussion here. But this is the upgraded matrix. You see the CS programming course in there. Here you see for this year only, I guess, the computer science networking course there that will go back to 3,500, the moves course next year. And here you see the new, yet more advanced interoperability course, the modeling oriented special topics course, and the additional thesis section. And that's all I have to say. Are there any questions or discussion that we maybe should at least start now? Dave?
Yeah, Colonel Dave Parks. So I'm here with AMSO with Colonel Verde, but I also work in Futures of Concept Center, Army Futures Command. Graduated, I think, 8 years ago. So the only thing I'd ask, Chris, and it's not really, I don't want to debate it, but when you look at the Bloom's levels and how you correlate that between, if I took a course in Q1 and Q3 and then Q5, at the end of those 3 courses in my Bloom's level 6 on one of those 12 topics, was it really focused on one course within one quarter? And all I would say is when you add up the other things that you're trying to do as a student in that quarter, I'm not sure we're getting to a level 6. That might be what we're all saying we want our students to come out at, but there's no way most of those were level 6 that I feel like I came out as a student at a level 6. So it's just worth looking at. And just time and space. How much capacity can a student really accomplish in one quarter if they're getting to level 6 on 3 different courses in a quarter that's, 8 quarters deep for the entire degree. So it's just something worth looking at.
Yeah, you're not the only one that's made this point. I think that's credible. I certainly, we would be willing to support the sponsor if they wanted to do a dredge through the Bloom's levels and kind of refactor that to what you might consider a more, let's say to a more modest threshold. So there are a large number of 6s and 5s in there, and even up to a 4 is expecting quite a bit of maturity from a student in that.
And that's
area.
just because we brief it to a senior leader, and then a senior leader goes, "Holy crap, I'm getting a level 6 on 8 out of 12 areas." And then the Marine Corps captain back there, the young Dave Parks, comes to the first unit. And they're like, "I was told you're level 6 on all this stuff." And I'm like, "If you say computer program, it'll choke you out." Right. So no, that's a little joke because I wasn't the best programmer, but the point being, I think you're still getting the quality. I really do. I think you're probably meeting the intent. Certainly for the Army, I think we are. But when a senior leader sees that, at least for the Army, I know if the Sec Army saw that, she's an analyst and she would go, "Oh, I understand the Bloom's technology and I understand what that actually means. That means you have this much credibility and experience. And maybe we're not quite there when we just come out of the program." That's all I'm saying.
Appreciate it, Dave.
Okay. Captain Thomerson, I actually did the analysis portion for the curriculum review. So basically, sir, to address that point, not what we did was we established what the expected Bloom's level would be. There were very few level 6s. We don't expect level 6 across those knowledge items. So we're talking a very long list, I think just over 100 knowledge items, a very extensive list. Not many of those did we expect a 6 out of. There were several 5s, and like Chris said, there were some 4s. But what we do see is an overlap. So we do expect that the curriculum, based on that knowledge item, that the curriculum overlaps to obtain that level 4. So you're not obtaining a level 4 in a single quarter, you're obtaining a level 4 over the course of the entire curriculum. With that, just so understanding that there are analysts in the room and the Bloom's taxonomy is very squishy. When we did that actual analysis, it had to be a very large gap. So the students, the existing BIC holders, and the faculty were polled. If 2 out of 3 of them said that they weren't obtaining the knowledge item, then we flagged it by 2. So we provided a very large gap to say, knowing that there's a lot of flexibility within the taxonomy levels that we're using, we're going to provide a lot of grace that this is not, quantitative analytics we're talking about. This is all very qualitative type stuff we're talking about. So those 12 knowledge items that were identified were seriously gapped. The other issue that we have is a population difference. So some of the updates, like the LVC stuff that Chris Fitzpatrick set up, there was a gap that was established in 2019, but the poll that we have to take for curriculum review did not take those courses necessarily. So there's a demographic that did not take those courses. And there's my demographic that took those courses in their infancy. Then we had COVID. So those people didn't get hands-on. You need hands-on to do LVC to work. So what we're seeing is like a progression of that emphasis on the things that are important. Does that kind of pinpoint? So we're not looking at six, like by no means do we expect a M&S officer after the curriculum to have a lot of sixes across the board. A lot of those are 2s and 3s. We just need
Some of
to.
your caveats were really helpful. In fact, it's not on the slide, it's not on the voice track, because that gives more context. So somebody doesn't just walk away with a slide like that and go, oh man, look what I'm getting. And maybe that's not the case. You're really talking to the gaps.
Yes, sir.
Good morning, everyone. Chris Fitzpatrick. My name's been mentioned a few times, so I just wanted to. But one of the areas, and I think we might be able to get help from the external community, is in teaching the course. I would love to get on the NCTE or some of the secure networks that and I hear some motivation out there. So. But I think that would be helpful in giving students exposure to what they may see when they become M&S officers. So I just wanted to mention that. I don't know if that's an area where, if there is someone in the community that I could work with, because it is difficult to get on those networks. And I've gotten a number of different, cost estimates. I've got a number of different paths to follow, and I'm trying, not to go a circular route in doing that. So just wanted to mention that.
Anyone else? I'll ask one real quick. Oh, no worries.
Imre, you want to?
We had a question asking about who the Navy sponsor for the degree is, and Imre's going to answer that.
That's an interesting question. It used to be N2N6, and then in 2015, the Marines took over and N2N6 went away. Well, this curriculum review, literally last week, N2N6 was saying, how come we're not involved in this curriculum review? So I think we are getting interest. The IW chair here is actively looking at it. So I think possibly going forward, we might have sort of a co-sponsorship with N2N6 and the Marine Corps. We are starting to get students. We actually have one student graduating, one Navy student graduating this year, and we might actually have 3 Navy students coming in, 2 IW, I understand, and 1 SWO. So the SWO community, and this was requested by the SWO community to send somebody here. So we're moving in the right direction, maybe slower than we'd like, but definitely go in the right direction. So that's where we are on Navy sponsorship.
So the only thing I'll add to that is, since the Marine Corps took what they would call major area sponsorship of the curriculum in 2015,
when N2, N6, they didn't want to do it anymore. We have always viewed both the Army and the Navy as co-sponsors. We've never left them out of any curriculum review or the discussions associated with them. They're going to be there tomorrow. I think some of the things, I'm saying something a little bit jaded, I'm sorry, but it would be very helpful if the Navy would send more students to moves. I mean, I'm glad we have one, but that's not really turning over the apple cart in the sense. And I say that from the perspective of the Marine Corps because we are a naval service. It would be beneficial to us to have Navy officers working with our Marine officers, both here at the school and then to maintain those relationships when they go out into the fleet. So I think to push the point, it'd be very helpful if the or if the Navy wants to get re-engaged, to start sending more students into the program. And if they end up having the majority of students, we're okay probably with handing it back to y'all. Over.
We're lucky enough to have a remote speaker today. Dr. Kristin Giammarco from Systems Engineering is going to be speaking about Monterey Phoenix, a simulation that she's created and that has been working on here for Monterey for a couple of years, I believe, at least one I know. And anyway, I'll let Kristin tell you all about it. Kristin, please take it away.
Hi, and good afternoon. Thank you for having me as a guest today. It's my pleasure to be here with you to give you a presentation on the Monterey Phoenix capability. Monterey Phoenix is an approach and tool that I'm going to show to you a little bit. It was actually created in the computer sciences department at the Naval Postgraduate School. And it was done by Michael Augustin, who is now retired. He is a professor emeritus now. I've kind of taken over the leadership of the project since his retirement in order to promote its use, not only in the systems engineering community, but anyone who does any kind of simulations in order to fill out the behavior space for anything that they're trying to replicate the behavior of. So I'm going to tell you a little bit about this capability. First, what is Monterey Phoenix? It is NPS developed. It's a language, approach, and tool for rapidly and formally modeling mission, system, and process behaviors. Now, it says it's scope complete, and that is the distinguishing characteristic of Monterey Phoenix. It uses lightweight, formal methods in order to generate exhaustive sets of scenarios up to a specified scope limit. And that scope limit is the number of iterations you want or repetitions of repeating or looping behaviors. So we get all combinations of all different possible alternative behaviors that any element of your system can have, whether that is a simulated system, a machine, software, a human, behaviors, and environment behaviors, all of these things. And what it does is it supports the human cognitive process as we probe the models for characteristics that we want our system to have, properties that we want, but also properties that we don't want. And this is the hard part, shining light onto those unknown unknowns. What could go wrong that we might not think of in advance? What possible inefficiencies might there be in a process or a mission or a system behavior? What example scenarios could emerge in operations that we necessarily did not think of? Maybe some can cause serious failures or waste in terms of inefficiencies or cost ineffectiveness, identifying them for early correction. Risks for training, cost, schedule, technical performance, safety, security. And that final bullet, that final sub-bullet there really shines a light on what we can use this for. Finding assumptions we didn't know we were making, requirements we did not know we had, until realizing them in the generated examples that are coming out of the tool. So what this also has a big application in the training space. So if you want to train people on a process or train people on a mission through simulation, any kind of simulation, regardless of the application that you're using, the underlying engine for generating the different training scenarios could be Monterey Phoenix generated. You could have an exhaustive set of possible behaviors to put out all these what if scenarios for the users using these tools. So why model and why model behavior? For anyone who does any kind of simulation, you're probably familiar with this premise that good process and product design and good simulations have good behavior at its foundation. Most of the challenges and risks associated with anything that we model that has behavior are found when we separate behaviors and when those separate behaviors are allowed to interact and produce new behaviors or emergent behaviors. And we want that to arise in simulation. We don't want to be too prescriptive in simulation. There is some wiggle room there that we want to find and allow behaviors to emerge. And so the very way the MP behavior models are structured is it allows these behaviors to emerge in simulation because we did not tell it not to. We did not constrain it out. Unless we do constrain it out, in which case we start to shape our behaviors. So when we're using Monterey Phoenix to build behavior models, we can ask and answer certain questions. And that's what we all do when we run simulations. We have questions in mind that we want to know the answer to. For example, what is the intended sequence of events? If we're planning a process or we're planning a mission and we want to model it, what's the order of the events? Which events happen concurrently? Which events happen sequentially? Which events repeat? Which are decomposed into other events? Which are the alternative events? Which are optional events? We have languages for expressing all of that. And how many scenarios of all of these behaviors that we're modeling contain unexpected behaviors? So if we're not too prescriptive in our modeling specification, when we're specifying the behavior, we can run and simulate and get sets of traces, some of which will contain unexpected behaviors. What formal constraints then will prevent the unexpected behaviors, or perhaps some of them are just unexpected but okay, but some may be unexpected and unwanted, in which case we might have found and identified an opportunity to introduce a new constraint or new requirement that we didn't know about until we saw a scenario that had the absence of it. We might ask which events must be managed as an enterprise risk, where are the critical decision points, which events have the highest consequence if they were to occur, what is the expected duration of an event, of a whole sequence of events, what is the downstream consequence of an upstream disruption? What behavior patterns are present in the model? Can I identify a behavior pattern in my model that may very well appear in someone else's model, just called by different names? Maybe the events are in the domain language of a particular system and just need to be translated over. So these are the types of questions that we can ask and answer. So why use MP to do that, or why explore using MP? We can clarify and fix the ambiguity in less formal representations of systems and processes. The behavior modeling tools, and this is especially true in the systems engineering community, they don't enforce the same degree of formality. I am on the SysML specification team. They are coming out with a new version of SysML version 2 that is going to be more formal, but it still does not have the scope complete scenario generation aspect to it. So that's my involvement in them, is to try to see, can we leverage that aspect of Monterey Phoenix into the next version of SysML 2. It's also unlike any other approach when it comes to scenario completeness and consistency. So as I mentioned, this scope complete aspect, it's drawn out here on the bottom just to kind of illustrate what we mean by scope complete. Every trace that is generated out represents one instance of behavior, and the trace generation is automatic and exhaustive up to a scope limit that is defined by the user. So if you want to put a scope limit on the simulation run, it's done at runtime, and you say, I want a scope of 2, or I want a scope of 3. We use low scopes, small scopes. Then any loop that is in the behavior specification anywhere will not iterate past that limit. So if scope of 3, you're going to get loop iterations of 0, 1, 2, and 3, and all combinations thereof, anywhere there's a loop in the model. And you can do local scopes as well. But we only keep the numbers very small. with this approach. So we're leveraging this thing called the small scope hypothesis, that most flaws in models can be demonstrated on small counterexamples, meaning you don't have to run at very high scopes in order to start to see example behaviors that you don't want to keep. All those unexpected, unwanted emergent behaviors can be found at a small scope. So just to compare visually, typically we will have some kind of methodology, whether it's random or maybe following some kind of protocol for selecting the samples that you are going to test for, the test cases, right? With the scope complete approach, we are testing exhaustively every single possible case within a small bound. And so we're getting full coverage, but only within a small bound. But the small scope hypothesis says that most interesting things, if we do this full coverage here with the small scope, we can find a lot of them. Not all, not guaranteed to infinity, but just we can find a whole lot more than what we're finding now with current behavior modeling approaches. So this little analogy on the side here, this is Professor Augustin's analogy, where he compares, doing multiplication in Roman numerals versus doing multiplication with Arabic numerals. Some methodologies and approaches and tools are a little bit easier to use than others. This Monterey Phoenix approach and tool is meant to make formal methods accessible to lots of people that do not have PhDs in math or modeling and simulation and computer science. They're not skilled with formal methods and theorem proving and model checking, all very manually intensive processes that require years of expertise and experience. This is something that a lot of people can learn very quickly. In one picture, what Monterey Phoenix does for us is it takes what we normally see above the waterline here, like this iceberg, the number of scenarios we would normally model, we would normally think to capture. And it gives us visibility onto all possible scenarios that are also below the waterline here as well. Also keeping in mind that Monterey Phoenix models are still models. It's subject to the same limitations as any model would be. But it helps you to find more errors of omission than you would otherwise be able to find, because you're constantly probing that model and using it to identify the gaps in it. So it's a very iterative process. So we're able to find a larger number of scenarios with Monterey Phoenix by treating it as a model finding tool instead of just a model specification or behavior specification tool. We're actually using this model to discover and learn more about the potential behaviors of our system. The output is very basic. It's very simple to read. So it has the event traces come out as boxes and arrows, just simple directed graphs. They are arranged in columns similar to sequence diagrams. We have the top box will always be the root event. We often name the root event as the name of the component that is interacting as a convention. So we have boxes that are events. We have arrows that represent relations between the events. And there are two basic relations, precedence and inclusion. And we can also use user-defined relations, but those are just the two basic relations. The dashed arrow represents inclusion. So the sender includes a send event here in this example. And then we also have precedence relations. In this example, we have the send event precedes the receive event. And so we specify these relationships in a separate file. It's a text model currently. And then we generate from that text file based on the rules that we said what the allowable combinations of behaviors are that we then inspect to see which are valid, which are invalid, which we want to keep, which ones we want to reject, and we can shape that model accordingly. So I'll talk just a little bit about at the high level how this works. How the trace generation works. We start from excess. So think of an unpruned tree. You can choose which branches you want to keep and which branches you want to reject, because maybe you want to increase the amount of light that the branches are getting. You want to decrease the amount of pockets of moisture that could cause mildew. If you're trying to grow fruit, for example, you want to open things up. And so you can choose which branches you want to take out or subtract, and ends up with a finished selection that is likely to be more productive. It's the same kind of process, but we're using that now with our behavior modeling. We're taking an undefined shape and we are shaping it. We are removing the unwanted behaviors. We're generating an excess, a superset of possible behaviors, so that we can see all of them and then choose which ones we're going to keep and which ones we're going to reject. So each one of these tiny little thumbnails here is one event trace from MP. And the analogy here is this is our block of granite. And from the block of granite, which is all those event traces that MP generates unconstrained, we're going to choose which ones we are going to keep and reject. So by the time we're done shaping it, we may end up with just a small subset of event traces that represent the wanted behavior that we expect to see. The angel in the marble, so to speak. So I have an example here that I'll share with you by a student, recent graduate from our 721 curriculum, the PD21 Masters in Systems Engineering Management. Josh is a supply chain expert who works at Navier, and he wanted to do his thesis having to do something with supply chains. And so he models the supply chain in Monterey, Phoenix. This particular supply chain problem was of a system software that was under development to serve as a marketplace to find parts, components from different suppliers of personal protective equipment during the COVID-19 problem. And he used Monterey, Phoenix to find both desired and undesired behaviors of this app and of the whole supply chain that the app interacted with as well. So he modeled the app and he modeled all the environment behaviors as well. He found a couple of examples of behavior. He found undesired but expected behavior. No surprise to him that this scenario came out with his expertise, where we had a disconnect between the customer, the app, and the delivery service, resulting in shipment not arriving as expected. We've all experienced that. He also found, given his expertise, he found some examples of both undesired and unexpected scenarios. And here's where we really contribute something. We have somebody who has some expertise in this area, years of working, that learned something about his own system or process. He was able to use his expertise in order to identify potential surprises that would have been surprising had it happened in the real system, but he was using a simulation environment to get ahead of that surprise and basically be surprised early before it was tested or deployed. And these two scenarios were that he found a counterfeit part made its way into the supply chain via the app. And he also found a scenario where there was non-conforming material making its way all the way back to the customer through either miscommunication or lack of inspection. And so he was able to make recommendations based on those findings, those insights that he gained just from inspecting the MP scenarios. So this is what an MP event trace looks like. And it just shows these, the boxes and arrows and the relationships, the dashed arrows being the includes, the solid arrows being the precedes relation. Pretty intuitive to read. The customer submits a request. The app receives the requests and submits the request to the various part suppliers. And each of the part suppliers has their own lifeline here where they're doing their activities. And he's reading this trace, and then he realizes, he gets up to this part where the component supplier finds that the material is non-conforming, and then they ship the material anyway. And The finished part supplier gets the material, does their thing, and then ships it back to the customer. And so by virtue of this combination of different possible events in different columns, we are able to help users identify possible misbehaviors of the system. So I have a couple more examples, but I'd like to leave some time for questions. So I'm just going to go through very quickly. We had another student do a supply chain analysis, and this was a cyber attack risk that she looked at, where we had 2 cyber threats and the Colonial Pipeline. And this predated the actual Colonial Pipeline attack, but this one was a physical attack that was modeled. And we have, she demonstrated the ability to assign event attributes and properties to these events so that we can start to assess things like risk. So she assigned a risk to each of these events, a subset of events that carry risk. She identified which ones carry risk, and then which ones, how likely they were, and then what the impact for them would be in order to compute a risk score for each event. And then adding up the events in the same scenario would get you an overall trace risk. And when you're generating a whole exhaustive set of traces, you have now properties for all those traces, and then you can do global queries such as, what is the total risk over all the traces? What's the highest risk? What's the lowest risk? Sort them in order of risk. So you can do a lot of different queries with it once you have all of that modeled, and it's all done on a scope complete set of scenarios, which means more data to work with. So in summary, we have a capability here. It can reliably, repeatably, and rapidly find exploitable, unwanted behaviors that are latent in a design. It's scope complete because it generates the exhaustive set of event traces up to the specified scope. It's workforce accessible. We have a couple of tools. They don't require expertise to use. We've had hundreds of college students learn this tool in about 5 weeks' time and find behavior that the expert did not expect to find, that surprised the expert. So this tells us this is something here. The graphs are intuitive. You could see the layout of the event traces resemble sequence diagrams, something familiar to a lot of people. We can also generate activity diagrams, state diagrams, component diagrams that are familiar, and all extracted from a single MP model. So they're guaranteed consistent. We can also do custom graphs that show dependencies that are interesting to you. You can define what your own graphs are. We can also support queries and assertion checking. So if you know what you're looking for, I think the beauty of this tool is it helps you find what you don't know you're looking for. It's exploratory, but when you do know what you're looking for, you can query for it. And this is helpful when you have a large set of scenarios and you know you want this property to be absent from your design. You can set up a query in order to find any scenarios where that assertion fails, where it's true or false. So you can refute assertions with this. Finally, we have support for event attributes to support quantitative reasoning. And this I showed you very briefly with the risk analysis, but we can also assign time, cost, power, anything quantitative, any quantitative resources. We can assign probabilities of occurrence as well. We can capture conditional probabilities and Bayesian belief networks so that we can calculate whole trace probabilities. We can generate reports, tables, charts, summarizing properties of interest at both the local event trace level and also do global queries across the whole set. What I'm most excited about for this capability is its ability to serve as a trace generation capability underlying other simulation engines in order to make those simulations even more realistic and full of different alternatives, different variability in scenarios. So you don't see the same scenarios a lot, but you have a big variety of different possible scenarios. And the training applications of this, I think, are really plentiful, because now you can have tools that the users, the trainees, interact with in order to play through very many different scenarios, including failure modes and other things that you want them to have experience with, but not in real life. You want them to have the simulated experience with it so that they know what not to do. So I'll leave on this slide and I'll turn it back to Perry to moderate for questions.
Okay, thanks, Kristin. I think we have time for maybe one quick question. If anybody has one?
A question about sort of the whole problem with simulation with garbage in, garbage out, or garbage in, gospel out. How dependent is it on the accuracy of the documentation or the truthfulness of the people doing the reporting? I mean, for instance, I could see that the person who shipped the bad part might not want to declare that it's a bad part on the inventory sheet before he ships it.
So yes, I get it. So the interesting thing with these scenarios, and I'll just go back to that slide, is it kind of gives you this omniscient view of the whole scenario unfolding. So that event right here, it says material non-conforming, but does that mean they know it's non-conforming and they shipped it anyway? Or does it mean it's non-conforming, but they shipped it anyway? Maybe they didn't know that it was. So it leaves the room for interpretation, and it allows you to war game these different scenarios on your team and say, well, how could this happen? This describes something that happened. So if you look at this as something historical, you can say, okay, how did it happen? And you can take it apart and analyze it and say, well, maybe they accidentally shipped it, maybe they didn't know, maybe they skipped this part of the process. And that right there is where the subject matter experts come into play, because they know how all these interactions take place and work, and so that they can play out circumstantial events and scenarios in their heads over how that could happen. And that's another training application, right? Because you can say, this happened, now tell us how it happened, tell us a story to make this an operationally valid scenario. And maybe you can come up with even more than one story over how it could happen.
Great, thanks, Kristin. I think that's all we have time for. So thank you very much, Kristin.
You're very welcome. Thank you very much.
We appreciate it. We're going to try to see if we can get, she does have a colleague on campus, and hopefully he's going to be part of the demo night tomorrow night. So we're going to see if we can make that happen. So hopefully there'll be some more time to come and check out Monterey. So thank you very much.
Bye now.
Okay, not many of you, or some of you may know that the area where Moves is what's called the Moves Annex, or excuse me, the small annex. Mike Zida tried to get them to call the building the Moves Building when they were building it, but that kind of like fetch, that didn't happen. And so, because it was built afterwards, and when they were building it, one thing they looked at was, Mike went out of his way to make sure to get people from TRAC over here. TRAC is the TRADOC Analysis Center, or was at the time. And so they are on the floor right below us. And it's great because we have a lot of work with them. So we're glad to have Lieutenant Colonel Brian Wade, who's the director of TRAC Monterey. And he's going to brief you on some of the great research they're doing down there.
So again, my name is Lieutenant Colonel Brian Wade. I am the director of TRAC Monterey, which is now the Research and Analysis Center. So interesting story. So we were part of TRADOC, the Training and Doctrine Command, part of one of the Army's, at the time, 3 major commands. And so our mission was always to look at what the Army is going to look like in the future. What material solutions should we buy? How do we fight? How do we organize? So when Army Futures Command was stood up about 2 years ago, we got moved over into AFC, Army Futures Command, along with many other organizations, all looking at what the future of the Army is going to look like. When we did that, there was a certain amount of brand recognition behind the TRAC acronym. And so we needed to keep that. And so we had to back out a new name, which is ultimately where the Research and Analysis Center came from, sort of like the Ohio State. But like I mentioned before, the mission of TRAC didn't change, even once we moved over to Army Futures Command. And so we are still concerned with how are we going to organize? How are we going to fight? What does the future of the Army look like? And so at this point, TRAC is a DRU, a direct report unit to the CG of Army Futures Command, who is currently right now Lieutenant General Richardson, the acting CG, until we get another one probably in the next couple of months. TRAC itself is a geographically dispersed organization, 4 separate centers. Fort Leavenworth, Kansas, probably our biggest center, which does brigade and above operations. And then you have White Sands Missile Range, New Mexico, individual soldiers up to brigade level operations. Fort Lee, Virginia is sustainment. And then us out here in Monterey, we are the research and innovation arm of that organization. And so our general mission is to look out across what do these other centers require? What does the Army analytic enterprise require? What does the DoD analytic enterprise require? And then we do the applied research with students and faculty here at NPS in order to realize those results. So when you look at TRAC itself, the bread and butter of TRAC is operational effectiveness. And so understanding what is that operational effectiveness as we change the organizations, materiel, et cetera, within the Army. And so we do that primarily through the studies, as well as we're the Army's proponent for the SSA scenario, support strategic analysis scenarios. But then the bread and butter of TRAC really is the M&S, the models and simulations. And so as we start to look at what that future force will be, we maintain a suite of multiple M&S tools that I'll cover in a few minutes, which is ultimately where the partnership with MOVES was born. And so as we start looking at how do we advance those M&S tools, many of those projects are partnered with MOVES. Hopefully, oh, there you go. Okay, so again, ultimately, our primary customers are the Army Futures Command. We do work across DoD. And so ultimately, when we find interesting problems that all the services have within their M&S, and so it's routine for us to partner with, for example, the Navy, advance some type of Navy simulation, but recognize that there is some aspect of doing that we can eventually port back over and modernize some aspect of the Army's types of simulations. So we'll go off, we'll find various DoD sponsors, Army Futures Command sponsors, pull them in, as well as then working with, of course, the NPS students and faculty. The advantage of working primarily with my team is that I have full-time analysts on my staff. And so I have 5 FA-49s and 1 FA-57, all of whom usually straight out of grad school, occasionally have one operational assignment beforehand, but their primary duty is to find these sponsors, work with the sponsors, develop the plan, because as we all know, most of the time the sponsors know they have an issue, but can't articulate it or can't articulate it well. So how do we scope that problem? And then eventually, how do we take that problem and piece it into various chunks that a thesis or a capstone student can do? And I am free to work across campus. And so while MOVES is one of my primary customers, I work with operations research, with math, with systems engineering, et cetera. So as I take these problems, we dissect them into the various parts. My analysts will typically form cross-functional teams where this part of the problem is a systems engineering capstone. This part is a MOVES advancing the M&S. This part's a data analysis. We'll give that to the OR. And then my analysts will partner with those students. We can be second readers, co-advisors on theses. And then we're also act as that single point of contact back up to the sponsor. And then typically at the very end, pull together all those various products, the systems product, the OR product, the MOVES product, into some coherent package back to the sponsor. Yep. Oh, good idea. Mm-hmm. Oh, what? There we go. Wow. Okay. I didn't know that existed. All right. So I mentioned before that we have a suite of M&S tools. And so this is the suite that TRAC controls. AWARS is run out of Fort Leavenworth, Kansas, and that's our brigade and above simulation. AWARS, was developed by TRAC, it's maintained by TRAC. It's run on a closed SIPR network, and so it only exists on the SIPR side. But when you come down to the other list, those are more accessible to us. So Combat 21, jointly developed by the Army and the Marine Corps. So it's used by all the Marine Corps analysis agencies, and of course, us out here. Okay. Used, of course, by us out here. And in fact, out here within the MOVES department, Combat 21 used extensively. Imre Balogh, one of the primary developers originally on Combat 21. So a lot of experience within the moves department. VAST is our wargaming tool, and so it's used for distributed wargaming, developed initially in Java. They're currently in a process of porting it over to R, and that's really to get across some RMF processes. But again, another pretty powerful tool. Logistics Battle Command used at our logistics center, Fort Lee, Virginia. And again, developed out here, Dr. Arnie Buss. I didn't see him when I came in, but again, one of the primary developers in the moves department for LBC. And then of course, we have multiple other types of tools. So I mentioned before, again, I've got a pretty large team. I also got 6 analysts plus myself. We currently have 37 students, I think, at our last count. So we were able to very quickly expand our capacity to take on a rather large number of projects. So what you can see here is what I currently have ongoing in support of various sponsors across DoD. The red box is the ones I'm going to touch on in the rest of this briefing that really deal more with the moves department and I think are more applicable to this audience. And again, primary purpose of presenting these is I'd love to see if there's any type of collaboration in this room that I'd love to be able to partner with you all moving forward on any one of these projects. So starting off with the first one, this is our M&S effort, moving to the cloud. So across the Army, and I'm sure this is the same across the services, the Army is starting to look at data centers and starting to close them down. Data centers meaning that you have a designation that you can buy servers and maintain your own set of servers. And so in each one of our centers, we maintain what we call the farm. So large 256 core, server stacks that we can send our M&S tool, run them there. But those require upkeep. And so we have to, of course, buy new pieces and parts for them every couple of years, refresh them. The Army, so TRAC itself currently has got a stay of execution on the closing of our data center, but the writing is on the wall. At some point in the future, the data center is going to close. We're not going to be able to refresh our stacks, and we're going to have to move our M&S to the cloud. So one of the efforts we've started is we started looking at how can we efficiently port some of our M&S onto the cloud. And as we've very quickly realized when we do this, you can rack out the cloud bill very, very quickly if you don't do this correctly. And so we've done several, about 2 years ago, we did a bunch of cost benefit analysis looking at moving on to AWS, Amazon Web Services, moving on to Azure. And then we also started an effort looking at the DoD high performance computers. So DoD maintains a suite of HPCs that you can use for free, but they are shared resources. And so at this point, this entire project has been managed by my FA57. This has been his life for the last 3 years, managing this massive effort across TRAC. And so he is managing a team of about 50 or so analysts looking at these various efforts. We've made the most strides at this point really on the HPC effort. And so we have at this point, through a partnership with what's known as the PET proposal, a productivity enhancement to training proposal. So by doing that, we got free SME support from ARL, Army Research Lab, that partnered with us to give us some computer scientists to help us learn how to efficiently run our simulations on the DoD HPCs. At this point, we've taken a brigade-sized simulation that took about 9 hours or so to run on our 256 core farm, got it down to just under an hour. And so what that's eventually going to do is allow us to expand this capability of our simulations. The advantage here too is that this was a free resource compared to, again, some of the ways you can rack up some big costs, but it is a shared resource. And so you do have to wait for your turn. But one of the ways we got kind of around that, or we found an innovative way around this, is we're actually doing a technique called dynamic load balancing, where within the HPCs, as opposed to requesting, for example, 256 core and waiting for those to become available and then running your large simulation, what we do is request one core 256 times. You can imagine that. And we sneak in between other people's jobs, primarily because when you're doing a Monte Carlo simulation, each one of those is independent. You do a parameter sweep, each of those is independent. So as long as you've run those, you can recompile on the back end and do all of your post processing. So again, we're making a lot of progress here. The next major effort that we're currently working on is how to do an entire end-to-end study on the HPCs. And that really gets at how do you efficiently move data to and from the HPCs. So you can imagine that at this point, getting cores is not the issue. getting data through the pipeline to the HPCs is the issue. And then of course, pulling the gigs of data back can be an issue. So we're looking at what data can we pre-position up on the HPCs? What data do we have to do locally in order to do your scenario integration? And then how do you efficiently port that up to the HPCs? And then ultimately what data has to come back and what can you just keep on the cold storage up on the HPCs? So again, if any organization is looking at how to efficiently move to the cloud, we're currently working in this area. I would love to hear what you all are doing and how we can partner on that. Another effort that we're working on too is artificial intelligence, or really reinforcement learning for a combat sim. This is actually done with Dr. Darken here in the front. I know he's presenting on this later, so I'm not going to steal all of his thunder, but I'm really going to get at to some of the things that we were looking at doing more in the future. Again, looking at how we can do some amount of integration. So when we take a look again, one of our primary tools that we have is VAST, which again is our wargaming tool. The advantage of VAST is that I control the backend. I control the developers in Track that actually maintain that. One of the things that we have found trying to do reinforcement learning in a combat sim is most of our combat sims aren't built to do reinforcement learning. They're not built to export the state space at runtime or re-import new actions at runtime. And so our first iterations of this about 2 years ago, we looked at multiple simulations across DoD and ultimately found most of them didn't work, which is why we went back to one that we own, because I could actually get the developers to build me hooks into the back end of VAST that I can actually now do the reinforcement learning. So once we did that, we then partnered here with Moves, again with Dr. Darken, using actually his homegrown Atlatl, which I know he'll cover later on in another brief, so I'm not going to touch on that. But we, in essence, train our agents in his homegrown system, which again is using the OpenAI framework, kind of the bread and butter of reinforcement learning at this point. And then one of the things that we have done that I think is different than there's several other agencies that are trying to do reinforcement learning in a combat sim. One of the things that I think we're doing that's unique is we're not centered on a very specific scenario. A lot of other agencies are trying to fight the National Training Center or fight the Fulda Gap in Germany or something, picking a given scenario. What we are doing is we're scenario agnostic and we're trying to teach the principles of war. So how do we teach an agent really to think militarily that we can then hopefully port it to multiple different scenarios? So at this point, you can see that we have actually gone through and have at this point demonstrated. And at this point, we're still fairly small in our scenarios. And so we're at the 5v5, 10v10-ish range. We currently have a student that is looking at hierarchical reinforcement learning, which is ultimately where we're going to start to see this hopefully scale. After it scales, then we can start looking at some of the other things, like, for example, unity of command, security, et cetera. And then one of the other aspects I would like to do is port it into a more sophisticated adjudication system. And so again, Combat 21, one of the track scenarios, also jointly run by the Marine Corps. We, of course, have developers here at NPS. So again, able to get into the back end of the system in order to do reinforcement learning. And that's probably our next major milestone after we can get to the hierarchical to scale it. How can we then start to do this on an actual DoD recognized combat sim? As I'm going through, if you have any questions, please feel free to jump in too. I should have mentioned that at the beginning. Next project I wanted to cover is also the Project Convergence. So some of you may be familiar with Project Convergence. It's an annual exercise that Army Futures Command runs. But at this point, PC is a joint, and actually in next year, PC 22 is also going to be coalition. We have several partner nations coming to join us. So it's a massive exercise. When I say massive, we're talking hundreds of people that are testing different technologies. And so technologies, anything from TRL 3 on up. So technologies that are ready to be fielded, the technologies that, hey, this looks possibly interesting. And the Army puts these in the hands of soldiers, puts them out in the field in order to test how well they work, and then to examine various concepts with those. And so the large PC event that JMC runs it, and then ATEC, of course, has a large Army Test and Evaluation Command has a large role in that. A lot of these are run on various ATEC ranges with their instrumentation, but TRAC is the analysis arm of PC. And so a partnership between TRAC, DAC, the Data Analysis Center, and ATEC, the Army Test and Evaluation Command, all in charge of the analysis of it. But you can imagine coming out of PC, again, hundreds of people, hundreds of technologies, you have terabytes worth of data that is harvested during the actual event. And so the reduction and analysis of that typically takes weeks to months to produce the final report. The problem is during the exercise, the GOs, the general officers in charge of this, don't want to wait weeks or months to see what happened. And so that's really where TRAC Monterey came in, is our main goal was to produce what's known as the in-stride analysis. So as close to real time as we can get. At this point, real time is within a couple of hours. And so as the exercise is ongoing, we pull various aspects, not the entire terabytes, but various aspects of the data in order to very quickly post-process and then push out dashboards that are then shown at the daily stand-ups, et cetera, so that people can have an understanding of what is occurring during PC. Just to give you an idea from PC 22, and so the data that took place last year, we produced various visuals such as this. For example, one of the big things was reducing the sensor to shooter time. And so you imagine in the exercise, we had UAVs that were out flying. You then had various artillery tube shooting at it. And so what we were able to do is do the exercise, map out how long it took us to identify a target, how long it took us to process, then to fire the target. And then we showed that, and ultimately, hopefully you can show learning in a reduction from the base case. And as we inject these new technologies, you get faster and faster sensor to shooter. Additionally, what we found in PC, you can imagine if you're trying to duct tape a bunch of technologies together, that network becomes a massive issue. And so we're able to demonstrate, criticality of the network, where we had various nodes that were going down, important nodes going down are important to know so that we recognize when things are happening, but data is not being collected. And so we produced various of these types of graphics. So at this point, we had several students who have worked on PC 22 data that have then produced various graphics. Moving on to PC 23, what's taking place next year, it's actually part of it is taking place at the National Training Center. So National Training Center, Fort Irwin, California, the Mojave Desert, massive training center for the Armor and Striker Brigade combat teams. So one of the things we did is we reached out to NTC a couple of months ago, recognizing that PC 23 taking place later on this fall, taking place at NTC. We partnered with them, recognizing that they harvest all kinds of data to support their observer training mission, and ultimately see how can we help them on that mission, but of course also get us ready for PC 23. And so the CG was ecstatic. We were down there. We met with him personally, and he ultimately directed us primarily to look at fires and at sustainment. So looking at those, we were able to gain a large amount of data. You can see the data over here on the right side. A lot of our logistics data is actually just pulled straight from Advana, Vantage, as well as some of the other various logistics platforms. Fires data, they maintain a separate database, and so we're able to get that database downloaded really quickly. And I currently have multiple student teams, multiple capstones that are producing applications that we're spinning off, sending down to the OCs in order to help them facilitate and expedite their AAR products. Additionally, one of the data sources that I haven't tapped into yet, and on the top, I have the CTC-IS, Combat Training Center IS. That's like your GPS and miles gear, like laser tag data, as well as your webcast data, which is all your contextual data. And so I have all that. It resides on SIPR. My analysts are just now starting to pour through that data. And so there's likely going to be a lot of interesting things that resides there. So again, if anyone does work with combat training centers, I would love to talk to you to see how we can partner on that. And so again, one of the things we're really working on at this point, the sustainment and the fires. Eventually, as I pour into that CTC-IS data, we're going to start looking at long-term trend analysis. And so the effectiveness of anti-tank weapons is one of the big questions we were asked, given what's happening currently in Ukraine. And then, of course, as we gear up and get ready for Project Convergence 22, part of which taking place at NTC, we'll hopefully have the background in order to leverage that data. Additionally, the Army within Army Futures Command has the Army Software Factory. So this is where the Army partners soldiers that have coding capabilities with industry experts in software development. and they produce various applications for the Army. One of those projects is looking at how do we streamline the fires data collection. So at this point, the only way fires data gets captured in NTC is if an OC is standing by the radio and hears a fire mission coming in, at which point he literally either puts it on his phone or like writes it down and calls it up on a separate line. That gets inputted at the TAF, kind of like imagine like a TOC that's supporting the fires. And it's literally, they're writing it down like ATC style, like on this piece of paper and passing it down the line, adding new information that eventually gets into a database. So it's a little bit, it's obviously working, it's working for them, but it could be streamlined. And so we partnered with the Army Software Factory, who is developing a web application for the OCs to carry around to very quickly input the data once, have it stored and basically shot out to everyone else. And so they're producing that data collection mechanism. And then they're going to, obviously we're partnering with them to leverage their database on the back end to produce the various visualizations. I think I got, well, nope, okay. All right, last one, and I promise I'm done. Open house, please come down to our area. I got one student who was looking at developing VR technologies in order to do vehicle identification. And so this was down at the Intelligence Center of Excellence, and we'll have a demo down in our area, so please come down and talk to us. All right, so with that, I am out of time. Again, I'll be around in front. If anyone has any questions, I would love to talk with you all. Thank you all.
I'm the advisor on that, so that's why I gave him the extra second to present that one. So our next speaker is Dr. Susan Aros, and she's going to be talking about the wrench project that she's working on with several people here at Moves. And so Susan, are you ready to take it away?
I am, thank you.
Okay, great, thank you.
Hello, and thanks for allowing me to present remotely. My name is Dr. Susan Aros, of course. And to give you a little background on our work, I and Dr. Imre, we co-lead a large cross-functional team to research crowd dynamics and also broader human behavior. We got involved in this stream of research by Steve Hall, who many of you know. So he brought us in, and then as he retired, we picked up the stream of research. I expanded the research team and are working on bringing in new sponsors. But here's bringing to fruition what he had initiated is modeling potentially hostile crowds, and particularly with a focus on exploring the effects of intermediate force capabilities and rules of engagement. We're doing this currently under funding from the Joint Intermediate Force Capabilities Office. So just a little background on intermediate force capabilities in crowds. So the effectiveness of the intermediate force capabilities varies depending on crowd behavior, characteristics of the crowd, and the response of the crowd to use of intermediate force capabilities is complex and difficult to predict, depending on many, many factors. Aspects of identity and group membership influence the crowd response, and often that influence has unexpected outcomes. Existing intermediate force capability models generally focus on the effects of intermediate force capabilities on individuals. So we're working on the crowd modeling research with intermediate force capabilities to determine their effectiveness. But historically, crowd modeling research often focuses primarily either on the crowd being many individuals or a crowd being a unified whole, the sort of mob mentality idea. So what we found in social science, crowds are composed of smaller groups and smaller social identity groups. Individuals remain individuals in a crowd, but they are also heavily influenced by their group, by others nearby, and by other social identity groups nearby. So social identity groups, or SIGs, they can emerge in the crowd anew. They're dynamic, and those changes are one of the things we're most interested in. Group members do generally stay together. They sort of have a live or die together in the crowd. However, there can be very compelling reasons for someone to leave a group. People's actions are affected by their social identity group and also their attitude toward the forces. intermediate force capabilities don't just impact the individual. So the effect of the use of intermediate force capabilities, so the impact of an intermediate force capability, not only affects the individual directly impacted, but also anyone in the vicinity who witnesses that impact. Individual assessment of individual, I'll start saying IFCs, sorry. Individual assessment of the IFC impact. So the view about that, the interpretation of that impact of that weapon depends on who is hit and the witness's perception of that individual. For example, if a child ends up getting hit, there's a much different response than if an adult who was behaving in a very aggressive manner was hit. So to understand and model crowds, we really need to use a multi-agent model that includes both individuals and identity groups as agents. We need to break down the different types of participants, gender, age, and then I missed a carriage return here. We also need to model the SIGs as dynamic agents themselves. We have to include the effects of SIGs not only on their members, as well as those nearby and on other groups. We also need to include in the use of the IFCs, we need to include both intentional and unintentional effects of the weapons. We want to track attitudes and beliefs towards the authority and security forces, since that significantly influences the responses of individuals and groups. We also want to represent a variety of beliefs and objectives of individuals within the crowd, and these change dynamically. So just a broad overview picture of factors influencing human behavior. The center purple circle is the individual person, and within a person, we have all kinds of things going on that will end up motivating their behavior. They have their personal goals and intentions, the behaviors that they're currently engaged in, their emotions, their basic needs, think Maslow's hierarchy of needs, their trust of others, identity group affiliations. And then they have the influence of the external environment, the physical environment, the other people and groups nearby, the presence of the forces, and the group that they do identify with, that influence on them externally as well. And then we have the weapons impacts, what they witness and what they experience directly. So there's a whole lot of things we need to consider in what drives human behavior. So to address this, we use the bottom-up modeling method of agent-based simulation. So decision makers are the individual agents. Keep in mind, we have individual people modeled as agents, and we have groups modeled as agents that are more than just the sum of their parts, their members. Agents act independently of each other. However, they influence each other quite significantly. Crowd behavior then emerges as a result of these individual agent actions and interactions. And we, of course, can have random stochastic elements within the agent-based modeling realm. And agent-based simulation is it's the best modeling method for modeling complex human behaviors. So we've put together the workbench for refining rules of engagement against crowd hostiles. So that's denoted as wrench. It's the agent-based simulation model that we have coded in NetLogo, and it explicitly models the people, the groups, the security force members, all as independent agents that are interacting in this physical environment. And the environment is designed using a GIS data set. And the security forces can use intermediate force capabilities according to specified rules of engagement in response to hostilities that they perceive. So we incorporate multiple aspects of PMISI. I'll just mention we explicitly have the military, social, information, physical, and time elements. Some of the higher level elements, political, economic, infrastructure, some of that can be set by the scenario parameters, but the others are modeled as part of the interaction and dynamic environment. So just a little bit about how we model the humans. So the individuals, and these are individuals in the crowds, these are the civilians, they have internal states, they have their objective, their intents, cognitive intents, and then behavioral intents. And then they also have immediate emotional reactions that can occur. And they have their movement, whether they want to go forward towards the forces to attack them, whether they want to run away, or whether they want to just stand around in a protest kind of stance. So they're influenced by their social identity group, also people and other social identity groups around them. They're also influenced by the experienced and witnessed weapons impacts. Those can directly influence some of those internal states or those objectives, particularly the reaction, the immediate reaction. But those experienced and witnessed weapons impacts heavily influence the internal identity state. So inside a person, keep in mind, we do have their objective, and there's 4 objectives that we model: none, so this sort of wandering or window shopping, protesting, attacking, or staying safe. And we have also more detailed intentional states and behavioral states to affect or towards that objective, whichever they have. Every individual, their identity state includes basic emotions, anger, and fear, their beliefs about the legitimacy of their forces, their hostility, their level of hostility or intent to be hostile. We also have basic needs statuses, a sense of potency, how powerful they feel they are in the face of the situation. And then it's not their identity, but their physical injury level is also comes into play. So we model social identity groups. 2 kinds of social identity groups we create as part of the population characteristics at the start of a simulation run. So we have family social identity groups of different sizes that can be specified by the user, and social identity groups, things that can be specified by the user, and they are formed based on a characteristic of the people. So the common characteristic or shared identity characteristic is what those groups are formed based on. And then these groups can change dynamically over time during the simulation run as well. People can join groups, leave groups, and entirely new groups can be formed, and groups can be completely disbanded as well. Just very briefly, our modeling of the security force. So we have the individuals, DIs are dismounted infantrymen, although they can be in a patrolling squad and actually be mounted on a vehicle if they're in a patrol state. So we have vehicles.
Susan,
yes. Sorry, you cut out. Did I cut out? Uh-oh. Okay. Can you hear me now?
Okay, yeah, it looks like we've reconnected somehow. So Zoom looks like it reset. I heard you now. So please continue.
Okay, so and I just got a text from one of my team members that I faded out on slides 11 and 12. So we have different kinds of groupings. We have groupings that represent families. We have groupings that represent social identity groups that have a common characteristic that they form based around a common identity characteristic. And the forces are modeled as a compound squad who is defending or securing a compound to start with. And we have patrol squads that are on vehicles driving around the area, securing the area. So we don't have the detailed psychology and motivations within the force members. That's actually a future project that we're looking at doing. Will to Fight has done work in that area. We can incorporate some of their learnings. We've been in touch with the folks that came up with that model, and others, actually a couple groups in England have been working on these kinds of issues as well. So that's a future that will be moving into that realm. But the security forces right now are just simply either the securing or defending. They're either in an overall command says we're patrolling or command says we're defending. So primary security force decision-making consists of discerning hostile intents of the people, deciding which threats to address, and deciding the method of engagement. So threat assessment, we design how they're determining threats, and then how they select a target and how they select a weapon to use. So Wrench has three main user interfaces. We have an animation screen I'll show you in a minute, which has lots of different things that can be controlled about the population and the force characteristics. We also have separate screens that I won't show today where you can select which intermediate force capabilities to put in the hands of the force members, and also design tactical rules of engagement to help determine those questions about how to select a target and which weapon to decide to use. So this scenario map may be familiar to some of you, but we are using this compound defense scenario. You see here, I've enlarged the people so you can even see them at all. But they are gathering around the compound, wanting to protest, and some may want to attack. So we see also that there's red dots right now. Color-coded on the right, the bar chart, we have color-coded what severity level of weapon is being used. So there's psychological weapons, there's physical pain weapons, and then there's also lethal force as well. And we monitor population composition and some of the outputs. So we can run Wrench in this animation mode to watch what happens over time and interact with it as well, or we can run it in a headless mode and do data farming experiments with it. So we have many output metrics we could look at. So we want to look at frequency of the use of IFCs, severity levels, what IFCs are being deployed, what the people's hostility levels are currently and their objectives, what's driving their immediate behavior. So there may be operational implications from those things. And then their objectives that they hold on to longer term, their longer term anger and fear levels, and also changes in their beliefs about the security forces, particularly the legitimacy of the security forces, can even have strategic implications longer term. So I just want to throw up a couple slides here. I'm just going to do a time check real quick. I have until 45. Okay. So here's a couple charts where we did a large scale data farming experiment testing varying a number of different parameters. When we look at the changes in hostility level of the people, on the left, we have different intermediate force capability options. We tested 6 individual types of intermediate force capabilities, and then a couple pairs, and then the option that we gave the forces, all 6 of them. And then on the right, we have the results separated out by different sample rules of engagement that we put together for testing purposes. So we see that we get some difference in the change from the start to the end of the run of the hostility levels of the people, but how level this is slightly misleading, because we can also chart time series data that shows larger changes in hostility, but the hostility of the people rises, and then as the situation, so the start to finish difference isn't as significant as what happens over time. Another thing we can chart here is the change in people's legitimacy beliefs. So how legitimate do they believe the forces are? And I separated out again on the left, that's separated out by different weapon or weapons types in use by the forces. And on the right, I separated it out by rule of engagement. So we see here that we can have very, very different results in terms of the beliefs of the legitimacy of the forces by the people that can have especially longer term strategic implications as well as immediate. Here we see it looks like all the legitimacy beliefs went down, but it's not true for all the scenario, all the runs, all the design points. Just on average, we ended up having them all go down. And here's an interesting one. We have some new functionality in the code where people start to accumulate injuries over time. If they're hit with multiple pain IFCs, they can accumulate injuries. And then if it's a more severe IFC, more severe level pain IFC, it can actually kill them unintentionally. So we see that on the left, there's certain kinds of weapons can tip someone over into death, cause enough additional injury that it can cause them to die. So we expect to see bars in some of those cases and others without any unintended accumulated injuries. But on the right, we see with different rules of engagement, some rules of engagement rule sets caused a great deal of unintended deaths and others caused very few. So that's interesting results that we can look into further in our analysis. So here's the one I think is most interesting. This is actually the change in the objectives of the people. So the forces can't observe the objectives of the people. All the forces see is the behavior of the people, whether they're approaching to attack, whether they're running away, and particularly how they're responding to getting hit with or witnessing the deployment of different intermediate force capabilities. If they keep coming, then they're more hostile than that severity weapon was designed to repel. So we have here that this is by different rules of engagement rule sets. We have that under some rules of engagement, we had a very large drop in the number of protesters, which is in red. And we had some small increases in the number of attackers. Now, these attackers are more threatening than the protesters, so even small increases are important. When we look at it by intermediate force capability, it is interesting that we actually cause more protest in the case of lethal only. We're still working on that case, but we see also using different intermediate force capabilities does affect how the objectives of the crowd change. So that's just to give you an example, couple examples. We have some future plans. We're continuing the work we have. We're enhancing the needs modeling of the people. Some more, as I talked about, force members having their psychological drivers included in the model. And on crowd adaptation, there's something called post-traumatic growth in the literature that we want to look into. How do the people in the crowd learn and adapt based on having been hit with certain IFCs? And perhaps being able to inform other combat models on the civilian and civilian behavior specifically. Anyways, I just want to leave a few minutes for questions. So I want to mention, though, I'll keep up my next slide is the question slide. But I wanted to point out how diverse our research team really is. We have people representing 5 different departments across campus. We run the gamut of, computer programming, psychology, experimental design, statistics, social psychology, social movement theory, all kinds of areas that are participating in the development of this. I sort of lead the more analytical simulation modeling side of the house, as I call it, and Dr. Bailouni sort of leads the social science side of the house, and we work in conjunction with each other to advance the project. So leave a couple of minutes for any questions.
All right, thank you, Susan. That was very interesting. So do we have any questions in the audience?
Hi, Dr. Aros. How did you operationally define the different levels of all those emotions, hostility, anger, and fear?
How did we operationally define them? So we're modeling, I'm not sure if this gets at your question, so tell me if it doesn't. We're modeling fear and anger on 0-1 scales. Hostility level, we actually operationalize in a larger framework from 0 to 6, which actually aligns with severity level of weapons. Legitimacy beliefs, we also do on a 0 to 1 scale. And injury levels are actually accumulated injury points, basically, with a tipping point of death. Does that get at your question?
Not really. So, I mean,
okay.
I guess what I'm asking is, you've got these subjective emotional states by individual people. How did you define when somebody's showing anger? And then how did you define that they were showing high anger versus low anger?
So we've been spending a lot of time mining the psychological literature to look at models of what drives anger and fear, what situational conditions drive anger and fear. We've looked at some of the research on the intermediate force capability effects on individuals. They have a little bit of data there. We also looked at how anger and fear may or may not drive hostility, and what about the environment may moderate that. So Anne-Marie would better answer. I think she is online. I don't know if she has a mic up.
Yeah, did you mean the initial state or the result?
Well, I guess I was Because when you had the slide about the change in hostility, well, that obviously depends on how you define hostility and then how you're defining this distinct levels of hostility. I don't want to belabor this.
Yes. So there's also, I don't show the influence diagrams here because there's a very complex spaghetti chart of all the different influences that we found in the literature. And I know hostility can be defined differently. Here it's the middle ground sort of between the anger and usually, you know, anger doesn't necessarily turn into hostility and hostility doesn't necessarily turn into aggressive behavior. So there's a number of different feedbacks that influence what happens. I don't know, again, I don't know if I'm answering your question well. There's a great deal of complexity that I'm you know, just simplifying here just for presentation purposes. Happy to follow up on conversations on that.
Yeah, we took the microphone away from Quinn, but she looks satisfied with the answer.
Okay. Yeah, and definitely Anne Marie is the expert on the social science side of the house as well.
Excellent. So I think that's all the time for questions we have. So thank you, Susan, very much for that great presentation.
Thank you. We're happy to engage further with anyone.
Okay, next thing on the schedule is we have a break for 15 minutes. So please be back ready to go at 1400 and we'll continue the briefs then. Thank you.
So as you said, I'm Professor Joe Blau from the physics department. I also have Eric Johnson here from the MOVES Institute and Professor Bondi Johnson online from the systems engineering department. So we're going to be talking about modeling and simulation of directed energy weapon engagements. Not actually, we do not just Navy, by the way. I see some Army people here, maybe some Marine Corps. So we're doing modeling of all the services actually. Well, we started out with Navy. So how do I advance this? There we go. Okay, so first of all, I just want to give you an overview of directed energy. This is kind of the selling pitch that I use for directed energy. It kind of just sort of gives kind of the pros and cons of directed energy. So directed energy weapons are actually under development currently by all the services. You can see some of the pictures here. A couple of these are just cartoon pictures, but the one on the top right there actually is that one up there is actually shows the USS Portland when actually the Navy has a 125 kilowatt laser deployed on that ship. And if you go online, you can Google that actually and see a video of it in action shooting down a drone, which is part of what we're going to be modeling here. And I actually got the pleasure of actually being able to be underway off the coast of San Diego when they were doing the initial testing of that laser. And the reason, and you may have heard of lasers and directed energy for many years, some of the older people here in the audience, like myself, you know, going back to even the Star Wars days, but those were like chemical lasers. And they had a lot of practical issues with deploying those, but there have been a lot of advances, especially in industry with solid state fiber lasers, which is what has driven the push out to the military to apply these high energy lasers and deploy them. And kind of the goal to use them is for addressing threats such as UAVs, FAC-FIAC, anti-ship cruise missiles. And some advantages of directed energy are they're very precise, speed of light, energy delivery. So you can engage targets out at great ranges and engage even rapidly maneuvering targets. You can do both hard and soft kills, so you can take out sensors instead of just blowing things out of the sky like you see in science fiction movies and video games. Like the one, well, it's not. This isn't a video game, but what we're developing here is a model of using directed energy weapons in actual engagement scenarios. Another advantage of DE weapons, especially with these electrically powered solid state weapons, lasers, is that they have a very large magazine. Essentially, it only takes about a gallon of ship's fuel or less to fire the laser. And so it's a much lower cost per engagement instead of shooting, $1 million missiles at your targets, which might be, $1,000 UAV or something like that. It only costs a gallon of fuel. So it's like on the order of well, I guess fuel prices are going up, but still it's only on order of only a few dollars to fire the laser. And NPS has been involved in DE research for more than 30 years. I know this because I've been here 33 years. So when I first got here, my students used to say, this sounds pretty cool. When are we actually going to have these all out in the fleet? and it was always X plus 10, and X kept increasing in terms of number of years. Well, now they're actually deploying them out in the fleet and all the services. So this project we're doing is to model using these directed energy weapons in actual engagement scenarios. And so it's a multi-departmental effort. The meteorology department is providing us realistic atmospheric data because that's very important. These lasers are affected by the weather and by different atmospheric conditions. So they provide us realistic databases and models of the atmosphere. And then my group over in the physics department, we do the actual modeling of the beam. I can't get this to, whoops, let me go back here a second. We actually do modeling of the beam propagating through the atmosphere, and then determine like what the irradiance is on the target. And then we have another professor in the physics department, Professor Drago Gerbovic, who does modeling of the lethality, like based on the material properties, how long does it take to actually cause damage to the target? And then my colleague Bonnie Johnson will be talking later in the system engineering department. They do some of the practical aspects of actually integrating these into a ship, power and energy requirements, cooling, things like that, but also looking at kind of how you apply these in actual realistic scenarios. And she has groups of students that she'll be talking about later that are applying this model. So, and then where MOVES comes in is that they have this nice modeling framework that they have, which Eric will be talking about, which allows you to kind of tie all these pieces together and then to see, how you would employ this in real actual engagement scenarios, like this picture where it shows, a swarm of UAVs with a ship that's got a laser defending against those. But it's not, like I said, it's not just a cool looking video game. It's got realistic physics and meteorology and everything behind it as far as what's actually happening when the laser beam fires and when it hits a target. And this project has supported many NPS student theses, as Bonnie will be talking about, and capstone projects. So the idea is to simulate both sea and land-based lasers, where, as I mentioned, we're also looking at the Army and Marine Corps applications. And then model threats, like I showed in that picture, a swarm of UAVs. That's one of the big threats the Navy is concerned about, and the other services as well. And then use this capability to study, what happens if you have different weather conditions or different environmental effects, and to look at the SWAP requirements. That's, size, weight, and power requirements. To study tactics, develop CONOPS for how you're going to use these in different situations. And also what we're getting into in this coming year is to put in more realistic models also of kinetic weapons so that we can look at the trade-offs between using DE versus kinetic weapons in different types of scenarios. So I'll let Eric take over here now. If you have any questions, by the way, hold them to the end and we'll try to answer your questions. But I want Eric now to talk about how MOVES is actually using this to do this modeling of the directed energy.
I don't even know, Mike. Is this live? Okay. Hey, good to see everybody. Eric Johnson, research associate here for a long time, 2 decades, 20 years, 21 years. I'm not counting. It's been a while since I've talked about this project. For you people that have been here for a while, I've probably said it 3 or 4 times over the years, but hey, it's back. Swarm Commander Tactics is this project we started years ago, originally funded for DARPA, I believe under the Cruiser program. And it was an idea we had to, can you examine what to do if you had swarms of UAVs under your control? And I don't mean a dozen or 5 or 10, I mean hundreds or thousands. If you had so many vehicles that it was complicated visuals and controlling, and you can't do that as a one vehicle controller. It's got to be some autonomous behaviors. But we didn't want to get bogged down in the details of UAVs and flight dynamics and all the sensor simulations. So we came up with this video game, essentially. And the point of it was to test out the tactics from a user's perspective. What would you do if you had that many UAVs to control? How would you use them for offense or defense or other types of simulations? So that's where Swarm Commander Tactics came about. When this directed energy weapon was initiated, I was in the unique opportunity to sort of inject some suggestions. And I thought, hey, this is kind of a neat project that we could tap into. There's a lot of just fake simulation data we just made up when we wrote this program, but it's all extensible and easy to replace with more robust simulation. At least that's what I sold the sponsor, PI. So yeah, as you saw on the last slide, we're kind of the hub of this project, which is an interesting position to be in. other, I would say stovepipe standalone capabilities and integrate that technology into this application. So we can take the physics calculation, we can take atmospheric data, the kinetic damage system, and write up the code and the logic to do more robust simulations. So for the past few years, we've been able to kind of move up this one commander tactics to add these more detailed hooks. Now, some of it's still all fake smoke and mirrors. The flight dynamics of the UAVs is very, I just wrote it one night. It's like nothing fancy. But that's not the point of this yet. The point of it is now we're looking at directed energy weapons. I don't really care how the UAV flies. I just want to know how the weapon acts upon it. So what am I missing? Did I cover everything in there? Physics base, yes, ground vehicles. So we had to do a lot of modifications to support this project, including surface vehicles, ships with lasers. That was the whole point of this. So we had to add some dynamics for ship control. We've also now just extended it to ground vehicles. So we're doing, trucks with weapons, sensors, driving around on the terrain. And just a couple screenshots you can see. We'll show you a nice little fancy video of what this looks like at real time later on. But we have different aspects of the program, including a live player-to-player mode. So you can join online with your friends and control your thousands of vehicles and rain terror on them with your own tactics. We also have a behavior editing system in that middle bottom screen. It's a graphical hierarchical based play system. So you can define your conditions and actions and assign them to vehicles at runtime, and the vehicles will now carry out your tactics, as we say. And of course, the weapons. Let's go next slide. Yes, so we've added a couple things, including the ability to control vehicles on the ground. Originally, this was all UAVs. So going to surface-based and ground-based added some new tricks to the requirements. We're just adding in the ability to do sort of a waypoint following system to get into more of a convoy scenario. So we can have maybe UAVs protecting a convoy, or a convoy with flanked with UAVs, directed energy weapons scattered around as well. Next slide. Now the big payoff of this project is the ability to tie in the student research projects. Having this cool project is all well and good, but if you have no users, it's kind of a dead end. So with Professor Bonnie Johnson's capabilities, we're able to plop in new students to do their research on topics that they think this would be interesting, especially in the directed energy domain. So for instance, we can now do some analytical calculations. I'm seizing up. Analytical calculations of directed energy weapons in simulations. So what do I mean by that? You can have tunable parameters in the simulation. Let's say you want to increase the sensor detection range. Tweak that up, run a whole bunch of scenarios, and see the results. Theoretically, the further you can detect an enemy, the sooner you can engage in it. So we've added that as a scenario generator idea. The user can very easily go into the scenario generator, modify parameters, and generate a whole bunch of scenarios, batch run them all in parallel in a headless mode, and collect the results. As well as a vehicle variant system. Previously, the vehicles were all just hard-coded. We just kind of made up some cool stuff to play with. But the research shows that, that's well and good, but what if it can go faster? What if it had a more powerful laser? What if it had more energy capacity, which we couldn't change? So now the users can go in and modify and make their own vehicle variants and use them in scenarios. Currently you can make them impossible vehicles. We don't have any limits on it currently, but probably will. Next slide. Okay, so I know you're saying, well, that's great, Eric, but you know, what does it look like? Are you going to be crazy enough to run a live demo? Thematic music. So instead of a live demo, which I'm going to show tomorrow night, by the way, during the demo night, there's a little canned video of sort of what it looks like at runtime. This is the player-to-player mode, where you can see, you can control, how many vehicles is this? I don't know, 100 or so vehicles. Basically simple gamey interface where you select the vehicles and assign them the behaviors to do. Those are the plays you see running at the bottom. Full camera controls. Again, this is all simulated world, so you have a God's eye view of everything your vehicles can see, you have access to. Very much game-based. Now you can see how chaotic the visuals get. And this is you know, one of the questions we keep trying to figure out is how do you show this? How does this make any sense to anybody? There's missiles flying around, explosions. It looks cool. It's very hard to decipher what's happening. We've also added satellite capability. You know, that's a big thing with the Space Force these days. Satellites getting attacked and how to defend your satellites in space. So we have just the initial cut of that. Again, we haven't talked about using directed energy lasers on satellites, but possibility. A couple clips of what it looks like in the scenario editor. Again, this is very simple interface. This is not too complicated. And the vehicle system. This is all of our vehicles you see on the left side that are kind of pre-built into the game. And each one of those, you can fine tune the parameters and make new versions, plop them into scenarios, and have a cool little head-to-head battle. Again, the point of all that is that you can run these studies on these parameters and kind of come up with the best tactics for the best parameters, the best properties you have. Let me jump ahead here to this was really the heart of the start of the project, this play designer. To come up with an easy graphical way to embed your tactics instead of writing code, which nobody wants to do as a student, apparently. Anybody? What if you had a cool little drag and drop system where you can just hook up the behaviors and we did all the hard coding behind the scenes? That's the idea of this play editor. So if you can dream up the tactic with a condition action system, then we should be able to test it out. Now, those behaviors are really what the vehicles are doing. So they have, you know, if my vehicle detects an enemy, what do? Do you attack it? Do you fly away? Do you cut your swarm in half and attack two different flanks? Those kind of behaviors. Yeah, and I just wanted to, one last point was, this project was really awesome for me because it's a full circle project that it started as a small thing that we developed in-house. We've been able to tie in other departments to leverage their expertise. I don't know anything about laser propagation or atmospheric data. So that was kind of a neat thing. And be able to pull in the students on the back end, and the students, based on their results on every capstone and thesis, drive the next requirement phase. So it's a really nice story on this project.
Yeah, and then the student aspect kind of ties into what Bonnie has been doing. So let me see if I can advance this to her slides here. Okay, go ahead, Bonnie.
All right, so just real quickly, Joe, can you hear my audio pretty good?
Yep, yeah, coming in good.
All right, super. So I'm Dr. Bonnie Johnson, and I'm actually a distance learning professor. So I live in Maryland. And I'll, agree with everything that Eric pointed out about this project and Joe. Anyway, one of the cool things about my job is that I teach a lot of students that are also distributed and distance learning students like myself. So I've got students that are both active duty military and civilians that are usually in the systems engineering program that are able to access moves remotely and really do some interesting research. And another thing I just wanted to also highlight that's been really interesting in the last couple of years is that this project is so popular, or just working on directed energy research in general is so popular, that for the past several years in our department, we'll actually give the students several different topics to choose from. So I'm usually competing with the directed energy topic with other professors that are trying to get students to work on other projects. And this is always one of the top projects that students choose. So it's very popular. And I think, as Joe and Eric pointed out, one of the big studies we did for several years is we did a lot of different studies for laser weapon systems on the shipboard environment. But this last year, our research sponsor, who also I want to point out has been fantastic and very engaged with our modeling and simulation efforts and with using moves and our students, wanted us to study a smaller but still high energy laser system on a tactical vehicle. So we actually had a resident Army capstone team of 5 students last year that really well. And another thing I let them do is I sort of let students also drive what they're interested in doing. But they did a lot of modeling, both with model-based systems engineering, also with a program we use called ExtendSim, and then also with moves. But they looked at basically a counter swarm of drones to see what a high energy laser supported the Marine Corps could do. So this is just a little bit of their modeling diagrams and so forth. So next slide, Joe. All right, and this is another thing I wanted to also point out is that, like I said, sometimes I let students, I sort of give them a general topic, but then let them kind of decide what areas they're really interested in. So I had 2 students in particular last year who really wanted to explore machine learning and AI and in conjunction with this. So this top part of the slide shows that one of my students actually worked pretty closely with Eric Johnson to collect a lot of scenario data. Basically, this was a shipboard laser system against drones, and he was able to train a machine learning algorithm based on the data that he collected through moves to choose between 2 different laser engagement strategies. So in this case, he looked at, should I shoot at the closest drone first, or should I shoot at the weaponized drone first? So that was what he was able to do, which was another interesting application of this moves modeling and simulation capability. And then in the lower box, this shows another team that was really focused on looking at the decision process. So if a tactical warfighter was actually going to operate a high energy laser, what kind of decision process would they go through? And so one of the students on this team, he actually worked very closely with Dr. Gerbovic in the physics department to train a machine learning algorithm that if they could kind of predict the thickness of the drone that we were firing at and maybe what it's consists of, what kind of materials, then it would be able to quickly calculate what the dwell time would have to be. So then you'd know how long to turn on your laser to burn through the metal. So anyway, keep going. Next slide, Joe. And this is just kind of a smattering of a lot of different projects. So we've had several teams use moves with a shipboard. Now we're kind of moving also to look at this scenario that's ground-based, kind of support the Marine Corps. So I have another team right now, they'll graduate in December, that's kind of doing a follow-on study to look at different and maybe more high energy level lasers to protect the Marine Corps in kind of an expeditionary force. And then another really interesting topic that's gaining traction with students is also to look at the reverse of this. So to say, all right, what happens now when our adversaries have high energy lasers or high powered microwaves? How do we defend perhaps ground deployed soldiers? How do we defend our own drones and different aircraft and vessels? So anyway, we've had a number of students do that as well. And so we're working with Eric Johnson and Moves to kind of look at the reverse of a counter-do or counter-directed energy warfare scenario. All right, next slide, Joe. So this talks a little bit more about the future plans. I think you were going to talk about this, Joe, but just to show that we have a lot of students that have already graduated and continue to graduate. And just also to touch on this, that we also have 2 current thesis students that are are in fact interested in laser studies that are space related. So one student is looking at using a space relay for over the horizon maritime communications using laser. And then the other student is looking at power beaming using lasers that is also space-based. So we kind of are trying to accommodate what our research sponsors at ONR want us to do and also what our students' interests are. Thanks.
Yeah, and so just to wrap up, you can see a list there. I won't read them all to you, but just some different areas that we're investigating to continue to improve the model and have more realistic physics for some aspects of it, or the timing of the kill chain, for instance, and also the ability, like for instance, to target individual sensors. That's another thing we're working on currently. So, or to look at if we're trying to protect our own assets, different types of paints that can reflect the laser beam and things like that, different materials and so forth. So I think we're about out of time, but if there are any questions, I don't know if we have time for a question or two.
Again, we'll be showing this on the demo night in the classroom. So if you want to come by and poke the keys a little bit, see what it looks like, ask questions, blow some stuff up, let me know.
Can you model sharks with lasers?
Sharks with lasers? Possibly, yeah. I'll look into that.
Okay, our next presenter. We're always glad when our alumni can return home. So we've got Commander Dan Cain. Dan is currently at TAC Trade Group PAC, or the Tactical Training Group Pacific, basically responsible for training all the ships before they go out and deploy, especially focusing a lot on the carrier battle group staffs. So he's going to come and brief on some of the LVC. You've heard that term several times today, very big term. And so he's sending out a quiz. If you don't pass, you'll have to leave. So, okay. Okay, yeah, I guess that's true. If you don't pass, you have to stay because you need to learn what all this stuff is. But Dan, please take it away.
Thank you. Laser pointer, I'll check good. All right. 2 quick admin notes, if I may, before my time starts. 1, you never know who you're talking to. So I had to pass a mea culpa this morning. I didn't know there was an SES in the room. So I'm not quite sure, kind of like Michael Scott from The Office. I never know what I'm going to say, but I don't think I got myself too much in trouble. But the point is, we have an SES in the room. That's such a huge deal. So thank you, sir, for being here. Okay, next point, Imre, thanks for all your leadership over the years. Appreciate it. And last but not least, I may or may not get any sales, but Dr. Jeff Applegate's book was mentioned earlier. This is what it looks like. Highly recommend you take a look. All right. Admin notes are done. Start the clock. Okay. Okay, so PRC invading Taiwan has been in the news a whole lot lately. In fact, there was even a Meet the Press full episode on a war game related to that. If you haven't seen it, you can YouTube it and watch it for yourself. The point for that is when it comes to the invasion of Taiwan, PRC can push incredible amount of assets. Besides just the amphibious invasion, there's the air, and we're talking 4th and 5th gen, J-10s, J-11s, J-15s, all to clear the way, not that they really need to, for their bombers, their H-6s, which can put precision guided ordnance in Taiwan easily. That's just the air. From the surface, to support those amphibious units, they have pure threat level ships, destroyers, cruisers, that can match anything that we have with Jankai 3s and Renhais. That's just the surface. Subsurface, Yuans, Mings, Kilos, Jins, Shangs, the list goes on. They have many submarines. It's not done there. Rocket forces, DF-21, DF-26s, all can range for the latter as far as Guam. It's a long way. That's not counting cyber or even space. I was just looking to see if anybody would look up and point it out. So, space. So I'm making a joke, but it is deadly serious. They know where we are, when we are, pretty much most of the time. Big deal. This isn't to paint China as a giant that is insurmountable by any means. The point of this, and to list all of their assets, is to soberly know that it's not just the Navy that is training to go up against PRC. We have to work with our allied, joint, theater, and other services, all those partners, if we're going to have a chance. So that's the purpose of why I'm up here today. Good afternoon, Commander Dan Cain. I'm from Tactical Group PAC. We do synthetic training in the integrated phase, but we also do a whole lot more than that. So I'm going to try to get through these slides pretty quickly. And if you have any questions, please save them to the end. I know it's kind of like an exciting movie. I'll probably get the answer to your question as I go, but if I don't, ask it at the end. Also, one quick prop. This is unclassified. This is an unclassified venue. If you do have a question, please ask it. If you see this, maybe we can go to a skiff or something like that and we can discuss further. All right, all that opening. Now I got to figure out how to move the slides forward. And failing. There we go. All right, this is what we're going to talk about. NCTE, go into some fleet synthetic training, go into a little bit on LVC and some improvements, and finish up with what we recently did very successfully, a tabletop exercise known as Ender's Game. Okay, it wouldn't be right without a little bit of level setting. So the next two slides are on level setting. Everyone, we have a lot of Army in here, Marine, Navy, no Air Force, unfortunately, hopefully next time. So live, I'm a naval aviator. I'm gonna use these as examples. Pilot in an actual aircraft, virtual, pilot in a high fidelity simulator, constructive, retired pilot sitting at a computer, moving around a constructive or fake entity. I'm also going to add one more to this list because ships are such a weird mix of all these. You'll hear me also refer to synthetic. When I say synthetic, what I mean is a mixture of virtual and constructive. That's important because for ships, when we are doing training, you have a sailor at a console, but the console is in training mode and we're piping in constructive entities. That's synthetic. All right, one more. Okay, I'm going to talk about this one left to right, top down. So starting with basic, these are the phases of the workup cycle for the Navy. With basic, you're talking about operators on their own ship, in their own aircraft, working to learn their systems. Advanced, working together with other ships, other aircraft. Integrated, it's no longer about the operator, it's about the staff. The staffs are getting trained, the operators are playing second fiddle. Going down. So Tactical Group PAC, what we're doing, these are the organizations in charge of these different events. Okay, Tactical Group PAC, we are just supporting with technical means, providing the environment. So important to know, as a carrier strike group, say, gets ready to deploy, they're hitting all these different training wickets. They have a whole bunch of other maintenance and other things they have to do. This focus, training. Also at the bottom, you'll see a whole bunch of other stuff that transcends the different phases. Okay, NCTE. This is basically our architecture with secure plumbing for data and voice. This is how we get Artrons and voice from Tactical Group PAC out to the fleet to do our training. It wouldn't be right without mentioning the who. There's a whole lot of engineers at Corona that we partner with to make this a successful training event. So while Corona has the engineers, Tactical Group Pack, we do have some technical folks. We also have the mentors for the operators. So we have an heavy N3 and N7 as well as an N2. Don't want to leave them out. But for the purposes of this, there's a whole lot of collaboration between those two commands. Okay, wouldn't be good without a diagram. NCTE, so it's a combination of a network, software, hardware, and it has to be in accordance with standards. All that, again, with the people across the bottom. I know it's a little hard to see, but workforce. So technical as well as operational. Okay, Professor Darken mentioned modeling earlier, really important. So right here, if you look on your fund list, so one thing that we work with also, MDA, Missile Defense Agency, it's really important if you're to try to train a whole group of individuals on a peer threat, you got to have quality modeling. So if we are stressing the training audience with launching ballistic missiles, cruise missiles, you have to have the right profiles. They have to be able to see the inbound threat the right way. And of course, vice versa. Our models also have to be accurate in order for it to make sense. The other part that I want to discuss with this is, yes, we are indeed connected to a whole lot of different organizations, not just Navy. So if we go back just last month, there was all services that we were working with for exercise 22 TAC 3, which was over in 7th Fleet. That's west of the international date line. We had all services joint. We had Canadians and we also had Australians, all playing, no appreciable latency in case that was a concern. Very highly successful and stable architecture. All right, the way you read this slide is starting here at Tactical Group Pack. What I really want to point out here is when we do a FIST, a Fleet Synthetic Training GC/J 2-week event involving generally all the services and some allies. We have in our facility, which I think a number of you have been for Tactical Group Pack. Okay. Important to note, we have, it will encompass many hundreds of individuals between the training audience and support. So just in Tactical Group Pack, we have whole separate sections for M&S, game control. We have civilian war gamers representing red ship, air, surface, subsurface, and blue. We have actual, a whole lot of Air Force representing those assets. And we can link, doesn't have to be just in our building, we can link to all sorts of other facilities. So there was a great question earlier by the cohort about manpower, and I'll just take 2 seconds to discuss Winter Fury, which was a Marine exercise where they paid the Air Force to go to their 100,000 square foot giant warehouse at Kirtland Air Force Base, where they had SIMs in the building and linked to all the other services as well. So with the Navy, when you're talking VC, we link to the Air Force. They can, from that facility, they can link to everybody. So from a VC perspective, it's incredibly powerful. So continuing on with this though, from Tactical Group Pack, we can bring in TOFs or high fidelity trainers to keep it simple. For F-18s, for example, in Lemoore, Whidbey, et cetera, or for helicopters, 60 Romeos and Sierras, bring them in San Diego, Hawaii, Japan, you name it. Okay, and then we'll have sailors on the actual ship pier side connected, and they will all be able to activate different sensors all in the same common operational picture. Very powerful. So what does this look like? Reading this slide left to right. So a bunch of us are in the nerd hive here in the XCon on the far left side of the slide, but we also put mentors out on the ships in with the simulators, as well as not just technical, but a team of one tech, one mentor for the ops. All that just to get signals, both voice and data, as you can see on the slide, for all the different, from voice, geeks, comms, a stable Link 16 picture, all together so that they can actually play their war game. One specific example, Resilient Shield, a couple months ago, we have an annual bilateral exercise we do with Japan. Again, all services represented. And what I want you to take away from this is in the bottom there, all the listed data links, the operational picture, comms, network. So here's your, if I could use a not so great analogy maybe, but Fortnite. Probably talking to the wrong audience, but I'm going to go with it anyway. So Fortnite, everybody gets together on the same game. It doesn't matter what you're playing on, Xbox, PlayStation, everybody is syncing in. And that's exactly what happened here. This was a highly successful exercise. First one kind of post-COVID, right? So we actually sent a ton of people forward to Japan, and this worked out brilliantly. It doesn't mean that there's not room for improvement. There is, and in a different venue, I'm happy to discuss that. But on the surface, as far as technical feasibility, this was a huge win. Okay, one more slide and then a little bit of bad news. Okay, NADSI is a basic phase mostly where aviation simulators link up. So disparate location, disparate platform, all joined together to knock out ACTC training. All right, bad news. Okay, so I created this picture, doing jumping jacks up here, you know, patting myself on the back for the Navy. It's got a lot of challenges ahead. Some of them better than, some of them a little bit easier than others. Starting with the CSAS and different baseline standards. So let me start with the ship side. Almost, I don't want to say almost every ship. Most ships are actually slightly different when it comes to hardware and software in order to get into training mode. So you're taking a computer that was, and this is the same for aviation, that was never meant to really link up into a training mode, and you're going, I'm gonna trick you into going into training mode and provide that Link 16 and be able to do the voice as well. Tricky, possible, but still very challenging, especially when you consider how many DDGs are out there, the Flight 2s, 2 alphas, and oncoming 3s. Everybody's just about a little bit different. That makes it hard, especially when you're trying to have one manual to tell everyone how to get into the training mode. The aviation side is an even worse, more challenging situation. So I just described to you how we can do virtual constructive. Yes. Live linking into that virtual constructive generally doesn't exist. Now, we do have a couple of things I'll talk about little here in a sec, but there's no way to take the computer, mission computer, and have it receive synthetic tracks to be able to participate like the ships. So we can't just from tactical group pack beam in constructive entities in order to make that happen. We're not there yet, and I'm still pretty far away. Okay, so one cool thing on this is voice, right? So how do you make a radio call UHF to the ship? Because they love that, right? Swells love that. So what you do is you put a box on the ship, and it gives you a chance to actually turn digital to analog, and it translates that so you can get the radio call. So again, everyone loves pictures. So if you notice, if you're in the circle of friends, a ship with that VTBE, it can send out the RF for that, voice only. Okay, so the good news for aviation, just F-18s, is there's a live constructive opportunity called LITTLE, which is tricking the computer planning on deck, and you can put constructive good guys and bad guys. All right, I'm gonna get through the next couple slides real quick, just for the future. Tactical Group Pack routinely works with a number of organizations that are pushing the envelope on S&T, one of which is not TSD. I've kept in contact with them. They do some pretty amazing work, one of which I'm going to mention here, Doomer at the bottom. So that's a way of doing some assessment while you're underway. Okay, two quick things. The NCT, the Nintendo, it's very expensive to have contractors. So if you can have it on demand, you save yourself a whole lot of money. And then the Sonobuoy, same thing, because the mission computers for aviation are so expensive to update. One way they found was in the buoys, you can put a little chip in and voila, you can do some L into VC. Okay, my sneaky agenda all along were these last two slides. So we recently did a tabletop exercise, and CSG 15 task tactical group pack. Hey, I know you're busy, but I want this before I leave the job. I want you to do a fully informed, which means SAP level, tabletop exercise, just for the very senior leadership of the next carrier strike group leadership. Roger that. Okay, so what we did, we had 6 months to create and train up an organization that had zero real experience facilitating, excuse me. That was fun. So it was very successful because we had education that came from here at NPS. So Perry was one of my thesis advisors, Dr. Applegate, the other one, right? So leaning on them and working as a team, we were able to facilitate that. All right, that's it. I'm done talking except for questions.
I did see on one of your slides, the Air Force Medical Battalion was participating. You getting any engagement from the BUMED side of the house with the FSTs?
During a Com2X, yes, but not appreciably. I'll take that back and ask. Oh, yeah.
Let's talk. So figure out how to make that more of a thing.
Sounds good. Thanks for your time.
Thanks, Dan.
Good afternoon. My name's Al Abejon. I'm the director for the Combat Aviation Brigade Architecture Integration Lab, better known as CABAIL, not CABAIL or cable. It's CABAIL. We were going to name it the Combat Aviation Brigade architecture, lab experimentation, but the boss didn't like that. He thought that might not go well. So anyway, I'm going to give you a little bit of an overview of it. What is our aim? Our aim is to holistically develop capabilities for the CAB as a force, not individual systems, not individual aircraft, but the CAB as a total force. And we would do this in a risk-reduced environment rather than going out there, hey, we got this neat gadget, go out there, go to a test aircraft, which is very expensive, bend metal on it and make mistakes, and then try to get the warfighter to figure out, well, what did we do wrong? So this risk-reduced environment allows us to readily get to not only the material developers early, but also industry. And that's very key because the technology changes so quickly. Bring them into the fold quickly so we can take a look what's coming down the road, but do it in a risk-reduced environment. The other key piece to this is bringing the aviation warfighter into the design early. Normally, when we get warfighters into material development, it's usually at IOTE or EUTE. It's way too late then because the system's already been designed. Bring them up front early to show them, hey, these are the technologies that we're going to try to give you the capabilities that you think you need. Does this meet your intent? Rather than at the end and figure out you wasted all those millions of dollars that it doesn't. We also work with the other PEOs and PMs, read the other material developers, because we don't own it all. We have to get out of this mode of these silos of excellence, if you will, only focused on your particular program. We fight as a combined arms team. Therefore, we need to fight as a combined arms material development group. Moreover, a joint combined arms material development group. So we're all sharing together. We're all looking at the same picture. We also take a look at expediting these capabilities that we're coming up with early to the force, not wait for the perfect picture. If we have opportunities and the warfighter says, that's cool, I need this now, give it to me, I'll take it. We give it to them. Sure, yeah, there's going to be logistics implications, but there always is anytime you try to field anything. But you don't also try to field to the whole fleet at one time. Target your equipping, if you will. All of this is also to influence future vertical lift, because one of our biggest problem sets is our enduring fleet now, which is our current aircraft. Guess what? Still going to be the enduring fleet when future vertical lift comes about. So basically, the aircraft we have now are the B-52s of the Army. Because if you take a look at it, FLRAA, which has moved up in fielding from 2034 to 2030, but take a look at the production rates. 8 aircraft a year. There are 119 aircraft in the Combat Aviation Brigade. Even if you only did half of them, at that rate, do the math. Then there's 11 Combat Aviation Brigades just in the active component. Do the math on that. So our aircraft today, we have to do targeted modernization. So those capabilities that we put in those aircraft, those technologies that we put in those aircraft, they have to lead to future vertical lift. All right, we have some challenges ahead of us, and we have to take a look at these in terms of, all right, what are we going to put into our aircraft? What are we going to put into our forces? So we're shifting from counterinsurgency to large-scale combat operations. When you really look at it, it's kind of going back to World War II. So we're not looking at 100 to 150 miles anymore. You're talking about 400 to 700 miles just to get from the base sanctuary, just to get to the forward area. And when you get into the exploitation in dominance phase or cross flot, now you're talking about anywhere from 800 miles, sometimes out to 1,200 miles. All right. Now you got to now we have to deal with this dynamic balance between, all right, we've got this extended reach, but the threat also has reach. So now you got to figure out, how do I get myself some standoff so that I don't have to commit or expose manned platforms or my troops to the threat? That's where UAVs and this thing called ALE, or you guys call drones, but we call air launched effects. And this is also key. Now we've done this. This is my 51st year in the Army. We got to get it. We got to get out of this mold that we're the greatest. We fight by ourselves. We don't. We have to fight as part of the joint team. We have to fight, moreover, in today's environment, as part of the coalition environment. Other things that are causing us to make changes very quickly are the contested environments we're going into. So across that continuum I described, you're going in and out of contested, uncontested environments, contested, uncontested environments, and then you're trying to figure out how do you deal with that. In my opinion, everything revolves around information exchange. Shoot, move, communicate. You can't communicate, you don't know where to move, and you don't know who to shoot and when. So if you can't exchange information on the battlefield, what the hell good are you? Get off. Cyber. Lieutenant Colonel Ward just talked about that. And then also space operations. Force modernization. This is the problem set for us. Trying to make change at the speed of relevance. And I'll talk to this in the next chart about some of the challenges there. And then trying to maintain equal capability, if not greater than what you already have throughout that change. The hard part that I think, and I'll use a second lieutenant vernacular, it's been my vast experience, is maintaining the warfighter's capability to fight and increasing it all during that speed of relevance change. Again, critical information exchange, every system on the battlefield exchanges, is a generator or receives information. And it's going to require not a single network. You talk to people about networks, he says, this is the greatest network since night baseball and sliced bread. No, you have to think in terms of a network of networks, and it's got to be dynamic, because if you're going to be going through these contested environments, you need some sort of artificial intelligence that can say, all right, I'm in this type of environment. These are the networks that work the best in this environment as you're maneuvering through this battle space. And then it says, okay, these are the networks that are going to work. Oh, by the way, now I got to do some automated data prioritization because the data is normally connected to the size of the pipe and the type of the pipe. And if you think the air crew is going to be doing all that stuff, you got another thing coming. All right. These are change factors that we have to deal with. We can't manage them, but we still have to deal with them. Technology. It's not Moore's law anymore. Hey, every 4 to 5 years, we're going to double the number of transistors on a chip. It's like every 2 to 3 months, there's some quantum leap in technology someplace. The other piece is requirements process has got to change. I'm sure you guys heard of JSIDs. That takes 3 to 5 years to codify a capability requirement that's based on technology at that point in time. So in fact, what we're doing is we are promoting irrelevance and obsolescence, and we got to change that. We got to change that that ability to recognize, yeah, this requirement. And I hate, hey Al, where's the requirement for that? Are you kidding me? Did you read the National Defense Strategy? Did you read the doctrine by General McConville and says, hey, we're talking about joint all domain operations? Do you read your own CONOPS? Do you read your TTP? You're asking me, where's the requirement? Read what you have, how you have to fight. There's your requirement. And then there's that ripple delay throughout the acquisition process. Now you got to do POM, you got to do budgeting. That takes years. We got to cut that, figure out a way to cut that. The evolving threat. We're not fighting third world countries anymore. You're talking about peer, near peer, in many cases overmatch. Speaker before me was talking about China, was also talking about Russia. All right. The other part of that is our buddies today could be the threat tomorrow. The threat today could be our buddies tomorrow. There's a balance there that you got to achieve. And then this dynamic operational environment, again, he alluded to it earlier. Joint, interagency, intergovernmental, multinational. Joint and coalition is going to be prevalent in the way we fight in the next decades. And then again, he also alluded to the range of military operations, all the way from full combat, and where we don't really focus on, and we need to, is homeland security and domestic operations. Many of the homeland security and domestic operations missions are Title 32, are also relevant to Title 10. So if you had a capability that did both of them, which we could leverage off the National Guard's dollars, which are separate from the dollars that we work with, we could make a killing. Again, with respect to today's environment, this rapid force protection, more use of sensors, weapons capabilities as far as gentleman was talking about directed energy. We talked about AI, and then being able to rapidly adapt communications to the environment that we're in. But this is a simple chart that I stole from now Lieutenant General Todd. It's basically a development pyramid. Can't really do too much within the dynamics, but where we make the biggest changes are in the LRUs or the black boxes or the software within the LRUs. And so that's where we try to focus now. And then obviously tying industry in line with us is saying, hey, what else you got out there, and figure out what the best technical mix is. LRUs, the black boxes, it says every 5 to 10 years. I'm here to tell you it's more like every 3 to 5 years. Software that goes into those, to me, it's more like every 8 to 12 months, you're going to see some new version of software. You're going to have the initial, then you're going to have 2 alpha, 2 bravo, so on and so forth. Again, the enduring fleet, whatever we do in the enduring fleet, these black boxes, this software, the design, the architecture has to be relevant to what we're doing in the future vertical lift. Again, the speed of relevance. This is a chart that summarizes the problem sets that we have. Everybody, we talk about aviation. Well, no, we are the king. No, we are. We are an equal combat maneuver force on the battlefield, equal to infantry and equal to armor. We are not combat service. We are not combat service support. We are a combat maneuver force. But our sole purpose on the battlefield is to support the ground commander, his scheme maneuver, and his priorities. That's our sole job. So in doing so, we have to be able to communicate. We have to interact with our ground components. And we don't manage all of that. For instance, there isn't a separate communications, a separate network, or separate mission command for aviation. That's managed by the Army, read PEO C3T. They have the mantle for the armies, not the Army except for aviation, mission command, communications, and network. In the same manner, soldier, that's not just ground guys. They also have the interface tablets, IVAS, the integrated virtual augmentation system, visual augmentation system. That's both relevant to both air and ground. We don't know the things that are in the back of medevac aircraft. That's MedCom. ASC, aircraft survivability equipment, that's not us. That's IEWS. We fly through airspace, but we don't manage it. That's missiles in space. So we have to enjoin the other material developers to achieve this balance so that we can meet the requirements or the capability sets that Army Futures Command says, hey, we're going to need it in this decade, and this decade. And then the COEs or the Centers of Excellence are the ones who actually write the requirements. They give us material developer Bubba says, you need it to make it look like this and do this. And this is the problems that we have to work with. Then obviously, these guys, all the joint guys, we have to work with them as well. When you peel back the onion, that's the choreography that we have to deal with. All the PMs within those PEOs, we have to balance the technical, the programmatic, the funding, the timing of all these capabilities and all these technologies so that we can bring to bear increased capabilities in aviation so that we can more effectively support the ground command. This is kind of a summary chart of what we're trying to achieve is being able to operate across these extended ranges, which means you're going to have information exchange. You're going in and out of contested, uncontested environments. We have to maintain comms across this continuum. So we have all these different networks you can see here projected by this legend. Then we're transitioning to future vertical lift. We've got our aircraft here. We're always going to be on the move. I heard someone told me the other day, he says, well, I don't think the commander's going to ride in the back of the aircraft to get to the forward area. Really? So you're going to tell me he's going to get in a next-gen combat vehicle that goes maybe about 60 miles an hour, about 700 miles to the front. He doesn't want to ride in the back of an aircraft that flies right now between 120 to 130 knots Moreover, when it gets in Florida, it's going to be going 280 to 320. He didn't want to ride in the back of that. Okay, gotcha. I'm being naive. I'm being butthead. But you get the general ideas. We have to look at it, both give and take from air and ground. We still haven't figured that out yet. All right, what is the CABAIL? So it's a compilation of multiple high fidelity aircraft simulators, not simulators, aircraft replications, simulators and emulators. What do I mean by high fidelity aircraft replication? So the H-64E Systems Integration Lab and CH-47F Systems Integration Lab, and I'm bringing in a UH-60 as well. As soon as I can get those guys to get out of the testing mode and bring it over. But those are actual airframes that have the actual LRUs or black boxes, have the actual wiring to the exact same length that they're in the aircraft, because we have to mimic the latencies. These are not training devices. They are not training devices, but they are high fidelity replications of the aircraft or their capabilities. We're also working with the quote modular open systems approach to architecture, open integrated test bed. Basically, it's a workbench where we can bring TRL-6 to TRL-9 technologies in. They'll figure out how to work it on the workbench, but then we also put it into an aircraft to see what that impact is on the aircraft environment in the cockpit. And then we apply it by connecting it to the rest of the CABAIL so that we can see what the impact is on the total operational force. We also have a tactical operations center because but they don't do that on their own as well, because remember, sole purpose of aviation is to support the ground commander. So we'll bring in a ground staff and they plan an operation. They'll give that operation to our TOC personnel, and then our TOC personnel will then go ahead and build the missions. We also have ground control station emulators. Now you say, hey, Al, you got these guys here that are in live, but you said you replicate the force. How do you do that? That's where the constructive simulation comes in. We have a bank of constructive simulations that mimic the aircraft and the capabilities that we want in that aircraft at that point in time, and they are manned by actual pilots. And then we have a nerve center, or the controlling piece is this thing called the Battle Master. You can see the networks that we work over. There's a myriad of networks. Again, it's trying to figure out which networks, combination networks work best in that particular environment. And then the mission command applications that we use in order to transmit or to convey the mission or the various areas within a particular mission. All right, how does this work? That MOS office I was telling you about, they're developing these reference architectures that support the C5ISR open systems standards. So this is an approach where we don't have a separate design and way you get things into aircraft for Apache, for Chinook, for Blackhawk. It's all the same way. It's a long way to get there, but that's an intent. All right. We'll take these insertions of that architecture. We'll take the hardware, we'll put it into the CABAIL. Into the CABAIL, we'll also coordinate that with the other material developers, and then we'll feed back. The big piece is the warfighter input. Once he gets in there, he'll be able to tell us, hey, is this worth a damn? Or where do we need to lift and shift fires? Or what needs to be done to make it really good? Let's say we get there and they say, hey, I like that. We go ahead and we put it in their aircraft. We let them have it for maybe 2-3 months. They come back and says, I got to have it. We give it to them. So then we're also putting relevant capability in the warfighter's hands at that point in time. At the same time, we're helping shape and inform future vertical lift. So I already told you what's in CABAIL, but what we also try to do, not try to do, what we are doing right now is we're connecting to the rest of the total force. So right now, we connect to the CJSIL, or the Coalition Joint Systems Integration Lab, which is the hub for the Army up at APG. They connect to other SILs that have like capability within the Army so that we can get this total combined arms team look. But it's also important that we take a look at the individual command sills or material developer sills like the Ground Vehicle Systems Command Sill, which we're connected to in Warren, Michigan, the APARI or the Aviation Platform Augmented Reality Integration Sill that's at Fort Belvoir. That's that augmented reality piece for aviation that's part of IVAS. We're also connecting to the fire sill at Fort Sill. We talked about the fire chain. I can't believe in this day and age, it takes 17 minutes to complete the fire chain average in today's technical environment. Find, fix, track, target, engage, and then assess. 17 minutes from I see a target to, okay, you're cleared to pull the trigger on that target. Insane. You're cleared to fire. And what? Target's gone. We're also connecting to the Aeromedical Research Lab to take a look at what the stress is on the air crews with these increased capabilities. There's a workload increase that corresponds to that. We're working right now with Chris Fitzpatrick to connect the NPS FVL SIL that's here now, and we're connecting that to the CABAIL, again, in the spirit of being able to share joint information. AFRL, we have some feelers out there talking with those guys to see if we can connect any of their simulators to us. And obviously NavAir, PMA 276, who couldn't be here today. Chris was hooking us up with them. But it gave me an idea of this. Maybe we need to take a look at, maybe as a baby step, take a look at some of the training devices and see if we can connect the joint side as a baby step to getting to this total force. All right, I'm just going to go over real quickly some three concepts. This is at ALE, or you guys were talking about UAVs before, but we see ALE or air launch fix, several means we can do it. Extended range comms relay, basic recon and VDA or surveillance out in front of these expensive UAVs such as Gray Eagle. So essentially you can take a look at these as disposable drones. EW, put those sensors out there, put those ALEs out there as advanced warning sensors, or long loitering air munitions. We got them on the ground. On the ground, they're like about, they're hand launched. They stay up in the air for about 10 to 12 minutes to carry 6-pound warhead. Do the same thing with long loitering munitions. You give it the target set saying, all right, if you see this radar signature, you see this electronic signature, that's your target, go after. All right. Counter drone, they talked about that earlier. So you could send counter drones out there essentially with the same sensors to see a swarm coming at them. They could be loaded up with flechettes or micronets and at least neutralize that swarm, if not take it out. Force decoy, putting these ALEs out there so it makes the threat think that's where those guys are. And then when they do that, they light themselves up. They become the target. And then the last thing is just basically supply, resupply, where you can get bandages, insulin, plasma, blood to these remote areas just for instead of sending manned platforms out there, which are going to be critically short. Dynamic airspace and synchronization, being able to know what's in the air. Moreover, ROSs are going to become more and more important because of the increased use of UAVs and ALE or these smaller drones. You got to know what's in that airspace. You're going to have to know where all these air quarters are. Gun target lines. I got hypersonics coming. I got spike envelopes. I got close air support coming in. It's a mess out there. And we don't know that until after we get back. We're getting yelled at because what the hell did you fly through that wasp for? I didn't know it was there. All right. So those types of things. And then being able to coordinate all these fires and the clearance of fires in conjunction with that dynamic airspace synchronization. ASE, this one, it's my personal favorite. 45 years ago when I was flying, still today, when that ASE goes off in your cockpit, which means somebody's painting your butt or something's trying to engage you, how come you're the only one that gets to enjoy the music when it goes off? Why isn't that automatically shared with the rest of the flight? Why is that automatically shared with the S2 so he can put it in a D6A? Why isn't that automatically shared with airspace management? Moreover, why isn't that shared at my base operations so they don't continue to plan and drag aircraft through that same airspace? And then why don't I get that same information from my joint brethren? And why am I not passing it to my joint brethren? And that concludes my briefing.
Excellent.
Questions?
Okay, time for a quick question.
Sir.
So two questions. Are you linked in or is there plans already for the SIL up in Monterey? You linking with them with your system?
No, but that's a good idea.
So
I do. I've had some, I don't know if she's still up there, Dan, Dr. Nancy Booker. She's a pretty big in simulation. I'm not quite sure if she's still up there or not. But that's a good idea.
I've been working with them with my stuff, so I just know they have that set up and everything. It seemed like another West Coast thing to have. The car concept there, but try stuff out. Secondly, talk about the MOSA and being able to test kind of some of those things in the system and this architecture. Have you seen or run into any issues with IP? I read an article recently that FBL, one of the issues that they're having right now with MOSA is companies are having trouble coming off their IP and not knowing where it's going. They want to keep it close hold, but
Yes, but let's face it, right now, from both FAR and FLAR, they're still building the truck. Make it go higher, make it go faster, make it last longer here, make it carry more. What they haven't figured out yet is what accessory packages are we going to put in that truck? And how, read your MOSA and CMOS, are we going to put those accessories in the truck? We haven't arrived at that stage yet or that problem set, in my opinion.
Okay, well, thank you very much. That was great. Okay, our next speaker is Mr. Chris Fitzpatrick. Chris has been doing so much great stuff since he's been here. He's a MOVES graduate who returned and has joined the faculty a few years ago now. How long is it now? 4 years? Five. Okay. Time flies. So yeah, so we're really glad to have him here. He's done a great job with LVC and all sorts of networking stuff. So he's here to talk to you about one project, integrated synthetic environments.
Thanks, Barry. Appreciate the introduction. First, want to start off by thanking Al for the brief on the CABAIL, and I think it's actually very much so integrated with our integrated synthetic environments project, and that's one of the things that we're trying to do here within the MOVES curriculum is starting to connect to external labs. And in being able to do that, we could create scenarios and simulations and build op centers within our home here, but work with other labs. So I think that's really exciting for us. So we're definitely looking forward to connecting with you guys. So thanks again for making the trip out. I do appreciate it. So integrated synthetic environments, I actually went in, looked up the definition and wanted to make sure that it was aligned to what I was doing with students. But basically, this is when students come to me and students say, hey, I want an environment that I need for an experiment. I want an environment that I need for training, or I want an environment that I need for, test and evaluation. So when they come to me, I go ahead and think about, what can I do for you, or what environment can I create for you? So in doing that, the other thing is the education perspective of building out our labs and also creating the environments. One of the things I always think about is that, being a modeling and simulation professional, you want to be able to apply modeling and simulation to your specific problem set. And one of the things within the curriculum, we're able to put students through a number of courses that Dr. Darken went through today that will allow them to apply modeling and simulation to the problem sets that they'll see out in the fleet. However, when some of the other curriculums come to us, and you'll see as we talk about a few of the projects, they don't have any classes. So I have to do like kind of a rapid fire, hey, this is M&S 101 for you in about, 2 hours or 3 hours. And we have to try to get them as quickly up to speed as possible. But that's what we're trying to do, is to educate students on how to deploy modeling and simulation environments for their problems. So looking at the way we look at LVC, and I wanted to kind of break this down to what we do in the lab. So one of the things that we got to see with Commander Cain, he had, an extensive environment, probably has, a number of contractors that put them together for him. It's, nothing like the Air Force at the DMOC, but, it's still a large scale workforce that helps them create that LVC environment. Whereas, if you go into the MOVES Institute, we don't have a long bench of people to go to say, hey, can you work on this? Can you work on this? And, team, go out and do your thing. That's not something we have. So we have to think about things on a little bit smaller scale and also leverage students. So when we do that, so when I think about live simulations, and Dan went ahead and went through the definition. So I'll talk about kind of what I do application wise within the lab. So when I'm thinking about live, one of the things I'm thinking about are live operators that are going out and using simulations for maybe a training event. So in our class, what we normally do is we use either the ATAC, which is the Android Tactical Assault Kit, or the Kill Switch. And what we try to do is we try to have the students build applications that allow them to create a DIS sender that will send out packets, and then we have a receiver that'll take in those DIS packets and then send them out as COT, the cursor on target schema, and that's where we kind of do our live. In addition, we also have C2 systems in our lab that we try to use. So, for example, we have C2 PC, which can take in DIS data, but also we're starting to work with some different Air Force applications for interoperability. Such as Stitches that was developed at DARPA, and also NavAir has Amy that's also used. And one of the things that we're going to try to start doing is look at building applications that will allow us to maybe put OTH Gold standard out there. So maybe Geeks M might be able to see a C2 system. So then when I go over to virtual, with virtual, we usually use X-Plane or Prepared 3D. So that's those are the two virtual simulations that we use in our lab. And then for constructive, we have about 12 simulations. And I have a slide that's following this that'll kind of go through all of those. But one of the things that I have students do when they come to me and say that they want to build a LVC type environment, we first ask them to, hey, build a conceptual model. What do you actually want to do? What are your training requirements? What are the things that you want your system to be able to do? What are the questions you want to answer? So that's going to be, absolutely key for us. And then actually building out all this environment, one of the things that I do in my classes is I take students through the networking of, building out an environment like this, cutting the Cat5 cable, programming the routers, getting the switches ready to pass the data, setting all the IP addresses, because those are things that when I was a student back from 2007 to 2009, which seems like such a long time ago, but it's but I get the way time's been flying. It's not really. So, but the thing about that, which is was something that I didn't know how to do, and so I always take teaching from the student perspective of I want to make sure I have all these knowledge, all of this knowledge, so when I go out to the fleet, I feel comfortable around computer systems. Okay, so the current efforts at MOVE supporting, first we have our SE capstone. So what we're doing with the SE capstone is we're looking at human machine teaming for the future vertical lift. And what I thought was interesting about that is the team came to me and they were doing an SE capstone, and they wanted to integrate modeling and simulation to do an experiment that looked at 3 different groups. First was a control group that was going to just have a co-pilot that's in a future vertical lift, fly or act as a co-pilot, but also control the FA-18s that were supporting the mission, but then also work with the ground control station for the UAV that was looking at targets. And I'll go ahead and show you a brief small simulation of what we built for that. The second group was going to look at teleoperating a UAV over for a certain area. So we wanted to look at task saturation for the co-pilot because he was still going to have to, do the 9 line with the F-18 pilot. So again, we wanted to use, constructive simulations to support, the 9 lines for the F-18s, but then also virtual simulations to have a pilot and a co-pilot flying this mission in the FVL. And then that third group was going to look at a fully autonomous UAV that was going to be operating in the mission, overflying the airspace, but still the co-pilot had to go ahead and control that 9 line for that Hornet coming in. So I'm going to go to my next. You'll see that in a second. I want to describe the other topics. Then there's a DA thesis that I was working with a student who's with the Navy Special Warfare Command, and what he asked us to do was to look at ground force commander type drills that they do, and they're basically like rehearsal of concept drills. And rehearsal of concept drills are where operators will sit around a table, they'll go ahead and talk through specific mission sets that they have to do, and use the communications to talk about the execution checklist, or say, hey, I've reached a certain point and I'm actually going to need maybe a Hornet to attack a target or something along those lines. And so that's what they were asking me to insert simulations into that rehearsal of concept drill. And what's really neat about that is when I got a chance to see a demonstration of that in the DA 4500 course, they were actually very tough on each other. They were giving each other communications at times where they had to go ahead and process information and prioritize information. But the thing about it is it was basically around a table and it was on a 2D map. So not something that was really all that interesting. And so what their goal for me was to, hey, can you insert simulations into this to make it more challenging, more dynamic? And so that's something where I'm working with a student to do that right now in the DA department. And then finally, there's a CRADA that we're doing with hybrid air vehicles, and we're looking at and you could see on the bottom that the Airlander 10 right there, we're working with hybrid air vehicles. They're out of the UK. And the Airlander 10 there can hold 10 tons of equipment. So what they've asked me to do was to put the Airlander in a simulation and look at just different naval missions that the Airlander could potentially support. And the naval missions, obviously logistics would be one of them, but also ISR. You can hang a number of different assets on the bottom of an Airlander, and it flies for about 5 days, and it can go to about 20,000 feet, and you could actually carry, of course, 10 tons, but you can carry a mission or a crew that could, continually run the mission sets for them. So those basically are the 3 departments that we're working with, and that's kind of a shift to where I'm thinking it moves. Is I want to create the environments that students here on campus need. So in creating that environment that they need, we're using our lab. And here you could see the virtual and constructive simulations that are available at Moves. This is something that we've collected over time, and we've had to, and that allows us to have the students do that conceptual model of what they need. So they might need a ground simulation, or they might need an EW simulation, whereas modern air combat environment might be something that they could potentially use, or they need a first-person shooter simulation. VBS3 might be the one that they could potentially use, or they need a MAGTF style simulation. So MTWAS might be the one that may fit their need. In addition, we could have our students in class, or we also have a remote connection to our VPN. So this is something that, in connecting to CABAIL, it's something that, I want to be able to be in our environment, connect to the NPS network, and then be able to go out to CABAIL and maybe do some work with them, over time. And it might be something that we could potentially integrate into the Moves networking courses. The other thing that we need to think about is future secure connectivity to support operational integration. So NPS is working towards getting on the STRAN. So that's going to be pretty exciting for us, that we're moving in that direction. However, we're not connected to the NCTE yet. However, I am talking to NOC-TSD about potentially connecting to the NCTE by peering through the STRAN, which is something that they're working on right now, and it's in its infancy. So that's something that will give us a significant amount of capability in connecting with Tactoid Group Pack. If that is, something that we'd like to do, maybe collect some of their data sets, look at some of their problems, and we'd be able to recreate their problems more easily within our LVC integration lab at NPS. So the system engineering capstone, moving back to the three areas where we're supporting our students. Again, this was briefed about a week ago. They unfortunately didn't win like they won for Swarm Commander, but they didn't win when I supported them. So Eric he's got a one up on me, but unfortunately, but they did a great job. So what but here is kind of the the OV1 that they created. So we created a little bit smaller one for them, and we actually did it in our lab. And actually, this is an island chain off Japan, and Taiwan is right over in this area. So what we were looking at doing was launching future vertical lift from Miyako-jima, and that would take off and move in this direction. And then we had a UAV deployed overhead Tarama, which is the island here, and there were some ZSU 23 TAC-4s in this area. And then we had some F-18s up overhead that were ready to execute a 9-line. So I'll just go ahead and play that, and I'll talk over that. You can see this is a modern air combat environment, and this was a simulation that we were easily able to develop this scenario rather quickly. One of the other things that we do in the lab is we connect these simulations to our image generators. So what you'll get to see during the demo night is I was able to have some of the students that were in the SC capstone. They were able to control the cameras that were on the UAV overflying the island. So we were able to see first the UAV footage of the ZSU. We were able to see the Hornets come in to attack the target. And then we were also able to see the differences in the terrain within the simulation. So one image generator, had, terrain that was collected via, a satellite photography, and you could see the clouds on the landfall, whereas there was some procedurally generated terrain in another simulation. So that was something that we got a chance to expose them to. So we'll see. You could see a little bit longer demonstration during demo night, and we hope you join us for that. So I'm going to move to the next slide. Here's the next generation virtual reality trainer that we're doing with our NSW student. One of the things that I wanted to say there is that we have we have 8 personnel that we're going to be taking part in this, and actually, as we're starting to build this out, we've already been reached out to by Coronado that said that they're looking at already integrating this into their training regimen, because they're finding that that their operators are liking the training that they're getting, and they're liking the fact that NPS is looking at this because they're sending their students up here. And actually, I've had 3 students that have continued to work on this project. So, okay, so this is a quick video. I apologize. This is from Ice Cream, which is a screen record software that I have. It's kind of weird, but so this is where the student actually, I worked with him, and he built out just a basic ship to shore landing model of 3 or 4 ribs that are launching from an LHA Wasp. They're moving to the beach. As they get to the beach, they're going to go ahead. The ribs are going to stop. The ribs actually stop, and then they start swimming towards the beach. So what's really nice about this, again, is when I think about this, I think about the fact that in the M&S community, you know, we have our modeling and simulation officers, but the fleet, you know, there's a delta between, you know, actual, like an operator and a modeling and simulation officer. But I think if we're going to integrate M&S into the fleet, we're going to have more guys doing training with modeling and simulation. We're going to need some level of training. So what this allowed me to do is having my student, you know, develop this for me. What he did is he was able to, you know, in a couple of days, just build out this scenario, do the scripting to be able to do this, and actually move from the ship to the shore. But you know, that's one of the things that a modeling and simulation guy could do this very easily. Could you know, make this this type of scenario within, you know, maybe an hour or so. Whereas it would take you know, a couple of days for the, you know, the DA student to do that. So I just wanted to make sure that, you know, we're starting to think about, you know, what are other ways to educate the course, not give them a full, you know, 2-year curriculum in modeling and simulation. So that was just so I, you know, proud of the good work that he had done with this. And then finally, for that CRADA that we have with hybrid air vehicles. Over to the left, you know, Hybrid Air Vehicles had shared with us their 3D model or their 3D rendering of the Airlander 10. And so what we tried to do is we said, well, hey, we want to go ahead and try to put that into a simulation. It didn't, you know, port over as easily as I expected it to. As you can see, when we built out the 3D model, we just kind of mirrored the other half, you know, and actually that didn't render correctly in the simulation. But what they had 2 students, what they did is they basically looked at a scenario from Okinawa to Korea. And as they built out that scenario, they looked at, you know, the specific logistics capabilities of that Airlander 10 vehicle. So I'll go ahead and play a quick simulation of that. So we actually did it within VR Forces. We have you know, 2 Cobras taking off. We have the hybrid air vehicle that's moving. We linked that to the physics of an aerostat model. Originally, we had it linked up to a helicopter, which actually didn't make it, you know, all that, you know, it moved kind of weird where it was kind of nosing forward as it was taking off. So that was something that, you know, when we were building out these different environments, you have to think about, you know, the physics model and then building the routes correctly so that you're going to be able to see a, you know, the dirigible move as correctly as it possibly can. So here, and then finally, within in FY23 for the CRADA, you know, as we're starting to put it into simulations, we're also going to look at potentially doing some animations where we have Scan Eagles launching and recovering from the Airlander. So this is one thing that you know, HAV, as they're looking at pushing their product forward, they wanted to use modeling and simulation to, you know, potentially be a way to look at you know, different use cases for this. So this is these are some diagrams that they gave me, and now we're getting ready to start working towards building these out, and that they'll use that on their you know, their, I guess, roadshow when they go out and try to let everyone know, you know, what their system can do and within the naval environment. So basically, you know, so what I really wanted to kind of give you a flavor for today is what we're doing in the live virtual constructive interoperability lab. You know, how I'm trying to build the curriculum to support our students, and then also how I'm trying to integrate, you know, other research into that. So I did want to you know, quickly say that I did invite Paulo and Sean from HISA. So thank you guys for coming out. And so one of the things that we're doing during CWIX with them is we're looking at their sketch through plan application which you'll be able to see during one of their briefs and also during demo night. But again, as sketch through plan, I think is going to uses speech recognition to move around mil standard 2525 symbology on a map. And so as I as I've talked about this technology to the gentlemen that are looking at the ground force commander research, they're very interested in what they're doing at HISUS with this, and we're looking at potentially integrating that into the ground force commander drills, which I think would be very exciting and would put us in a position where we wouldn't have to use a keyboard during those types of events. So thank you, gentlemen, for joining us this week. So Perry, if there's time for any questions.
Just one question. Well, we want to hear the people on Zoom on here. Every time somebody talks about a mic, I get pitched at in the chat.
Perfect, sir. Thank you.
Chris, what help do you need at TSD?
Well, I think the one thing that would be really helpful is maybe integration with the NCTE. So I've been talking to Dave Kotick quite a bit, and so they know that this is something that I need, and so they've. But it's since we don't have the Estrin yet, I'm kind of the I guess this. Yeah, I'm not exactly where I need to be for them to support me yet. So, but maybe I'll take you up on your offer once it gets closer. So thank you, sir. I appreciate it.
Hey, Chris, Captain Bree here. Hey, when do you assess that you're going to be up on the Estrin? The reason why I ask is because McWill, we use the Estrin, and we want to actually use it to conduct distributed wargaming, and we want to be able to bring you guys in.
Yes,
if you're
yeah.
able to do that.
Yeah, so this, as soon as we are connected to the Estrin, I know it's definitely a high priority for Dr. Balogh, the president of NPS, to get us on there. And since we have our LVC interoperability lab, we want to try to push all of those simulations onto the high side. So we definitely do want to work with you. So again, I'll put a note in my notebook and contact you as soon as we get on. So yes, sir.
Oh, thank you, sir. Thank you. Thanks a lot, Chris. That was great. Excuse me, when I first came to NPS as a faculty member, I shared an office with our next speaker, Barry Peterson, and he's going to be talking on virtual environments for health. So, but yeah, it kind of goes back quite a way. So Barry left NPS, I think in 2001. But it's good that he's back here doing a lot of great work. Did you want this?
Well, there's some good things, some pros, some cons about speaking towards the end of the day, I think. I just want to say, can't put it into words. Perry and Dr. Darken, Eric, so great to see friendly faces, and it's kind of very unlikely that I'd be here today. It's very unlikely because I left NPS over 20 years ago under, I don't know, dubious circumstances. And I'm going to tell you a little bit about it. So one of the benefits of being here is I got to listen to a lot of awesome presentations. One of the cons of that is I started looking at my presentation, which Perry asked us to submit yesterday, and I realized, oh my gosh, wow, I wish I had changed that. I wish I changed that. So I'm not going to do too many caveats here, but I will say that I really liked what Mr. Hoffman did earlier on this morning. He said, look, you may want to zone out here. This is a kind of a soft presentation. This might be a good one to kind of just kick back a little bit. I'm going to tell you a story. We'll talk about some things that maybe you haven't thought about for a while. I'll give you the bottom line up front is that I think that if it's good for veterans' health care tomorrow, I think it's good for warfighters' health today. That's really what drives it. And the topics I'm talking about are a little bit flimsy. I'll tell you that right now. Yoga, okay, yeah, yoga, health, and virtual environments. Okay, not modeling the simulation so much, but virtual environments. So enough caveats. Let's see if I can. Which one? Right arrow. Oh, this one. I knew that was going to happen.
Not that it matters, but Barry went to West Point, so.
Uh-oh. Yeah, I was going to save that up to the last line. I was going to say something silly, depending on how bad this goes, about either go Army or beat Navy, but you beat me on that. Thanks. So here's a few. Talk a little bit about my yoga journey. That's going to be the story. And then come back to some things that I think are really interesting about considering and thinking about virtual environment technology applied to the health of our warfighters. And before I do, let me just ask you, what does this term mean to you? A self-defining memory. And I'm not going to pass the mic around, but I'd ask you to go inside for a minute and just say, have you in your military careers and your civilian careers, can you pinpoint a couple episodes, things in your life where you're like, you know what, that was a changing point for me. That defined my identity as a warfighter. That defined my identity as a simulation person. It defined my identity as a father, as a soldier, as a Marine. Do those things matter? Do they have a short-term, how long is their lifespan? Do those self-defining matters, do they determine how effective we see ourselves? And does that matter when we are conducting missions? So yeah, it's a homecoming for me to be here. And I have a chance to talk about what I'm personally passionate about. And I hope you find it worthwhile. And really seriously, I look around the room and I've heard all of your presentations and I'm just blown away. It's an esteemed group. I'm honored to be here. I saw Ranger Tabard 2, and it really made me think that what I'm going to talk about today is something that maybe y'all have figured out. And so I want to listen. I'm here. I would really like to make this interactive. So as things come up, please stop and let's discuss it, because I'm here to learn. I have some ideas and I'd really like to get your feedback about them. I didn't have that much time in the military. I didn't spend that much time here in Moose, but it's all very formative and very important in my life trajectory. And you know, when I left here, I didn't really expect to ever come back. And I'm back with a mission now, because I really think what I've learned in the last 21 years can benefit the health of our warfighters like today, really. So I'm passionate about it. So this is an operation most of you never heard of. Maybe you don't even know what happened. 1989, Operation Just Cause. It was a military operation down in Panama. I was involved with that. And that's where I had some self-defining memories happen. And I didn't realize how long they affected me until recently, actually. The first time I realized that something happened in Panama that was going to affect the rest of my life was 9 years later, 1998. I was at a VR conference and we were having a conversation about how we might be able to use virtual environments. This was 1998. How we might use virtual environments to help train soldiers who are kinetic. They're really good with kinetic missions, but maybe when it comes to civilians and they're not quite as adept, not quite as agile. So how can we use VEs to help them train those, what were maybe then secondary tasks? And again, I know DOD is mastered this stuff, but back then it was not quite there. And we thought, wow, virtual environments, maybe that could help. And that's where I met Dr. Rudy Darken. And we had a conversation, and it all of a sudden hit me that instead of building windsurf simulators, which I thought I was going to be doing, there's no market for that. So let's fall back on my Army experience. Is there a way to use virtual environments to help train tactical decision making? And that's where we went. And then 9/11 happened. And while all my comrades, my colleagues here had a new sense of mission, I dropped out. Literally, I was like, I can't do this anymore. And I couldn't explain why. And it was really clumsy. And Dr. Darken, Mike Zida there, they had a lot of graciousness for me because I didn't know what I was doing. And I left. And I always loved VR, but it wasn't in my heart to continue it in the military anymore. And I went off and I became a yoga teacher. Yeah, a full-time yoga teacher. That was a very financially lucrative move, I might tell you. Yeah. And in addition to becoming a full-fledged yogi, I mean, I had people telling me, why don't we take all your uniforms, all your stuff, and make a big bonfire, and we're gonna make a big situation out of this, and we celebrate you broke free of the military. And I was kind of all for it. I kind of distanced myself. I thought I was non-cooperating, what I thought to see as an evil entity. I know, and I know. That's why I was like, how can I ever come back here? I'll tell you why. It's because I thought, we can use yoga to help veterans. That's a good thing because it can help them to deal with trauma, it can help them heal their bodies. Yoga is a good thing for veterans. So I went down to my yoga boss, my general, my commander-in-chief of yoga. His name is Bikram Chowdhury. You may have heard the name and love to talk with you about that name here a little bit. But Bikram, and I said, hey, sir, let's build a yoga studio, a school for veterans. They can come and they can heal after they get out of the military. And he goes, get out of my office. He kicked me out. I had to go back. I keep going back. One day he's like, Peterson, stop thinking about veterans. I want you to build a yoga studio for active duty service members. And I was like, no, I'm out. You're crazy. That's not what I signed up for. I didn't sign up to help the military be better military. I signed up to help veterans heal after their military service. He knocked me aside the head, finally did not back up, and he said, no, wake up, and you need to start with service members. Don't worry about veterans. Get with service members. And he goes, matter of fact, I want you to go back to West Point and build a Bikram yoga studio at West Point. I thought, that is a crazy idea. That's never going to happen. But I said, yes, sir. And I made multiple trips to West Point, banged on I don't know how many doors. They again threw me out. They're like, what, yoga? You're crazy. And finally, I went to a reunion and I found that this idea that he had of stop non-cooperating, that's not yoga-like. And I was like, wow, I thought it was. He goes, no, you got to include, you got to go back to your roots. And when I went to my reunion, I was like, I love my classmates. I love the military. It's part of my heart. It's not felt right to push it away. And I came back into it and I was like, oh my gosh, this is really the true calling. This is really what I want to do. And some of my classmates actually supported the idea. They said, yeah, we'll help you. Let's build a studio at West Point. I was like, I can't believe this is happening. And I finally went back to Bikram and I said, I don't know how to do it. So I got some go ahead, but I don't know how to talk the language. And he goes, go back and study the Bhagavad Gita. Those of you that ever heard of it, it's a philosophical text about yoga philosophy. I was like, oh yeah, I read it. It told the warrior to go into combat. That's not what I'm about. No, the warrior should not go into combat. He said, read it again. And I went back and I was like, whoa, wait a minute. Yoga and the military ethos, they're not two separate things. They're a lot of overlap, almost the same thing. It's about doing what's right, no matter what you feel about it, doing what's right and under any conditions. And it's really about soldiering principles of service, honor, duty, and leadership. And it all clicked. And primarily there's three main benefits when I think about benefits for service members. Yoga principles support yoga, soldiering ethos, unstealable peace, how to practice comfort and discomfort. What does that mean? And that's when I think about Ranger School. And I say, wait a minute, Peterson, we don't need this. We already know how to do that. We do hard training. We do training that's real. We do real training. That's how we do it. Yeah, okay, I agree. And finally, there's a lot of physical, musculoskeletal benefits too. Here's Bikram. Talk about Bikram another time. But I'll tell you, if it wasn't for this person, I never would have woke up to, number one, I wouldn't be here because I would have still held a grudge against the military for some strange reason. And I never would have made the connection that the sooner a service member starts taking care of their health, whether it's yoga or something else, we're preempting all the other things that the VA is going to try to deal with downrange. Why are we not forward deploying it? Or if it's good, if we know it helps them at the end, why are we not doing it up front? Makes no sense. And he said, he's controversial. Yes. True. But he really cares about our service members. I mean, he sent me all around the world trying to do this. I failed. I'll tell you what happened. Here's what he says about unstealable peace. Through training the body with rigor and determination, is that a familiar concept? We also train the mind to concentrate. The discipline of practice helps turn the mind, which for many of us, me, this morning is my own worst enemy into your best friend. With your new mental strength, no one and nothing outside of you will ever be able to bother you, harm you, or disrupt your mental peace. As I tell my students in class all the time, let no one steal your peace. Now I think about that. It may be a little idealistic. It may be something we're already achieving in the military. Okay. But when I think about a force that has this mental mindset, they're able to follow through this concept. Is like, wow, that's unstoppable. That's power. That's powerful. Is there something that we can do? So 26 years after I left Panama, I'll tell you why I keep referencing Panama here in a minute. I finally got my audience about a room this size at West Point, and I made my strongest case I could about why we should build a Beacon studio at West Point, and it didn't go well. And I realized after that presentation, two things. Number one, the Army gets it. They get the power of yoga. They're going to use yoga. It's going to happen. But it's never going to happen with Bikram yoga. And there's some reasons why Bikram yoga wasn't going to be the path. And so I was dejected, and I was like, wow, what are we going to do? Until about a day ago, until recently. And I said, you know what? Here's an opportunity. How else can we cultivate, if unstealable peace is a noble goal, how can we cultivate it if we're not in a 105-degree, the Bikram yoga thing is done in a hot room. It's not as hot as some of you have operated in. I get it, but 105, 40% humidity, 90 minutes, it could get pretty grueling. And the idea is you go in there and you have to face yourself in the mirror and you have to suffer through this class. And sooner or later, you're going to hit a point where you say, I don't like myself, or I don't want to do this, or you hit that point where it gets under your skin. That's where the unstealable peace happens. So if we can't do it in a hot room on a ship, if we can't do it Bikram yoga in 90 minutes that way, how can we do it in virtual environments? I'm going to skip this slide, but just let you know, when preparing for this, I've thought unstealable peace. I think that's not a good word in the military culture. I'm not sure that really conveys. And I asked a couple of buddies to give me some ideas. I got to say, my friend Rocco Armando, he said, our mental armamentarium to focus in a crisis enhances mission success. I just think I'd never heard that word before. I love that. So if there's peace and if it's stealable, then who's the thief? Who are we trying to protect our peace from? Well, you think about it. Physical hardship, pain, mental distractions, emotional stress. When I think about it, add all that up, I'm like, it's the enemy. Isn't that what the enemy is trying to do? Aren't they trying to undermine our sense of mission, our sense of capacity? Aren't they trying to shake us up and steal our peace so that we break, so that we give up? I think so. So how can we use VEs to train for unstealable peace? Well, I think it's pretty close to what we're already doing. I mean, it's really, we've always thought that simulation provides a safe place to practice things that are kind of risky. Why don't we apply it to specifically psychological risk or individually psychological risk and practice developing comfort and discomfort, not in a hot room, but can we put people in virtual environments, immerse them in these situations that stress them out to the point where they breathe through that discomfort? I think we can. And even, yogis used to do crazy things. Lie on a bed of nails and have a motorcycle run over them. Have their buddies bury them for 2 hours and see if they can breathe on a full lungful of breath. Kind of crazy. But I bet you we get close to that kind of feel in a virtual environment. I bet we do it safely. I bet we could incrementally ratchet up to that. General Mattis made this quote when he was talking about, let's see, 7 minutes. Yeah. The value of studying deep history or studying history deeply. The study of history helps you refine the questions you have to ask yourself. What the heck does that mean? And why do we have to ask ourselves questions? What does this questioning thing have to do with? So I think it's wired into human beings. I think we want to make meaning of what's happened, especially in those self-defining moments. We want to understand why. We want to, you know what? One of Bikram's, he has a lot of one-liners. I'm going to give you one-liner right here. It says yoga is the only subject in the world. And he has a lot of exaggeration. Let me go back. Yoga is the only subject in the world where the object is not the subject. That means we're not doing yoga poses to study yoga poses. We're holding yoga poses so we can study ourselves and know ourselves better. And to me, that's what we're getting at here. So these senses that we make of self-defining moments, it may not meet the threshold of PTSD or moral injury, MST, but they may reach the threshold that makes me make a decision to leave NPS, makes me make a decision about my unit, about my career, about my identity as a professional warfighter. And that may have some long-term effects. And in essence, as Beacon would say, I've let my mind become my own worst enemy. When that happens, man, I'm in trouble. Because it's not about external anymore. I can't escape my own mind. And so we've got to figure out a way to make our minds our best friends. So when our sense making is negative and self-defeating, we're undermining our combat effectiveness. And we do it all the time. I do it. I mean, maybe you don't, but I know that I do it all the time. And I've been doing yoga for a long time, but it's still, I catch it a little bit quicker. Can we make sense about our self-defining memories in a way that helps us build empathy towards our soldier, our others, and towards ourselves? Is it possible? I mean, look, we use exposure therapy in VR all the time, and you know, with veterans to help them deal with trauma afterwards. Can we use it earlier as a way to preempt the negative mental processing? To help us rework through scenes, to help us find answers, to help us better understand ourselves so that we are, the next time faced with that situation like that, we are in a place of unstealable peace. After all, the history that really matters, and I'm not saying it, when you're studying history from General Mattis's perspective about being better leaders, that's a completely valid, very noble effort. Sometimes studying my own personal history is really, really important too, because that's what's going to get under my skin. That's the potential. When all the things line up in the wrong way and all of a sudden I'm paralyzed because all the external factors I couldn't control anymore have led to this point where, what do I do? So can't we predict that? Can't we dial that combination of environmental and social factors down to hit me right here now in training, in a simulation? I think we can. So just last week, I was on vacation. I took some time off. So I was on vacation. I went to Florida with my wife and I had lunch with my old commander from Panama. I'd not talked with him for 33 years. I talked to him last year. I reconnected with him last year. And it was a therapy session. And he, in 10 minutes, turned around some things that have been in my heart for 33 years, dragging me down, making me not trust myself. I hate to admit it. And at the end of it, I realized it's kind of been therapy for me. And then as I walked out, I go, oh my gosh, wait a minute. He said some things in there I'm not at liberty to repeat. It made me think he might still have some stuff going on about something that happened 33 years ago. That's not at the level of PTSD, but it's still something that's stuck in there and is still there, not resolved. Can't we use the technology to help our service members heal and to have the highest vitality and health possible today rather than waiting until sometime in the future? I think we can. About out of time, Perry. 2 minutes, I think.
Are there any questions for Barry?
Thank you.
Yeah, thank you for coming back and sharing that story. But being at Camp Pendleton, you know, they established the infantry immersion trainer. And so one of the things that they did there several years back, which we don't hear much about these days, is they did a bunch of research about PTSD and whether the combat infantry units that went through there, went to Iraq and Afghanistan and came back, whether or not that PTSD was more severe or less severe. They also had a gentleman there by the name of Dr. Skip Rizzo, who's from USC, ICT. So he focuses on virtual reality, and he actually would take the Marines and others who came back and were suffering from PTSD, and he put them in VR to expose them to those environments. What's interesting is that, you know, there was a big push for that 10, 15 years ago, but not so much today. I don't know why, but it's definitely something that I think there is value in it.
Certainly one of the things they wanted to get at was, can we help the veterans that are coming back to overcome the PTSD, the other things that they're going through, and ultimately to help them transition over into a civilian life. So
Yeah.
I appreciate this. I think it's a great topic, certainly something worth looking at. So thank you.
I appreciate your feedback. Thank you. Reminds me of that The Men That Stare at Goats movie. I don't want to reference that. Like, I don't know why that fizzled. Thank you.
Great, thank you very much.
Thanks,
Barry.
Barry.
That was excellent. Okay, our final speaker today is one of our earlier speakers. You're not seeing double or anything. Chris Darken is back. Before he gave some talks about the MOVES curriculum, now he's going to talk about some of his work trying to derive a tactically savvy AI. Thanks, Chris.
Okay. Thank you, Perry. Yeah, I don't know that this is particularly matches the session. It's not particularly interdisciplinary any more than the average MOVE stuff, which is always somewhat interdisciplinary. Thanks to Perry, I at least was able to talk today. Otherwise, because tomorrow we'll be busy with the curriculum review. So yeah, this is just a little update on work we've done, and let's see if I can give you figure out how to make things work here. Maybe not. Here we go. All right. Yeah, so let me talk about just catch up on where we were like a year ago. A year ago, one of the things I started talking about last year was how impressed I was, and I'm certainly not the only one, on the work that was done on computer games, right? By DeepMind, one of the real big AI units at Google. They worked on StarCraft, which to a lot of us looks a whole lot like a constructive simulation. They produced an AI that was 98th percentile in terms of human play. That would be wonderful if I had a military 98th percentile human AI for almost anything. Now, the reality is that what we've seen from the defense community overall over the last year has been very interesting. I was one of the technical evaluators for DARPA's combat program, and I've tried to keep up on a lot of the other programs as best I could. And what we're seeing is what I would want to call credible human performance on specific scenarios, which, you know, as we gain more experience with these systems, may hold up to continued human exposure, but I fear they won't. So that's why I want to talk about this idea of, you know, what's standing between us and what I would consider really tactically savvy AI. What I'm talking about here is that, and we saw this with the combat program, the performer goes, they build a pretty cool AI from the point of view of its design. They come and we do a test against a qualified human combat expert, and the human expert plays the AI a time, 2 times, 3 times, maybe even 4 times, and thinks the AI does pretty well. Okay, so that succeeds to a certain level. But I'm not confident that we're at the point where you could then say, oh, you like the AI, okay, take it home and put it to use. And I'm confident it's going to make you happy a week from now, a month from now, and so forth. That's what I mean when I say I fear it will not. I'm afraid that the AI will ultimately be found to be exploitable. When you play it enough times, you'll still see that there are just some chronic weaknesses in its approach to things that will ultimately mean that we need to take the AI up to a better level. So I showed a year ago here in MOVE some small proofs of principle that we've done over a couple generations of students using deep reinforcement learning. So that's reinforcement learning with a neural network under the hood. And what we showed there was kind of interesting. I thought it was important. Still, there's not a lot of examples where you can really prove that the behavior that the system is coming up with is optimal. It really finds the one, you know, unique, correct, or a member of the set of optimal behaviors. And I think our students have managed to do that, but the scenarios are very small, up to 5 units. So it's not something that's directly applicable to anyone's defense, applied defense problem. Whatever your problem is on your desk, you probably need to move more units than that. All right, so that's where we were. What I'm going to do here is just kind of go through a couple things, talk about some applied work. I didn't really think I'd have applied work to show here, but we kind of do. So I want to just lay it out there. I want to also talk about what obstacles I see being in the way of not just me and my little group, but also I think all of us, if you care about the AI field at all, and many of us are engaged at one level or another in that picture. What are the obstacles we have to overcome? I want to call out a few that concern me, and to the extent I can, talk about a little bit of current work and maybe a little more future work that I would like to see done. Doesn't have to be done by me, but I'd be very happy to do it. But if you go get to it before I do, well, I think that's just fine. Please come back and share with me. Okay. So this is the model that we've been working with. It's a very simple, very traditional tabletop type of board game, even though it's a purely digital product. It's something that I built personally. It is not really intended for applications. That's why I say I'm a little bit surprised that we're using it for that. It was really intended for AI research. So it's a game intended not for you to play, but for your AI to play and hopefully learn something. And then also because it is so simple, it's as friendly, I think, as we're going to get. I mean, the students will maybe tell you it's still not all that friendly, but it's about as friendly as we're going to get in terms of something you can give to a student and let them open the hood and do stuff with it. It's in Python, it runs fast. You can do human in the loop with it via a browser. That's what you see. That's what it looks like when the browser is actually rendering something, but often if it's just AI versus AI, you don't even see anything fun. It's just a blank screen and a cursor while you wait for the answer to come back. It's a, you go, I go kind of a model, red moves his forces, blue moves his forces, and every turn, every unit can either move or they can fire, so it's quite simple. The fire effects are deterministic. He uses the classic salvo model. And the units are nicely isolated from the rest of the system in terms of data tables. But this, I think any good simulation should be architected this way. And I think most are. And there's a bunch of data tables you have to specify, detection ranges and weapon engagement ranges and offensive versus defensive firepower that you see in the math of the salvo model. Mobility information, if you want defensive advantage from terrain, that needs to be in there too. But that's kind of it. You fill out some tables of numbers and you're good to go. All right, so we've done that. That's existed up, before this year. And now it's being applied in certain ways. So this is just an advertisement for Lieutenant John Allen's thesis work. This is part of the project on AI supported wargaming that we're doing together with Port Hueneme. And his particular application is kind of small scale freedom of navigation operations. So you have a little map like this, never mind the infantry symbols, those are ships on the water. We didn't get that far yet, but he's built up some scenarios that he likes and is in the process of training and evaluating AIs for that purpose, and he'll finish up that work in the summer. He's using the particular version, so it's at level, simple as it is already slowly spreading around DoD. So the version John is using is one that Army ERDIC Information Technology Lab is owns. So that's one thing that we've been working on. Please, I'm hoping you'll get a chance maybe to talk to John about that, and I'll leave the rest of the details to him. So there's something else that's going on, and this is really hot off the presses right at the moment, but also relating to the same work with Port Hueneme. So we send the students to a wargaming class here. We have a pretty good wargaming class, which Jeff Applegate teaches, and he had been asked why his war games were very old school. And he felt the need to put some technology into his war games this year. It's part of the same effort you heard Imre talk about, the project with Microsoft. I'm sure it was just inspired by the same conversations with the Navy brass. And so this was kind of an interesting opportunity because I'm funded to work in this area anyway. So, but the real ones, and so the way, first, let me just describe what this actually is. So what you see on top is the actual war game that the students, a team of students, was one move students in the mix, but mostly I think OR students developed. There's probably, I don't know, it's a pretty big team, 6, 8 of them, I'm not sure. But there you go. I mean, it's got a paper map. It's got some stand-ins for the different forces. Some of those markers label probably expeditionary advanced bases. Others label forces afloat there. And normally that's where it would begin and end. And they would come up with some rules for how they're going to do combat resolution. And that's traditionally the way things roll in Jeff Applegate's course. But for this project, he has an additional team of 3 of our MOVE students, which are it's the so-called MOVE's Tiger team there. And the way this is going to work, we'll see. The way it's planned to work, let me say it that way, is that whenever, so normally everything will resolve, you know, on the tabletop with whatever combat round. I suppose they'll roll some dice when the units encounter one another, however they want to do that. But if a battle occurs around an island, then they will, this team has pre-prepared maps of the important islands. And if a battle happens around one of those important islands, play stops at the top and they provide some data as to the forces to the Tiger team, and they now need to import that. They have to figure all that out on their own. I don't think that's quite trivial. So on the fly, they have to like populate their pre-existing map with whatever forces are actually going to fight here. And furthermore, they had to define 15 new unit types because we just had, you know, we just kind of had tanks and infantry and very few other things in the original model, and those are kind of all not there and replaced by mostly new force types. So it was interesting. Looks like it's been pretty successful so far. And this will be the way Jeff normally runs his course. He opens the war games up for public viewing. So if you happen to be around, I suppose, as long as you can get access to the base, you ought to be able to see the war game go down, and we'll see how well it goes down in practice. But it's I think it's pretty exciting. So yeah. So what's high speed about this? So it's actually adding an extra step. So let me just explain why this why they maybe deserves its name. So the battle actually is going to be fought out by AI. There. Now, it's not like the deep reinforcement learning AI that we're kind of known for with the folks who work with me. This is a scoring based AI. It's not machine learning based, mostly because we need it to be simple, because the timeline in a quarter course to go from start to finish and talk to a sponsor and get requirements, build and execute a war game. That's pretty intimidating, even when people are doing the simplest possible thing. And this is not the simplest possible thing. Yeah, so that's what we have right now. And my hope is if we see some interesting battles happen on the day when we actually run the war game, that I can maybe harvest some of those. And then in the summer course where I teach the advanced AI course, the students can then maybe go and try to throw some more advanced AI ideas. Surely the behaviors we see will not be perfect, and there will be plenty there for students to go in and dig into and try to improve. So we'll see. I'll stay tuned till next year. I'll tell you how it works out. Right, so I want to just talk real briefly about 3 obstacles and a little bit about how we are, or how I'd like to overcome them. One is, well, let me just dive into them because time is short. It's just 3. You won't get lost. So this is really a DoD-wide issue. I don't have a silver bullet to kill this beast with, but I just want to make sure we're all on the same page, or if not, let's discuss it. So AI is hot right now, and in particular AI for providing behaviors to war games and training exercises and other things is hot right now. But I hope we all realize that in order to do this, the AI methods absolutely require, the machine learning methods absolutely require that there be rigorous mechanics to the game. So there's hard and fast rules about what is allowed and what's not allowed. And also that there be an overall measure of effectiveness that is defined. That lets you actually say who won at the end of the day. Okay, now, in DoD overall, we are resistant to that kind of a mentality. I mean, mostly when we're doing wargaming or we're doing training, the point is not to determine a winner. Okay, that's a cultural thing. That's there for a good reason. Okay, but I want you to realize that let's put it this way, the military organization that cracks the code on how to provide rigorous mechanics and a summative MOE, which is meaningful to the AI, gets the prize of being able to use those AI techniques. And if you look at that and say, nah, we're not doing that, then you're not going to be able to leverage those AI techniques. I mean, that's where it's at. And I think at this point, none of us knows exactly what you're giving up if you decide, nah, it's not worth it for my organization, but you are giving up potentially something. And if the something turns out to be very valuable, maybe you should think about that in advance. Okay, so that's a soapbox speech, not really a solution, but I'll leave it there. Let me talk about the issue of tactical savvy. So what am I talking about here? I mean something very specific, actually. I mean this issue where we train up the AI and it's really good for one scenario that we trained on. Okay, that's true of typically what my students have done in their theses. It's true of what the DARPA performers that I've seen have done. And I think it's a real problem, right? So if I build an AI and I say, oh, it understands tactics, look at how great it is. And maybe it's really great at the one scenario, but I go and say, well, that's really cool. Let me just take some of your forces off and let's run it again. And you say, no. It was trained with this exact force distribution. You can't mess with it or who knows what'll happen. That to me is not tactically savvy AI. So we would like to see AI, and it is reasonable to expect an AI, I think, that goes above and beyond good performance in one scenario to good performance over a broad range of scenarios. We ought to be able to change the order of battle. We ought to be able to change the force distribution. We ought to be able to change the terrain. We ought to be able to change the mission and still get something reasonable. I mean, maybe it's going to degrade the AI to a certain extent if you give it a hard mission, but I would still like to see reasonable behavior. I don't think that's too big of an ask, but I want to make sure this is also in your sights in terms of problems that are on the horizon, because we're not even really trying to solve this at the moment, or so I think. Okay, but the way I'm trying to address it in my course actually is very similar to what Eric Johnson, when he gave his talk here, he was doing a similar thing. So maybe more people are dealing with this or not than I think. What I'm doing is going away from particular scenarios where here's my force, here's your force placed on the map as a starting position, and going more to scenario generators, and he used the same term, right? A scenario generator is some code that just can spit out as many different battles with different orders of battles, different missions, possibly different terrain. Just keep pressing the button and it'll just give you another valid battle to fight. And if we take that as the basis for our AI development, at least we'll know. If we don't have tactically savvy AI, so be it, but at least we'll know. At least we'll have the possibility of trying to get there. And this here, I mean, this is the simplest possible thing, but hey, my system is very simple, so I'm sorry about that. You see the tiny little maps here, but these are 3 that came from the same scenario generator when I press the button 3 times, right? You get the one up there. You see they're all kind of similar. There's all kind of clear terrain. I don't see any forests or anything going on there, but the gray hex is the city and its position varies, and the number of blue units is varying and the number of red units is varying, and certainly their position is varying. Okay, so if I can have an AI which does well on scenarios drawn from this distribution rather than one, now I think I'm really measuring something that's closer to my comfort level of saying that it's tactically savvy. That's what I mean. Okay, and last but not least, yeah, so the issue of search. So in search, what we mean in AI is looking for the solution. The AI, so the idea with these machine learning driven AIs is that you give it the environment, it explores in the environment, and it decides what its behavior is going to be, right? It picks what its behavior is going to be from what? From this vast space of possible behaviors, often called policies when you read AI literature, okay? And that is a search process. That's what we mean by search, okay? Now, we have a problem with search for this type of AI that I'm interested in. The spaces are huge and we're not doing a good job searching. Now, that's it in a nutshell. Okay, and you can kind of see some stats down below here. If you take the view that you're interested in how many different situations the AI has to make a call on, it's astronomical for war games, but it's not really all that different from chess and Go. It's still in the same kind of a range, okay? But that doesn't mean everything's still the same. What's vastly different with an AI, with a war game is how many situations you can get to in one move. That is very small for chess, a lot bigger for Go, which is what makes it so much harder. But for war games, it's crazy big, right? I mean, just think about it. You know, chess, you get to move one piece, right? You don't get to move all the pieces on your turn. Well, in war games, you get to move all the pieces, right? That's it in a nutshell. That's what's causing it. So we have this huge search problem. And then we have technologies which are using really weak sauce approaches to doing search. So, I mean, reinforcement learning by default does random things. That's how it learns. That's how it does its trial and error search. Well, when you do random things, I mean, literally just from drawing a distribution, first of all, there's nothing to rule out that you do literally the exact same thing more than one time, because you just don't remember the stuff that you've done. You can't make a list because the list would get too long, right? So you can literally repeat yourself exactly. And secondly, second bullet is that even when it doesn't repeat itself exactly, to a person looking at it, it can look exactly the same. I mean, to the computer, like one hex to the left, you know, if it does the exact same attack, but he moves the guy one hex to the left, that's different. That's a different Go. And you looking at that, it's like, well, that's the exact same Go. There's no material difference there. Okay, well, the computer doesn't respect our opinions. Okay, and I propose, which I'm claiming without proof here, but I think it's spending most of its time exploring options which are not significantly different from a human point of view. And last, and I think I have noted this in the past, because the AI algorithms are focused on maximizing this summative measure of effectiveness. They want to get that measure up as high as they can. Okay, whenever they see something that is looking to reduce their score, they're averse to it. And you find that when they explore in the future, they explore around those things, okay? And that means anything which is a good solution, but it's kind of a short-term pain that you endure to get a long-term benefit, they are very poor at finding those because they see the short-term pain right away and they learn, which is like what they're supposed to be doing, right? They learn, avoid that because it's painful. And then they don't ever see on the pot of gold on the other side, because they just don't get that far. It takes them incredibly long to get that far, more practically. So that's kind of where we are. Yeah, let me just mention another advertisement here. So if you get a chance to talk to Lieutenant Colonel Patrick Rood, so this is hierarchical reinforcement learning. Brian Wade also mentioned this in his talk. It's the subject of his thesis. Basically divide and conquer. Split the A up into a higher echelon and lower echelons, all solving smaller, more focused problems, right? You do lose something when you go to this kind of a framework. So it is, if it turns out that actually splitting one force and moving them to the far corners of the earth is a brilliant idea for some particular problem, you may not see that with this kind of an approach. But on the positive side, your searching is going to be much more focused on things that you probably as a person are going to think are a lot more sensible for the AI to be exploring. So we'll see. So this is still work in progress, should finish at the end of the summer. And the last thing I'll just say is that there's a bunch of things here I like to talk about for future work, but I just want you to realize, because I'm not sure everyone does, the amount of flexibility that's there in these algorithms is stupendous. And a lot of times when you're getting bad results, it's on you because you just haven't found a creative enough way to redefine the problem so the AI has a chance of tackling it. Okay, so when you apply reinforcement learning to improve an AI, you don't have to have it solve the entire problem. It doesn't have to make every move in the war game. You know, a lot of times we have a lot of AI tools that work very well that are not machine learning based. We've done it for years here in Moves and produced some pretty impressive AIs. You can take one of those and just take the 1, 2, 3 types of decision where, you know, the canned AI really is not, you know, you realize it's kind of weak sauce for those particular things. The reinforcement learner could be brought in just to deal with those actions. That works beautifully within the framework of reinforcement learning and game solving as well. Yeah, that's something I hope to leverage more during the next year. It's one of my resolutions for next research year. And that is all I wanted to say. If there's time, I'll take the question, but if not, I'll be around. So we should have a chance to discuss. If you're working in the field or just curious about stuff, please come bug me.
It's tangential. Why did you call it the atlatl?
So do you know what an atlatl is? So an atlatl is a spear checker.
Oh, I know what it is.
You know what it is? Okay. Well, there's all kinds of, there's an atlatl competition every year. So I mean,
Yeah.
people really know they're like competitive atlatlists. Yeah. So it's for the rest of us. It's a spear thrower that just uses leverage, and it's a stick that kind of, if you have a spear, rather than grabbing it yourself, you grab the atlatl, it hooks on the end of the spear, and you get leverage when you throw it. And your opponent, who may be using a crude shield to protect from your spears, now finds that your spears actually just go right through, which will certainly surprise him. So the reason I'm getting to your question.
Go ahead.
The reason is that it's a crude but effective tool. That's my rationale for using.
Well, I spent a lot of time with it, and I as an instructional designer, my doctorate's in instructional design, I was exploring how do you train somebody to use the atlatl, because it's a fairly sophisticated device. And one of the areas that I found really kind of interesting to explore, and this is where it gets tangential to AI, was if you kind of created the story of the father and the son, and the father's taking the son out and all of that dynamics, and then you kind of build in stories. And as you put more stories into it, as you made it more human, they actually got better at learning it. And as somebody who grew up with board games, the hexagonal board games, my favorite thing to do was the after action report. I didn't know that's what it was at the time, but we would spend hours talking about these games. And so I'd be curious, like storytelling, and do you explore that at all? Because you mentioned earlier Bloom's taxonomy, but you kind of stuck with the cognitive. Do you get into the affective at all?
I have not in my research, but storytelling is actually this is not really a very direct answer to your question, but it's kind of amazing. Some of the stuff that the DARPA performers were doing, they would take they would produce an after action review in words to then be able to use language technology to see whether the behavior was doctrinal for the opponent that they were in the program I was involved with. They were trying to produce Russian behavior. So was it doctrinally Russian? I thought that was pretty interesting. So the vector to that is through a literal story where they're describing in words what happened in the simulation.
Yeah, and just to sum up, we're familiar with Patrick Wilson, AI, I assume.
Yeah.
He made the argument that what makes us humans that we tell stories. And that's the thing that defines us.
Well, if you're,
I was quite amused by that one.
Yeah. Okay. Thank you for that. And it's exciting times if you're interested in natural language stuff. Those of you who follow OpenAI and the GPT-3 model, those are things to Google if you're interested in natural language but haven't heard of those things. It's pretty amazing what they're doing these days.
Well, I think that's time for the day. So thank you very much, Chris. Appreciate it. Thank you for attending day 1 of the Moves Open House. If you enjoyed this video, please see the comments below for links to the videos from day 2 and day 3 of the Moves Open House. Or you can check out the website listed on the screen to get all the information about the 2022 Moves Open House. Thank you.